We have 800, 900, 1,000, 1,200. Yep, they are coming in.
All right.
TV testing.
Let me know when it settles down.
All right, yeah, it's still climbing.
Yeah, there's somebody that's already got their hand up asking a question.
Chats are starting to roll in too.
Yeah, what do you have now, Corey?
We got a little bit of a loop here. Somebody, I'm gonna have to mute everybody again. 1,500.
Settling down, Corey?
Still climbing. We're at 1,600 and climbing. I'd say we're pretty good. We're about 1620, 1630.
Okay. All right. Well,
You
let's
guys copy N6 TV.
Yes, we copy you, Bob. All right. So let's get started. And welcome to Contest University online here via Zoom. And thanks very much to everyone for showing up. In some parts of the world, it's evening. Some parts of the world, it's very early in the morning. And we have 3,000 signed up for today. So let's see if we can have some fun with this as we go along. And you see the chat is already moving. I want to thank Corey, W3CDG, and Terry, KMNJ, for all their hard work to make this happen. And also all the professors that you will hear from today, as well as all the Contest University professors that we've had throughout the years. I want to thank you for all your hard work to put your presentations together. And the moderators today, the first set of moderators is Scott, N3RA, and John, K1AR. They will be taking your questions from the chat, and they will present them to the speakers, the presenters, via audio, and the speaker will respond. And so thanks very much to the moderators. Also, thanks to the Contest University Board, and as well as Michael, WHCI, for his support from Hamvention. And we couldn't do it without Ray Novak from ICOM America, and Doug Grant, K1DG, and K1AR. That rounds out the board. Over 500 participants today out of the 3,000 come from outside of the United States. This is truly a global event. And we welcome all of the DX that is attending here today. Contest University 2020 is being recorded, so you will be able to view, if you missed something, you will be able to view this again. And Terry, Kate, MNJ has posted all of the presentations up on the Contest University website. So today is all about sharing, having fun, and being active. Get on the air. With that, I'd like to turn it over to Ray Novak, N9JA National Sales Manager for ICOM America.
Well, thank you everybody for attending. And while everybody else is from home, I'm using the background from the Crown Plaza, so it feels kind of natural for myself. Normally I'm running, trying to get out of here to go finish setting up our booth, but a lot more relaxed environment. And want to thank everybody for attending, as well as everybody else that has participated to make this happen. And just looking at the DX from the webinar chat room is just incredible. So thank you everybody for attending. And again, thank you for our presenters and moderators and everybody else.
Thank you, Ray.
Thank you, Tim.
Now let's go to the home of Hamvention and the official spokesperson for the Dayton Amateur Radio Association, Mr. Michael Coulter, WHCI.
Hey, good morning, everybody. Thank you, Tim, Terry, Corey, and the entire host of the astonishing professors for Contest University. This is truly an amazing event. Normally, I'd be welcoming you all to Hamvention, but in a way I am. on behalf of all our 750 plus Hamvention volunteers, thank you for your continued support of our great gathering. I hope that many of you who are signed up are folks who usually are so busy at Hamvention and with Hamvention activities that you have been able to attend, and now you're going to be able to see a really world-class presentation. And the amazing thing is, this year is free. I want to let you know that we are certainly already planning our gathering for next year. Hamvention and Dara is still healthy. We're doing fine. And I hope everyone there is healthy. And I do want to mention we have a QSO party Saturday from 8 a.m. to 8 p.m. on most all the bands, CW and single sideband or whatever you want to use. And simply CQ Hamvention. More details on that at our website, and Tim will probably have more details on that. So on behalf of myself and all our volunteers and all of you who are as important to Hamvention as our volunteers. I mean, without you all, the gathering wouldn't happen. And I hope you have a great day. Thank you very much for allowing me to say a few words. And you know, I want to leave you with this, that we're hams, and we take a slamming and we keep on hamming. 73, back to you, Tim.
Thank you, Michael. This is a sad week for us. We wish we were coming to see you in Xenia, but we'll be back next year stronger than ever. And we appreciate your support as representing the over 700 volunteers that take care of our beloved Hamvention. And so I'm very thankful that we have this tool, Zoom, and the internet to make all this happen. And again, I can't thank the professors and the moderators so much for all your hard work today. Our first moderators today is Scott N3RA and John K1AR, and they will be looking through the chat and then presenting the questions to the professor. And our first professor, I'm sitting here at K3LR here this morning. This is the 10-meter station at K3LR, by the way. And I want to tell you a little bit about our first professor today. Frank's contesting career began when he was 12 years old at a field day in Rhode Island. And then when he was 17 years old, he finished first place in the USA in the 1964 ARRL DXCW contest in the low power category. In 1968, he was the leader of the W3LPL field day that finished in first place in the 4A category in Rhode Island. Immediately after college, U.S. Air Force Second Lieutenant Frank Donovan's first military assignment was in the Washington, D.C. area, where he worked under PVRC member W3GN and with his multi mentor, Tom Peruzzi, W4BVV. Frank finished first place USA single operator in 4 CQ Worldwide CW contests and 4 ARRL CWDX contests, and that was during 1973 to 1978. His first multi experience was with the world high scoring 1974 PJ9JT CQ Worldwide CW team. W3LPL multi team started 43 years ago. That's incredible. With a small entry in the 1977 ARRL phone contest. 5 years later, 2 incredible long nights of 10-meter JA runs unexpectedly produced his team's first USA multi win in the 1982 ARRL Phone DX contest, the same year that renowned multi competitor Jim Lawson, W2PV, became a silent key. W3LPL multi teams have competed in or completed more than 1 million QSOs and have achieved more than 50 first-place USA finishes out of more than 150 multi-multi entries in the CQ Worldwide and ARLDX contests. Frank was inducted into the prestigious CQ Contest Hall of Fame in 1999 and is a regular presenter at Contest University. Normally he would do 3 or 4 presentations, today being Thursday at Contest University. He retired 9 years ago as a chief engineer at General Dynamics Corporation after a 45-year career in electronics and systems engineering. It gives me great pleasure to introduce my fellow multi-multi competitor, W3LPL, Frank Donovan. Frank, the floor is yours. Please unmute.
Okay, Tim, thank you very much. And it's been a great pleasure to be a competitor with the K3LR team for all these years, and I hope many more to come. So let me see if I can get my screen shared here. Okay, so I guess we're ready to roll. So I'll just mention what this photograph is. This is not me right now. This is one of my favorite places in the world. This photograph is taken on the Irish Sea coast of Ireland, a few miles east of Dublin Airport. That lobster there had been caught just a few hours before. Okay, we're going to cover this very broad topic very quickly in about 40 minutes and hopefully cover some very interesting questions at the end. We're going to cover a wide range of possible antenna choices, from small antennas that most anybody can fit and gain some benefit from that, all the way to some of the highest performance antennas that only a few of us have ever tried, and also a technique for evaluating the performance of your receiving antenna system in place. So the most important part of the slide, and I will not attempt to read every slide. There's a lot of detail here, and you can read the detail at your leisure. But the most important aspect of this slide is that receiving antennas are especially valuable on 160 and 80 meters, but of course these same techniques in most cases can be used on 40 meters or even higher in frequency. All of the dimensions that are mentioned in this presentation are for 160 meters. And I think most people can figure out how to divide by 2 to make those dimensions work on 80. So I won't mention how to scale these at any other point in the presentation. So why receiving antennas? Well, it's easier to make them perform better than transmitting antennas on the low bands. The cost is low, the footprint is smaller, you don't need full-size vertical antennas, so with no reason with verticals in a receiving antenna system to go any higher than 25 feet, and you can go less than that. You can get good useful directivity in as little as 650 square feet. And if you have 3/4 of an acre or more available for receiving antenna, believe it or not, you can get directivity equivalent to a 5-element Yagi on less than 3/4 of an acre. Receiving antennas are also very helpful for diversity reception if you have a receiver capable of that, but you do need sufficient spacing between the antennas, and that usually means on 160 meters, at least 500 feet, preferably 1,000 feet. There's a widely used measure of the performance of receiving antennas. It was developed by WHAI. You can read about it on the URL shown at the bottom of the page here. But let me caution you that the RDF is for a receiving antenna in a perfect environment, and that will be pretty rare. In a lot of cases, there'll be a nearby transmitting antenna, and Re-radiation from towers, other antennas, nearby power lines within about 1,000 feet can degrade the actual RDF that can be achieved. And that's especially the case for high-performance RDF antennas. RDF is not a perfect measure of receiving antenna performance. It's a measure of the forward gain of a receiving antenna at the desired azimuth and elevation angle to the average gain over the entire hemisphere above your head. And EasyNet computes that for any antenna you want to evaluate. Now here's where the issue is with RDF, and that is anyone who operates, especially on 160 meters, knows that the noise source that's a problem is usually from a storm or maybe from a local noise source. So it doesn't come from the entire hemisphere, it comes from a part of that hemisphere. So that this RDF is kind of for a theoretical situation that is really what it is that we're trying to achieve. And that's why it's especially valuable if you have more than one receiving antenna to select the one that happens to have the deepest null in the direction of the offending noise source. And things like the DX Engineering NCC2 help you steer the null and an antenna to the offending direction, rather than relying on just the theoretical RDF capability of an antenna to achieve that for you. So just a quick overview of the relative performance of some antennas here, and I will not discuss the details of each and every one. We'll get into that in just a moment. Kind of the smallest antenna that's popularly used is the so-called magnetic loop, close to the ground, and I'll discuss that in further detail later. Perhaps the next most popular one of the small antennas is the BOG, which, as you can see, is typically 225 feet long on 160 meters. Its primary advantage is stealth, or a relatively small length compared to a full-length beverage. And then there's a wide variety of small terminated loops that are popular. The K9AY array is the smallest of those, requiring very little space, and the shared apex loop array is somewhat larger and offers somewhat better performance. Not as widely used, but we'll talk about it in a bit, is two-phase short verticals with 60 to 80 foot spacing, and ideally connected to a DX Engineering NCC2 phasing controller. This allows you to steer the deep null that you can achieve with two of these verticals in the offending direction. So even though two-phase short verticals produce, quote, only 9 dB of RDF, its utility can be much greater if you use it with NCC2 because you can steer the null. Now, getting into some of the higher performance antennas, perhaps the most popular of all of these antennas is the 500 to 600 foot beverage. They're typically mounted about 7 feet high, just so they're not a hazard to human beings and animals like deer. It's not very practical to place them lower than that unless they're in a fenced-in lot where animals and human beings are not present. Another relatively small and remarkably high performance antenna is a 4-square receiving array. We'll discuss that in some detail. And then at the very high performance end, you can achieve this very high RDF with a fairly small antenna, the 200 foot diameter 8-circle array with short verticals. That can be used either with active verticals or passive verticals, either one, doesn't matter. And then I'm only aware of a few of these 14 dB RDF antenna systems. In fact, I'm actually only aware of one, the broadside end fire array of 800 foot beverages. That requires 8 acres. So let's look at the smallest of the popular antennas. The 8-foot diameter magnetic loop This is a very specialized antenna, but it can be very, very helpful for those who are in urban or suburban areas where they need to null out a single source of RFI. The small diameter magnetic loop has a remarkably deep null, and it can be steered in the direction of that single offending source and null it right out. Now, there's a trade-off to be made here between null depth and sensitivity. Turns out that the smaller the loop, the better the depth of that null, and the larger the diameter of the loop, the better the sensitivity of the antenna. So there's a trade-off to be made there, and that's kind of up to the end user. Much more effective in terms of receiving antennas, except for that special case of nulling a single source, is the terminated small loop. And there are at least 5 of those that are popular. They all have similar performance. And the final one in this category of small antennas, there aren't very many of these, is the mechanically rotatable flag antenna. And the highest performance of those I'll discuss at the end of the presentation. It turns out also small antennas offer an advantage if your RFI sources are close to the antenna, because small antennas develop their directivity much closer to the antenna than large antennas. Large antennas could place the RFI source within the near field of the antenna where the directivity hasn't yet been developed. So if your RFI source is very close by, these small antennas could be a better choice. Well, these ideas are not new. They were developed for these. Most of these concepts for these small receiving antennas were developed during World War I, during a crisis. America had just gotten into World War I. Our only means of communication with our troops in Europe was via submarine telegraph cable. There was very great concern that those cables would be cut. We knew the German submarines were equipped to cut cables. So there was a crash effort to develop transatlantic communications capability. And the only technology available operated at VLF frequencies around 50 kilohertz. So shown in this photograph is what we would call a pair of broad-sized small loops. But in this case, it's about 30 feet tall and about 1,000 feet long, but that scales to the small loops that we use at 160 meters. So these concepts are not new at all. They were well developed by the time World War I came to an end. And one way to get better performance out of small loops is to array them as a pair. But you know, it's not a very popular thing to do, because usually if you can array 2 small loops, you have enough space to put up more effective antennas. But this can be done. Probably the most popular of those is the pair of K9AY loops. But what those really are is 2 independent loops that you could switch, or the shared apex loop array, which is a very popular and very effective antenna. A few people have developed broadside small loops, the VE3DO loops, but there aren't very many of those, and I don't know of anyone who's using the mechanically rotatable Waller flag, but that's an attractive antenna if you need very good performance out of a small loop antenna. So let's talk about the BOGs, and it's Beverage on Ground is a popular name, but the last thing you want to do is to actually place the beverage on ground on the surface of the ground, because the performance of the antenna degrades very badly if the wire is directly on the surface of the ground. So you typically, what you do is you place it over a grassy field where the grass will keep the wire a few inches above the ground, and then usually you have to go back and raise the wire to the top of the grass a couple of times a year. But that's a pretty effective way to do it. But you don't want the wire laying directly on the ground, as the name of this antenna implies. You can also build a bidirectional BOG in this with the same techniques that have been used for a long time with full-size beverage antennas. Another thing that can be done with a BOG is you can stagger a pair of them to get steerable nulls. And I've mentioned that steerable nulls offer an advantage over the apparent lower RDF of a small antenna. And also you can broadside space a pair of those. It takes a lot of space. Really, kind of the only application of this is where you want to have stealth, but you've got a lot of property available. So beverages are probably the most popular of the high performance antennas. And for many years, I've used 580-foot beverages, and I've had great success with them. And I still have 3 of them, and I'll show the details of my antenna system a little bit later. But I find them to be helpful because there are some situations, and it helps to be able to switch receiving antennas quickly, where the null of the 580-foot beverage is in a more favorable position than the null of the big 8-circle receiving array that I use. So it's helpful to be able to switch among antennas. Some beverage array users have installed staggered beverages. This technique was originally developed way back in the 1920s, but some hams are using that and with good effect. And again, the biggest advantage of a staggered pair of beverages is to put those into a variable phase controller, the DX Engineering NCC2. And broadside beverages also work quite well. You need about 400 feet of broadside spacing to get the performance of that. So, when did the beverage begin? Well, in the ham radio environment, it began in 1921 during the successful transatlantic tests. And this is an image that shows the beverage on the shoreline, sandy shoreline of Scotland. And this antenna was installed by Paul Godley, 2ZE, on the expedition to Scotland, which was a huge success. And the 100th anniversary of that is coming up next year, and I'm sure there'll be a number of events commemorating this breakthrough for ham radio. K1PBW reintroduced the beverage to DXers more than 50 years ago. So let's take a look at arrays of short verticals. There are 2 classes of short verticals. One, the high impedance verticals popularized by High-Z. These are especially valuable if you want to have multi-band operation, or if you, for some reason, cannot put down radials. So the High-Z antenna does not require radials. And the alternative, and any antenna that uses high impedance verticals, you can substitute low impedance verticals. They are a monoband antenna only. So if you put one up that's optimized for 160, its performance on 80 will be significantly degraded. So what's the advantage of the low impedance vertical? The advantage is it has very few parts and no active components. So they're very easy to troubleshoot and repair. There's hardly anything that can go wrong. The parts count is very low, and anyone who's ever done any reliability engineering knows that parts count is the key. Very easy to troubleshoot. We talk about radials. Now, it's totally unnecessary in an array of short verticals to have a massive field of radials. All you need is enough radials to keep the base impedance of the vertical stable. And for a typical installation of a low impedance vertical that's on 160 meters, about 8 70-foot verticals or 6 radials, or 16 35-foot radials at the base of each vertical. The passive low impedance vertical typically has 4 25-foot umbrella wires on it, so that reduces the required height of the vertical to 25 feet. performance is excellent. If necessary, you could use it at 35-foot verticals with no umbrella wires, if that is a problem for you. So let's look at a little bit more detail at the magnetic loop. As I mentioned before, this is a specialized antenna. Its purpose in life is to null a single nearby RFI source. That source must be vertically polarized, but the good news is that almost all local RFI is vertically polarized, and it must be received via ground wave. These antennas are also superb for locating RFI, especially on the lower bands. And the very small loops have much deeper nulls. So typically a portable small loop antenna, which is very easy to make yourself. You can build one of these in a couple of hours. They're typically only 2 or 3 feet in diameter, and it has a very, very deep null that allows you to quite precisely locate an RFI source. And you can easily move these from one location to another to help triangulate that source. So what's the beam width of one of these small loops is about 150 degrees. So it's nearly omnidirectional, 150 degrees on each side of the loop. So that's 300 degrees out of 360. And its unique characteristic is that deep null. Now, it turns out for horizontal polarization, one of these small loops is nearly omnidirectional. And the way you suppress the horizontally polarized signals that you don't want is to place the small loop antenna close to the ground. Typically just a few feet. You can raise that a little bit, maybe it's to 7 or 8 feet, but the higher you go, the more that null is reduced by signals that might be received by in horizontal polarization. All of these small loop antennas have low signal levels, so it's kind of a bit counterintuitive, but what you need is a low noise figure preamplifier with high gain in order to get the optimum performance from these very small antennas. And ideally, the preamp should be located right at the feed point of the antenna. You also don't want to degrade the performance of these antennas by signals that leak in either from the power cables or from the coaxial feed line. So here's a photograph of one of these small antennas. This is a good compromise between null depth and sensitivity, 8 feet in diameter. You can build one of these in an afternoon. And this will allow you to get rid of that single interfering source. So electrically steerable arrays, the K9A loops are very popular. Typically, these are built as a pair of loops, and the footprint for this antenna is only 25 feet by 25 feet and 25 feet tall. The shared apex loop is also very popular. It covers 8 directions. 3 dB beam width is much narrower than the K9AY loop, and the RDF is similar. And as I mentioned earlier, all of these loops are low signal level loops, and being very careful to choke unwanted common mode signals is key to achieving performance from these antennas. So this is an image of the base of a pair of K9AY loops. It's only 625 square feet. Almost all hams, except maybe in an urban location, can find space for this simple and relatively effective antenna. Its beam width is pretty broad, 120 degrees. Its front to back ratio can be very good if it's properly installed. There's a photograph of the very popular array solution shared apex loop. Has only 75 degree 3 dB beam width, so it's significantly better than the K9AY loop, and it's steerable in 8 directions. And requires a pretty small space. These are very popular with the expeditions. 50 feet by 50 feet, and it's only 25 feet high. Not very many of these antennas have ever been built. The vertical Waller flag array. It's for most locations, it's about 14 feet tall and 30 feet long and installed on a short tower with a rotator. Now, popular with some of the very serious 160-meter DXers. For example, my friend Wally, W3LPL, has one of these antennas on a 200-foot tower. And he's been able to work stations on 160 meters that no one else on the East Coast even heard a trace of. But it's a pretty specialized antenna, and a horizontally polarized Waller flag needs to be no less than 100 feet and preferably much taller than that. Undoubtedly the most popular receiving antenna. This was developed at the end of World War I and patented in 1921. And most hams install these on 160 meters with a length of around 500 feet. There's benefit to going longer, but 500 feet is adequate. And K9LA developed this little chart that shows some of the performance characteristics. This happens to be a 3-foot high beverage with lengths from 150 to 1150 feet. In the red graphic, you can show how the front to back ratio varies with length. But don't get too carried away with this red line, because what it's showing is exactly front to back. That is the ratio of the signal directly in front of the antenna compared to a received signal exactly in the back. So what's happening here as this red line moves from a front to back ratio of 24 dB down to 8 dB is that the location of that null is changing as the length of the antenna changes. But you'll notice in the in the blue line, that as you lengthen the beverage antenna, its RDF steadily increases. There's really no need to go beyond 900 feet in most cases, and the range around 550 feet, where the null is off the back, is a very, very popular choice. So the beverage on ground, you'll notice in this photograph, the beverage is not on the ground. It's a couple of inches high, and this is how they should be installed, or they can be laid on top of tall grass. But you'll be out there pulling the wire out of the grass a couple times a year. 225 feet is the typical choice. The beam width of this antenna is 70 to 100 degrees, so it's similar to a short beverage that's higher. But if you need stealth, this is a very, very good choice. The bidirectional beverage is not a new idea. It was patented in 1922. Switchable in 2 directions. You can use either 1 feed line or 2. And I always encourage people who install these antennas to put in 2 feed lines and feed it into a DX Engineering NCC2. And then you can steer the null, which gives you a significant advantage over a bidirectional beverage with a single feed line. Here's the radiation pattern. Friends at High Z created these graphics and allowed me to present them in these presentations. So this is what the 3-dimensional pattern of a 600-foot beverage looks like. You notice its disadvantage is that it has some high angle radiation off the top. This is characteristic of any antennas other than verticals. So the staggered array, I remember it was presented originally, we thought, at an antenna forum in Dayton about 20 years ago, but it turns out it was patented in 1927. And here it is. You can achieve 11 dB RDF. The big advantage of this antenna is when you feed the 2 staggered beverages into an NCC2 controller, where you could steer the location of that null rather than just to be dependent on where it happens to be. The only antenna of this type that I know that's ever been built by a ham it's been done by WHAI. But it was originally developed for the first transatlantic telephone system. So, we always think about transatlantic telephone as being either by satellite or submarine fiber optic cable. Well, we didn't have satellites or submarine fiber optic cable or submarine telephone cable until much later than 1927. So that first transatlantic telephone circuit was VLF radio, and noise was a big problem, and this antenna was developed for the receiving site, which was located exactly where Interstate 95 crosses from Maine into Canada. So let's look at some of the high performance antennas. The high impedance verticals, typically 20 feet high, no umbrella wires, no radials. 80-foot spacing of these antennas is ideal for 160 meters. They require a high impedance input amplifier at each vertical, and these antennas must be in an environment where, for any phased antenna using these, where the verticals see almost exactly the same environment. So you can't have one of those verticals located, let's say, right next to a tree, and then the other vertical in the array located in the open. Otherwise, the performance is degraded. And this is the pattern of a two-element array. Very, very effective antenna with two of these elements feeding into an NCC2 where you can steer the location of that null. An antenna that's becoming very popular, and this is a photograph taken by OZ1RDP of his array. 4-square receiving antenna. Typically, these are installed 80 feet on the side. It's only 20 feet high. This is an antenna that's easy to install for the season and take it down for the summer. 100-degree 3 dB beam width. All the parts to do this available from our friends at DX Engineering. And this is what the radiation pattern of that antenna looks like, again, provided by High-Z. Very high performance implementation of the High-Z array is the 8-circle. A tremendous amount of engineering effort went into the development of this antenna, a lot of experimentation. It phases all 8 verticals. All of them are in use. The phasing is 106 degrees. You can implement this antenna with low impedance verticals if that's your preference. So that improves the reliability of the array somewhat using low impedance antennas without all of the parts count of the high impedance amplifiers, or you can implement it with the high impedance verticals as well. And this is what the radiation pattern of that 200-foot diameter 8-circle looks like. It's very, very clean. It's actually cleaner than its bigger cousin that I'll show you in just a moment. Another excellent antenna, and it requires only 1/4 of an acre, is the YCCC tri-band receiving array. It covers, as it mentions here, 3 bands. There are 3 configurations that are popular: the 3-element array, which covers 2 directions, the 5-element array that covers 4 directions, or the 9-element array that covers 8 directions. The performance of this antenna does not change with the number of elements. It's about 12 dB RDF, more or less, but it just covers more directions. And the array diameter is 120 feet, no radials, no umbrella wires. You have a high impedance amplifier at the base of each antenna. So low impedance verticals. So what's the difference here? The high impedance verticals have a high impedance amplifier at the base of each antenna. The low impedance verticals are fed directly with coaxial cable through a tiny matching unit. Typically consists of a resistor and an inductor, all of which can be placed in a small container of just a few cubic inches. 4 25-foot umbrella wires are attached to the top of each vertical, and they run out to a stake in the ground, or in my case, and I think in most cases, you connect them to the top of a fence post so that the local wildlife doesn't get tangled up in the antenna. The element spacing of these low impedance verticals can be as little as 65 feet on 160 meters. But the disadvantage of the small spacing is that it's more difficult to achieve stable performance. So a lot of us prefer 80 feet or more. No amplifiers required. Very, very easy to build your own antennas. They're very non-critical, and you don't have any active components to maintain out in the field. So a 4 square of these passive antennas works just as well as the high Z version, and it's really easy to build. So this is a photograph of one of my passive verticals. It's 25 feet tall. You can see the umbrella wires in the photograph that run from the top of the vertical to 4 fence posts. And they're connected to fence posts only to keep the wires and the support ropes away from the deer. And any particular night, there'll be dozens and dozens of deer in the vicinity of this antenna. And I've never yet had one tangled up into it. And the radials that I use with these verticals are just randomly scattered on the ground. Their only purpose in life is to provide feed point stability. So it's not necessary at all for them to be equally distributed all around the array. They're just randomly scattered around, and it doesn't make any difference. Every year I have to remove this antenna system so that my neighbor who owns this land can mow it. And when I remove those radials, they are really randomly scattered around, but it just doesn't matter. And this is the pattern of this large 350-foot diameter 8-circle array. And you can see that it's not as clean as the 200-foot diameter array. But the advantage of this big array is that it's really simple, and it's really, really easy to maintain or to troubleshoot. So let's take a quick look at the antenna system that I've settled on at my QTH. All of these antennas are located on a 4-acre lot that is 1,000 feet away from my transmit antennas. And it consists of 2 8-circle arrays. The circle with the black dots shows the relative location of 8 24-foot tall umbrella verticals, the passive verticals. And then located inside of this 160-meter array is an 8-element 80-meter array, shown in red. And those are in a 175-foot diameter circle. There's absolutely no evidence of any interaction between the 160-meter array and the 80-meter array. Not surprising, because these antennas are so short that they have 50 ohm resistors in series to the feed point to match them to the coaxial cable. So there's essentially no mutual impedance between them. So it's not surprising that there's no evidence of interaction. And then located within the array, passing directly through the center of the array, are 3 beverage antennas. Each of these are roughly 580 feet long, one to the northeast, one to the west, and one to the south. And again, there's absolutely no evidence of any interaction between the beverages themselves or between the 2 8-circle antennas and the 3 beverages that pass through the middle of them. So how can you evaluate the performance of these antennas? Well, anybody that's listened on the ham bands now knows there's a tremendous amount of FT8 activity. And if you set up a pair of WSJTX programs running simultaneously on 2 different arrays, you can evaluate in real time the relative performance of this antenna and an alternative antenna. For example, you could run one instance of WSJTX on your transmitting antenna and another instance of WSJTX on your favorite receiving antenna, and you can evaluate in real time what's going on between these 2 antennas, and you can tell whether your receiving antenna is doing anything at all. So I've mentioned this several times. We tend to talk about RDF for receiving antenna performance, but RDF has it's a theoretical measure, and it deals with the performance of an antenna relative to noise coming from the entire hemisphere. And the reality on the low bands is that typically the noise that perhaps comes from a thunderstorm is located in a tiny part of that hemisphere. So this device allows you to really optimize the performance of your receiving antennas. And my last slide, if you have the opportunity to place two good performing receiving antennas at least 500 feet apart, preferably 1,000 feet apart, and feed a pair of phase locked receivers, such as in the K3S, the diversity performance is quite remarkable and well worth the effort to do it. What I use in my station to achieve this is we receive on one of the receivers using my transmit 4-square array for receiving, of course, and the other input to the receiver is either one of the beverages or one of the W8JI 8-circle arrays. So here we are back on the coast of Ireland, and it's over to K1AR.
Okay. Hey, Frank, that was really, really great. Thank you for that. And I'm sure our 2,120 viewers also enjoyed it, for those of you keeping score. So we have quite a few questions, and let me try to weed through these with Scotty, N3RA, who's also helping out here. And the first one really deals with a specific question, but I think you can generalize it. And the question had to do with the impact of having something like a K9AY loop near a tower, but and how that impacts performance. But the broader question is really, what is the impact on any of these receiving antennas when you start to deal with environments where there's lots of trees or shrubs or towers or things in the way, and do you have any experience on the impact of performance?
Well, thank you for that question. It's a very important question, and it comes up a lot. I'll address the simpler question first, and that is shrubs and bushes. Their main impact is on high Z antennas. The high Z antennas are very high impedance at the feed point, and if you have a shrub or a tree immediately adjacent to that vertical, it's going to cause a problem. I've never used these antennas myself, so I can't share any personal experience in that regard. But the generally accepted rule is that you try to get the verticals installed at least 10 or 20 feet away from the nearest building. But the issue with buildings is they often have metal inside, which can be even worse, or tree or bush. But the much more difficult question is, what about things like towers, antennas, power lines, all of which create problems. The big problem with power lines is that they often have a vertical wire running up the pole to lightning arresters or transformers up at the top of the pole. So this is a big problem. And even if you don't have that, of course, power lines are often noise sources. So the best thing I can say is there's not much you can do about the power lines other than try to keep away from them. And in terms of your own antenna system, you can't do much about the towers, so try to keep away from it. But in the case of, let's say, a 160 meter vertical, or whatever your 160 meter antenna is, and of course, anyone on 160 is surely using a vertical and not a horizontal antenna. One way that you can minimize the interference between a transmitting vertical and a receiving antenna is to put a relay at the base of the 160 meter vertical and to open circuit the feed point to that vertical when you are receiving. So it's, and you key that relay exactly the way you key the amplifier in your station. So that's kind of a brute force way to eliminate the interference between 160-meter vertical and the receiving antenna, but it's very, very easy to do. So that's the approach I always recommend. So back to you, John.
K1AR, are you muted?
Sorry about that. Scotty, do you have a question you'd like to ask?
Sure. Very good. Thank you, Frank, for that fantastic presentation. It's very interesting, and it makes me yearn to get outside and try something to improve the low bands for here. There's a couple of questions about things like, what are your recommendations for steep or rocky terrain? You know, that sort of thing where it's, you know, where you're putting the antennas and, you know, how does slope impact what's going on and that sort of thing.
Yeah, well, thank you for that question. Very few of us have an ideal environment. For example, my environment is somewhat sloped, but not steep, so it's not as severe as this case. And you know what I always recommend to hams is, you know, very few of us are ever in an ideal situation. So we always have to make compromises. And the most important part of an antenna is to actually get on the air and use it and enjoy it. So my recommendation is just to do the best you can. W4DR, very accomplished 160-meter DXer, faced this situation when he installed his transmitting Foursquare many years ago. And if you look at the DXCC totals, his total on 160 is pretty darn good for a 160-meter DXCC. And what he did, which was a good idea, but not everyone could do this, is he oriented the Foursquare so that only one of the four elements was way down the slope compared to the other three, and he elevated that one. So that vertical is an elevated vertical, and used elevated radial so that the array is closer to horizontal than it otherwise would have been on the sloped array. So I guess my recommendation is not to worry about it. Do the best you can, and enjoy the fruits of your labors. John, is it your turn?
Yeah, that's great. We have a user who's logged in from India, and he's living in a condo environment, and he's asking a question of all the antennas he'd like to put up, maybe like the one you actually have implemented. He doesn't have that option. He needs to put something on a roof. What would you recommend?
Well, of course, thank you for that question. Lots of hams are on 160 meters in far less than ideal environments. So don't let that stop you. Do the best you can. On 160 meters, I always recommend a vertical if you can. Their performance exceeds horizontal antennas in just about every case. So you didn't mention how high above the ground the antenna would be, how tall the building is. But I would recommend a vertical if you can do that. As little as 30 or 40 feet, and the ideal way to do that is to make it as an inverted L, so it goes up at least 30 or 40 feet vertical, and then a horizontal wire from there to as far out towards the corner of that roof as you can. So that's what I recommend. A lot of the details depending on the unique situation on the roof of that building. So again, I would recommend do the best you can and enjoy the results of your work. That's it.
Go ahead, Scotty.
All right. One of the other questions we have from somebody who's new to contesting, and you know, they're wondering if, you know, 150-foot BOG may be a good first receive antenna for a newbie, and you know, if so, what kind of other equipment relative to that would you suggest, since you know they're working on a budget and they're just new to the radio sport?
Yeah. Well, a BOG is a good choice where stealth is an issue. So if that's what you're dealing with is stealth, then the BOG is a good choice. But if you don't need stealth, you're going to get better performance out of out of a beverage that's higher. And usually the best choice is 7 feet, just so that it's not a hazard to people on that property. Now, short beverages on 160 meters, they can have good front to back ratio, but the beam width off the front is very, very broad. So my recommendation in a small space would not be to use either a BOG or a beverage, because their performance is very limited in that small space. So my recommendation is that you go back and look at my presentation at some of the shorter antennas. The easiest one by far is a pair of verticals, only 25 feet high, fed into an NCC2 controller. If you don't want to make the expense of the NCC2 controller, you can phase those, and you can either find articles that describe how to do that, or you can send me an email and I can help you. So my recommendation would be to not use a BOG at all unless stealth is an issue. Back to you, John.
Okay, that's great, Frank. So two questions that are kind of related. And the first one is, we tend to think of antennas in terms of and their performance. We tend to think more transmit antennas in terms of patterns and things like that. And the question is, does the same logic and science apply to receiving antennas when determining patterns? Second, kind of related to that, and maybe from your own personal experience, is how do you actually measure the reality of whether, other than on-air performance, whether or not you're actually getting interaction with the other things that are around your property that you're also using?
Thank you for that question. Yeah, transmit antennas and receiving antennas are different animals. We usually use the receiving antennas to get rid of interference that's coming from storms. If we're getting into a DX contest, for example, and there's a thunderstorm 500 miles away to the south, well, what we really care about is nulling out signals that are coming from the south. The other situation where receiving antennas really help is if you're in a big pile up in a DX contest or a DX expedition, and you want to hear that DX station, but you've got all these enormous signals coming from the US in that pile up, and the receiving antenna is really, really helpful in that situation too. So in the case of a receiving antenna, what we really care about is the ability to null out interference. That's what it's all about. For a transmit antenna, usually what we're interested in is very high efficiency and gain. We really don't care that much about pattern, but we care a lot about gain. And for receiving, we care a lot about interference. So they're kind of different animals. And from my own experience, what I use to evaluate the performance of antennas, quite honestly, is our performance in contests. But I do occasionally use two instances of WSJTX to compare, for example, the performance of my beverages and the 8-circle arrays. But I only do that maybe once a year when I have some spare time. So mostly what I care about is how well the things work in contests, and we just get into a bunch of those 160 contests, DX contests, and both enjoy the experience as well as you really do get an opportunity to try your receiving antennas in a variety of situations, and then you get a pretty darn good view. I always ask at the end of a contest, I always ask the operators in the different bands how the receiving antennas worked, and I usually get the same answer, and that is, it depends on the situation. In some cases, the 8-circle was best. In some cases, the beverage was best. And in some cases, the transmit 4-square was best on receive. And it just depends on where that interference is coming from. So, Scott, is it your turn?
It is. We have a couple of questions here kind of related to trees and things of that nature. And you sort of went through this a little bit, but the questions keep coming up. So one of the questions is, what's the effect if my choices for mounting are to mount some of these antennas or a beverage inside of trees, physical in the woods, so to speak. And the second is if I'm using trees as a support, is it better? I'm using insulated wire for a beverage, and I'm stapling it to a tree. Am I better off supporting it away from the tree instead of right to the tree? It's those kind of environmental questions. Again, everybody's trying to find the best way to make something work for their situation.
Well, thank you for that question. That's also a very common question. Trees are a little bit conductive, particularly in the summer. Of course, evergreen trees are a little bit conductive year-round. So it's never a good idea to staple a wire directly to a tree. That's a choice I would never make. But you can hang the wire down from a branch, or you can. A very popular approach is to use the insulators they use for electric fences. They're very inexpensive, and fasten an electric fence insulator to the tree, and then attach the wire. There's some really interesting videos produced by VE6WZ that are available online. He's got a very extensive array of beverage antennas up in the North Woods, and his beverages run through a forest. And I suspect he spends a lot of his time during the course of the year with a chainsaw rather than on the air. But his beverages work really, really well, and they run through a very dense forest. So I think about the only advice I would give in terms of trees with beverage antennas is just separate the wire a few inches away from the tree, and you'll be okay. It's not perfect, but it's just fine. And the other issue, of course, with trees is that branches will often break off of trees, so that's probably going to create some maintenance issues. And VE6WZ has some good ideas as to how to minimize that problem as well, using counterweights so that the beverage will give a little bit if a tree limb falls on it. So again, I'll just say do the best you can and avoid the obvious mistake of stapling a wire directly to a tree. John, is it your turn?
Yes, sir. That's great. So one of the things that I think is always debatable, especially with beverages, is what's the magic height above ground? And somebody asked the question, for example, if I raise my beverages up to 20 feet above the ground versus some other lower number, am I going to get some advantage, or does it not make any difference?
Yeah, thank you for that question. That's also a very common question about beverages. So here's the deal with beverages, and most hams are clueless about this, and it really gives, if you understand this, it gives you some insight into the answer to your question. So you notice beverage antennas are directive off the end. Even a short beverage, like a 270-foot beverage, is a directive off the end. But what's going on here? If I had a 270-foot dipole, it's directive off the sides. But my beverage is directive off the end. So what's going on here? Well, what's happening with a beverage is, because it's located close to the ground, and the ground is somewhat conductive, ideally not very conductive, but somewhat conductive, the horizontal polarization that would normally come off that wire if it were transmitting or received, the horizontal polarization coming into a beverage is very significantly suppressed because the antenna is so close to the ground. So the front to side ratio of a beverage antenna degrades as you raise it. And the best front to side ratio of a beverage occurs when it's very, very close to the ground, just a couple of feet high. But a couple of feet high is very impractical unless you can securely fence that area so animals and human beings don't get in there. So my recommendation for beverage height is always 7 feet. It's safe. It's a safe environment for human beings and large animals like deer, but the antenna is close enough to the ground that the horizontally polarized signals coming in from the side are significantly suppressed. Okay, Scott?
And Scott, this will be our last question for Frank.
Okay. So we'll do one last question and then a reminder to everybody. If you have questions that were not answered, please email them to Frank. He's more than happy to respond to those. Use his qrz.com address, his email address, and it's been good for many years, and he'll be happy to help you out. One last question, I think, here that seems to come up a bit. What is your recommendation if you're in an area and you live nearby an AM broadcast station? How do you deal with that? And if I can throw a second one in there, do any of these antennas scale well to, say, 40 meters or other bands? Thank you.
Okay, thank you for those questions. They're both very good questions. AM broadcast. The first question would be, is the AM broadcast station high in the band, like up near 1700 kilohertz, really close to the 160 meter band? Or is it lower in the band, like maybe below 1200 kilohertz? In both cases, what you want to do is to place a filter between the antenna and the receiver. The least expensive filters are receive-only filters because they don't have to handle the power coming out of your radio. So the least expensive are receive-only, but that, of course, requires that that the signal be fed into the external receive input of your transceiver. And if the nearby broadcast station is below about 1200 kilohertz, you can get really excellent suppression with very simple filters. And one of the filters I always recommend, and they only cost maybe about $10 in parts, is the W3LPL bandpass filter. It's a 160 meter only filter. If we're talking about that band, they're monoband filters, in other words. But the 160 meter W3LPL bandpass filter has fantastic suppression below about 1400 kilohertz. So you don't need to spend a lot of money, but it's a receive-only filter. If receive-only is a problem, you can purchase from a variety of sources filters capable of handling 100 watt power level. So that allows you to put it in the transmit receive output from your transceiver. And the performance of those is roughly tracks the cost. So there are some of those that have been engineered for extremely good rejection for broadcast stations up around 1600 kilohertz or 1700 kilohertz, but of course those are more expensive. If you have any trouble finding these filters online, just drop me an email. Just go to my qrz.com page and my email address is there, and I'll help you find an appropriate filter for a price that fits your budget. In terms of scaling, you know, I use my beverage antennas. They're 580 foot beverages, and I use them on 160, 80, and 40. They just work. It's a wonderful thing about a beverage. It's almost impossible for it to not work. So there's no scaling required at all for a beverage. The main consideration is that on 160 meters, you'd like to have your beverage at least 500 feet long if you can. If you can't, that's okay, but you'd like it to be that. And on 80 meters, just divide by 2. So on 80, you'd like to have your beverage at least 250 feet long, maybe a little shorter if you can't do that. It won't be as effective on 160. And same thing on 40. 40 meter beverage is a remarkably good directive antenna. We use them all the time at my station for receiving, to give us some some instant receive direction switching. And they only need to be you know, a little more than 100 feet long, but it would be a pretty terrible antenna on especially on 160 meters. So scaling is not a big deal for a beverage. In terms of the other antennas I described, the small verticals, the small loops have pretty terrible sensitivity on 40 meters. I wouldn't suggest them there, but they work great on 80. And it's just a matter of dividing by 2. And the short vertical arrays, they work great on 40. And again, the dimensions are just a matter for the the dimensions for the passive verticals, you just scale. So I have a 8-circle array of receiving antennas, passive verticals on 40 meters. It's about 85 feet in diameter, so it's a fairly compact antenna, and the verticals are only 14 feet tall. So that's it. If you have any detailed questions on the scaling of antennas, just drop me an email, and I'll be happy to answer it in much more detail than I possibly can here. So that's it. Thanks everybody for joining in, and hope you enjoy the rest of the day.
Okay, thank you, Frank. I know you can't hear it live, but there's clapping going on around the world right now for your presentation. Lots of great things in the chat and also in the Q&A area. And once again, if you do have a question for Frank, please go to his qrz.com page. His email address is there, and he's very accessible on email. With that, we're going to move on to our next presenter. And our next presenter is Dr. Nathaniel Frizzell. He's a space physicist and electrical engineer. He also, in addition to having a PhD, he has led the ham radio science investigation, and that's hamsci.org, which is a citizen science collective that aims to bring together professional research in amateur radio communities. For his efforts associated with HamSci and several initiatives, he was awarded the prestigious 2017 YASME Foundation Excellence Award and the 2019 Dayton Amateur Radio Association Amateur of the Year Award. He has also voluntarily coordinated and taught amateur radio classes and radio and astronomy merit badge classes. He's an Eagle Scout, and he is also teaching amateur radio with the K2 BSA Boy Scout National Scout Jamborees. Please welcome Nathaniel Frizzell, W2NAF.
Thank you so much, Tim. It's a pleasure to be here today. So yes, today I'm going to give a presentation called the 2020 Solar Cycle Update and the High Frequency Response to Ionospheric Storms and Traveling Ionospheric Disturbances. And most of the presentation is actually going to focus on how these disturbances affect HF operation and some of the science behind it. And then at the end, I'll give a little bit of information on the 2020 Solar Cycle Update. So for this presentation, I wanted to talk about 3 different types of space weather events or phenomena or things that we observe that really affect HF propagation. And some of these you may be aware of, and some of them you may not be. The first one I'm going to talk about is X-ray solar flares. Those cause radio blackouts. The next thing I'll talk about is geomagnetic and ionospheric storms. And these are the things that you typically hear about when KP goes high. They'll say a geomagnetic or ionospheric storm is coming. And then finally, I'll talk about traveling ionospheric disturbances. And these are the things that can cause fade outs in your received HF signals that have periodicities between like 15 minutes to an hour. So I'll talk about all of those today. And so to start out with, though, before we get into those different phenomena, I want to cover some of the ways that we observe these changes in the HF operation. Like why do we actually see some of these changes in propagation? And one really good place to start with is just talking about where is and what is space weather. So when we talk about weather, we talk about, in the terrestrial environment, we talk about how different changes in the environment around us affect our daily life. So if it's raining or if it's windy, that affects, our activities or some of our technologies here on Earth. So they extended that term to space. So when different changes in the space environment affect technologies in our life, that's what falls in the category of what we call space weather. And so ultimately, all of our space weather really starts from the sun up here. Let me see if I can put on a laser pointer here. So the sun up here. And that sun releases many things. It releases electromagnetic energy in the form of light and X-rays and UV rays, and that travels and hits, can impact the Earth. We also have the solar wind, where you actually have particles, mostly many charged particles, so plasma, and that carries with it the sun's magnetic field, or the magnetic field coming from the sun, and that solar wind and interplanetary magnetic field can go toward the Earth. And then when it hits the Earth, it doesn't necessarily hit the Earth directly. The Earth itself has its own magnetic field, and this creates something called a magnetosphere. And that magnetosphere can act as a barrier to the solar wind plasma and the interplanetary magnetic field. And so some of that material will get pushed around, but some of it can enter in through regions called the cusp, or under the right conditions, you can have this solar wind couple with the magnetosphere, and you can get energy into this system as well. But anyway, there's a lot of variability, and this magnetosphere can actually interact with the plasma that makes up the ionosphere down on Earth. So all of these changes that happen out here can actually be sensed because through radio systems, because we see changes in the ionosphere that are ultimately caused by these things. So what is the ionosphere? The ionosphere, it's a region of charged particles in the upper atmosphere of the Earth. And so this occurs mostly between, say, about 50 to 300 kilometers above the Earth, although it could go higher. There's not exactly a definite boundary. The ionosphere is primarily caused by ultraviolet and X-ray energy from the sun hitting the neutral atmosphere and stripping the electrons off of neutral molecules and atoms. And that creates electrically charged gases called a plasma. And so we measure the ionosphere by what we call electron density, how many electrons are found within a cubic um, a cubic volume, so like per meters cubed. And so during the day, when you get the driving from the sun, you get more layers. You get a peak in what's called the D layer, a peak in the E layer, a peak in the F1 and the F2 layer, and you get more structure and higher densities. At night, this reduces down to just roughly about 2 layers, the E and the F layer. But this, of course, is a very overly simplified picture. But why do we care about this with radio? Well, it turns out that as radio waves pass through or interact with this ionospheric plasma, that ionospheric layer can cause a bending or a refraction of those signals, or it can absorb those signals, or it can just reflect things straight back down, or the radio signal can pass through. But no, regardless of what happens, there is an interaction between this electrically charged plasma of the ionosphere and the radio waves that we are transmitting and receiving. And that's what this shows over here. So ham radio frequencies, as you know, we as ham radio operators are allowed to transmit on certain bands. And I have a chart of most of the common HF, MF, LF bands and some of the VHF ones here, listed by both frequency and wavelength. And a lot of the contesting that's going to occur in the HF band and the MF band. So HF stands for high frequency. It goes between 3 to 30 megahertz. And MF stands for medium frequency. It goes between 300 kilohertz and 3 megahertz. And each of these frequencies are going to respond differently to the ionosphere. And that's why we have so many different frequencies and so many different wavelengths, bands that we're allowed to transmit on. That's why they didn't just group everything into one region and say that's where you're allowed. We need all of these different bands because they all interact with the environment differently. So over here, I have what we call an ionospheric ray trace. And so in the background, the colors here, this is a model of the ionosphere, and it's organized, it's a profile by height. And the colors here are showing the electron, well, actually what's called the plasma frequency, which can be related to the electron density. So you can essentially think of these colors as electron density. So brighter colors, higher electron densities, darker colors, lower electron densities. And there's a gradient. So as you start on the ground and you start going up higher, there's a positive gradient in electron density. And then when you get to an ionospheric peak in the middle of the F region, and then above that, you have what's called the topside ionosphere, where there's now a negative gradient as you go out into space. Now, you can use something called the Appleton-Hartree equations to calculate where a radio wave of a particular frequency is going to go given a particular electron density gradient. And that's what these rays are over here. So I've picked, I used a model ionosphere for the eclipse that happened a couple years ago in 2017. And I chose a frequency of 14 megahertz, and I picked AA2MF's QTH down in Florida as our starting point, and I picked the WE9 Victor RBN receiver in Wisconsin as the receiving point here, and I ran an experiment I ran this model to see where the rays would go. And so you can see if I fan out the rays as a function of takeoff angle, you can see how some of the lower rays, they're going to be bent more by the ionosphere. Some of them, when they get above some sort of critical takeoff angle, they're going to escape into space. Some of them that are in the middle are going to hang out in the ionosphere for quite some time before they come back to Earth. And those are the Pedersen rays. So you can see all of these things. And then I had my model pick out the ray that was closest to the receive location. And it said that this one is close enough that the computer thinks that you will have an effective QSO between these two stations under these conditions. So you'll see a number of these ray traces throughout the presentation. One of the important things to know is that the ionosphere, this is an overly simplified, very smooth version of the ionosphere. This is not reality. So when you're looking at these models, remember that this is just a model. It's very smooth. The real ionosphere has a number of irregularities in it. It's very bumpy, but this is a really good cartoon place way to start. It's a good model for getting an idea of how things do behave. So we can show, if you run this model in a few different cases, I can show you refraction as a function of frequency. So now this is a similar ray trace, just using different locations. So here, this is from a 15 megahertz radar and Super Darn radar in Blackstone, Virginia, looking along a particular look direction. And here's a 15 megahertz rays that I'm using here. And I'm using a particular background ionosphere. And then here's the same background ionosphere, but now I'm operating at 10 megahertz. And you can see that when you keep the ionosphere the same, but you decrease the frequency, you're going to get more refraction. So the lower you go in frequency, the more refraction you're going to get, the more bending. So here I've got 1, 2, 3 hops in the same space, where up here we only have 1 hop. And this is why you have some sort of critical frequency or maximum usable frequency at any point in time, because when you go above that frequency, you're not going to have enough ionospheric refraction to be able to complete your QSO. Now, why do you have a lowest usable frequency? Well, that's most likely, what's not shown here is there's also absorption. So as you go lower in frequency, the radio waves are going to be more susceptible to being absorbed by the ionosphere. And so there's a competing effect that if you, especially in the D region and sometimes the E region, if you go too low in frequency, your signal will get absorbed and won't be able to complete the propagation circuit. So that was showing what happens when you keep the background electron densities the same, but you change the frequency. Now we're going to keep the frequency the same, but we'll change the background electron density. So this is the same model ionosphere I showed you 2 slides ago, from AA2MF in Florida to WE9V in Wisconsin. But now this is actually a movie that shows a prediction of what would happen during that 2017 eclipse. And so as the eclipse comes on, you'll see the electron densities become less and less, and you see how there's less refraction on that circuit. And at some point during the eclipse, this you could not make the QSO between Florida and Wisconsin anymore. Play that one more time. It's a nice little movie. Now, back about, probably in like 2012 or 2013, I had the good fortune of being able to travel to Adak Island in the Aleutians in Alaska with the Super Darn group to help build the Super Darn radar out there. And that's where I met fellow ham and scientist Ethan Miller, K8GU. And he introduced me to the CW skimmer and RBN system. I wasn't familiar with it before then, but this is a great tool that I'm sure many of the people here listening to Contest University are aware of. And if you're not, you should definitely take a look at this. So CW skimmer is a computer program that will automatically decode your Morse code. And if you couple that with a software-defined radio receiver that can listen to all the bands simultaneously, it can provide you a feed of spots, DX spots, right from your computer automatically for all the different bands. And if you use the RBN aggregator software in conjunction with this, you can send your spots up to the reverse beacon network where they will tell you, you know, who's calling CQ, and it will spot the different stations. And so this has created a great source of observations of ham radio HF contacts that we've been able to use. So they make their data available for download. And so I've downloaded their data. Many thanks to the people who operate the RBN network, like Felipe Seglia and David Pasco and the whole team there. And also thanks to Bill Engelkey, AB4EJ, who does a great job aggregating this and also like the Whisper Net data and PSK Reporter data network, PSK Reporter data. And I've been able to take that and analyze this data for impacts of space weather effects on HF communications. And so these networks, the reverse beacon network, the weak signal propagation reporting network, started by Joe Taylor and Phil Gladstone's PSK Reporter Network. These actually serve as ways that we can observe how space weather is affecting the amateur radio community and what current propagations are. And so you'll see a lot of this these data in this presentation. Another type of way that we study the ionosphere is something called total electron content. And I'm going to show quite a few figures in this presentation using TEC. So TEC is a measure of the total number of electrons between a GPS or more generically, a global navigation satellite system satellite transmitter and a GPS receiver on the ground. And so basically, if you have a GPS satellite up here and you have a receiver on the ground, you have a way of measuring the total number of electrons between here and here. And that's what we call total electron content. And the way you do it is it's derived from the phase delay of two different frequencies passing through the ionospheric plasma. And that's why I have F1 and F2 here. So most GPS receivers, like everyone's smartphone has a GPS receiver in it, but these consumer grade GPS receivers typically only listen on one frequency. But you can also get dual frequency GPS receivers that are capable of receiving on two separate frequencies. So there's what's called the GPS L1 frequency at 1575.42 megahertz and GPS L2 at 1.2 gigahertz. And by looking at the phase delay between these two, you're able to derive this total electron content measurement. And so this is the formulation for what we call the slant TEC. And you can see here, there's your frequency terms. It counts for both F1 and F2. And so, they're starting to come up with additional GPS frequencies. So even if you don't, so you might see receivers that use things besides just these two. But then you look at the recorded carrier phase differences and integer cycle ambiguities and the instrument satellite receiver biases. All of that goes into calculating this slant TEC. And you can go read about that more just by clicking on the link down here. One TEC unit, so this is interesting, total electron content is measured in total electron content units, which is equal to 10 to the 16th electrons per meter squared in a column. So the formulas are nice, but if you're more of a visual person or you're trying to interpret the data, it's nice to know that all of this TEC can go into maps that look this. And so you can get this from the MIT Haystack Observatory madrigal system. And this is a map of total electron content from around the globe. And you can see that toward the equator, you have the bright red areas, which is where you'd expect most of the TEC to be, because that's where you have the most sunlight. One thing, if you look really closely, you'll see that the peak is not actually directly at the equator. It's just above and below the equator. And that's something they call the equatorial ionospheric anomaly. And there's a reason for that, which you can go read about if you want to learn more about that. You'll see as you go to higher latitudes, you get typically have less TEC. And also you can see the diurnal variation. So you see there's a region of red that's moving through during the day, and then a region of blue that's moving through at night. And there's all sorts of other interesting details you can see in this. With a system like this, you can start to see some of the variability that takes place in the ionosphere. Although this particular figure is still fairly smoothed out, but if you can start to see some of the variability. You also notice with the TEC system, we don't have coverage over the oceans because you have to have a receiver on the ground in order to look at what's going on in space. Another thing to remember is that TEC, there is a correlation between TEC and the maximum of the F region, but it is an integrated measurement. So it doesn't fully characterize the ionosphere. It just lets you know the total amount. And so, really to understand what's going on with HF propagation, you really need to fully understand the full density profile from the ground up to where your signal's refracting from. So, but still, this is a useful way to get a big picture view, and one of the best ways to get a big picture view of what's going on in the world in terms of the ionosphere. Okay, solar flares. So this is the first topic I'm going to talk about that really affects HF propagation. What is a solar flare? It's a sudden increase in electromagnetic energy from localized regions of the sun. This energy travels at the speed of light. It takes about 8 minutes to get to Earth. What's so important about this fact? Well, one thing is we have no way of knowing about a solar flare until it's actually affecting us. So the first time we know that a solar flare is coming when it's already started affecting HF propagation, because the information is traveling at the speed of light. We have no way to prepare for it. Soft X-rays associated with the solar flare that are earthward directed, so if they actually hit Earth, they can cause HF radio blackouts. And these are often, but they're not always, accompanied by a CME. Now, the way they cause HF blackouts is they cause a sudden increase in the D region densities. And in the D region, you get what's called collisional absorption. So normally, when the radio energy from your HF radio goes up to the D region or up to the ionosphere, it will interact with an electron up there, which can then re-radiate your signal. In the higher regions, say like the F region, the gases are sufficiently rarefied or not dense that the electron will re-radiate that signal before it collides with some other particle, like a neutral particle. That's not true in the D region. The D region has a very much higher neutral density population and what we call high collision frequency. So it's very likely that that electron in the D region will collide with a neutral particle, and the energy will get damped before the electron has a chance to re-radiate it. And so that collisional damping is why the D region absorbs all of this HF energy. So you can see the effects of this in the RBN data. This is actually a map combining both RBN and WhisperNet data. So I've used data from both networks here. And so there was a big series of flares in September of 2017, what we call an X9.3 class flare. And so if you look for the 15-minute period before the flare took place, I have this map color-coded by a ham radio band showing the different communication paths occurring in the world. And there were over 13,000 paths observed by RBN and WhisperNet. And then right after the flare, the 15-minute period after the flare, that dropped down to only 2,500 paths. So you had an immediate effect of this flare causing that HF blackout. One thing to notice too is that the part of the globe that's going to be most affected by this is in the daylight side. That's the part that's being hit by the solar flare. The night side is going to be less affected. So you can see that more here. So for this same flare, this is the European sector of the world in response to that flare. Now, this panel here, panel B, this shows you a measurement from the GOES spacecraft, the Geostationary Orbiting Environmental Satellite, showing the X-ray solar flare measurements, the X-ray flux measurements. And you can see one flare there and one flare there. Now down here, these are 2D histograms of the RBN and the WhisperNet ham radio observations. And so I have them split up by band. So here I'm showing 7, 14, 21, and 28 megahertz. And then in time, so this is going from 6 universal time or 6 Zulu time up to 18 UT or UTC. And you can see that on the y-axis here for each of those, I'm going between 0 to 3,000 kilometers. So if you see a bright spot here, say centered around 500 kilometers, that means that on 7 megahertz at this time, most of the QSOs going on were between stations that were about 500 kilometers apart. Here up at 14 megahertz, you see them around 750, 500, 750 kilometers apart, and you're starting to see the second hop out here. Okay, so going along, everything's fine from 6 UT up till the flare time, and then boom, the flare hits. You can see the communications on all the bands just suddenly drop out. Now, one of the nice things about flares is they don't last forever. You actually get a pretty good recovery time. So things recover in, say, within 30 minutes, tens of minutes to a couple hours. The second flare definitely had a bigger effect because it was a little bit bigger, and so the recovery time was a little longer. Now, in addition to just the flares here, I want you to notice this white dashed line that's on each of these plots. This is a plot of the solar zenith angle. Whenever this white line is highest in the plot, that corresponds with noon. Noon right over the center of Europe, which is where the star is, the center of mass for these spots. So that's where noon is. So let's look at the US side. So here's the same sort of figure for the United States. And again, these are midpoints. These density spots, they're locating the midpoint between a transmitter and receiver in the RBN and WhisperNet network. So here you have 2 flares, but you see the sun is down. So the United States is still in night to early morning, dawn. And so 40 meters, 7 megahertz, things are going away really nicely. 20 meters is just starting to become active. 15 meters and 10 meters, they're still shut down in the middle of the night. And here you see the first flare occur. You really see almost no effect on 7 megahertz. It's being shielded by the Earth. Here, when you get to the second flare, and the United States is starting to come more into dawn, and now you're starting to see an effect. You see a bit of a blackout on 14 megahertz. You see a significant dropout on 40 meters, and 40 meters never recovers. Probably partly because of the flare, and partly because you're also going into daytime here. So 40 meters becomes a more local band at that point. So the next thing I wanted to talk about was ionospheric storms. And these are much more complicated to understand than the solar flares, I think. So before I talk about ionospheric storms, I'm going to talk about geomagnetic storms. So a geomagnetic storm is a large-scale perturbation of the Earth's magnetosphere and magnetic field caused by space weather events, and that can trigger an ionospheric storm. So the geomagnetic storm, these are caused by fast coronal mass ejections or high-speed streams from the solar wind. And the CME, or high-speed stream, it must be Earth-directed in order for it to affect us. And there must be an extended period of what we call efficient energy exchange between the solar wind and the magnetosphere. And this is defined by extended periods of southward, what we call BZ, or southward directed interplanetary magnetic field, and high-speed solar wind. So you have a number of conditions that need to be met before you have a geomagnetic storm. Now let's look at this last one for a minute. What do we mean by this efficient exchange of energy? Well, the magnetic field, I'm missing a few arrows on this plot, unfortunately, so I'll have to go update this and put the arrows here, because the magnetic field of the Earth comes out of this South Pole and it goes into the North Pole. So here, this is actually a northward magnetic field line. The solar wind can flip between north and southward magnetic field lines, or east and west. You know, it can change direction. However, it's only when you have, let's see, only when you have a southward magnetic field line from the sun do you get this magnetic field line can actually connect with this one and transfer energy into the Earth's system. So basically, this field line needs to be pointed southward, that needs to be pointed northward, and when that happens, then this magnetic field line from the sun can connect with the magnetic field line from the Earth, and then the plasma can flow freely along these magnetic field lines and enter the Earth's magnetosphere system. So that's what we mean by getting energy into the magnetosphere. We're going to skip over those for a little bit. Well, this is just showing you what some characteristics of coronal mass ejections. This is showing you characteristics of high-speed streams, the fast-moving solar wind released from coronal holes. But if you get all of those conditions met, what do we see on Earth? Well, for a geomagnetic storm, these are what Ham's, okay, these are defined what we call a negative excursion in the disturbance storm time index, or the high resolution, or the SIMH index, which is a high resolution version of the DST, the disturbance storm time index. And so these are measures that are derived from ground magnetometers that are located in the mid-latitude regions, both above and below the equator, that are shown over here. And that's what you see over here. This black line is a measure of the SIMH, or disturbance storm time index. And typically what you see is when the storm starts, you'll see a sudden kick up in the SIMH, and then you'll see a decrease down here. So this is what we call the onset phase of the storm. This is the negative phase, and then you get a recovery as DST gets closer to zero. Now, hams, they might be more familiar with the measurement that we see in the colors here. This is what we call the KP index. So the KP index is an index of geomagnetic perturbation that's measured from these ground magnetometers here. Again, both now like higher mid-latitudes and also down here. So KP, it's logarithmic. It's only a 3-hour resolution. The P stands for planetary. So from any ground magnetometer, you can calculate a K index, but the capital K with a lowercase p stands for planetary, which means they've accounted for perturbations in all of these indices. And so you can see that when KP gets into the red zone, which is KP greater than 5, or the yellow zone, which is KP greater than 3, that's when we start to have a geomagnetic storm. So it's very well correlated with the DST, or the SIMH index. It's just the DST index gives you a little bit more resolution or understanding of what's going on with the storm where you are. So I was saying that, why do these magnetometers get affected this way? Well, if you remember from Ampere's law, a current can actually cause a change in the magnetic field. And so in the Earth's space system is actually made up of many different currents. At the boundary of the magnetosphere, we have what's called the magnetopause. You have currents flowing this way. Inside of the system, you'll have a set of currents called the ring currents flowing this way. And there are many other current systems as well. When the high-speed stream, or CME, first hits the system, this magnetopause will get pushed forward, and these magnetopause currents will get pushed closer to Earth. And that's where you're going to start to see that initial kick, positive excursion in DST. Once that settles down a bit, the next thing that happens in the storm is this ring current gets enhanced, and you'll see that the ring current is going in the opposite direction of the magnetopause current. As the ring current gets enhanced, that's actually going to cause a negative deflection, in the DST, and that's what you're seeing here. So you have the onset, the main phase of the storm, and then what we call the recovery. So there's actually, 3 parts to a geomagnetic storm. So what's an ionospheric storm? The ionospheric storm results from a geomagnetic storm, and this is a specific response of the ionosphere to dynamic features in the solar wind that trigger geomagnetic disturbances throughout the coupled magnetosphere-ionosphere system. An important takeaway from this is there's both a positive phase and a negative phase of a geomagnetic storm. And as hams, when we hear a storm is coming, we just think, oh, everything is going to be disrupted. Well, how is it going to be disrupted? How is it going to change? Well, actually, at the beginning of the storm, you're going to see an increase in electron density, and then, but the majority of the storm is going to have a decrease in electron density. So that might mean that if the conditions are right for positive, there might be a small chance that you can go up to higher frequencies at the beginning of the storm. But then most of the storm, if you go down to lower frequencies, you're going to do better because in general, the electron density is less as a result of the storm. This is a really nice figure that comes from Evan Thomas, and this is actually looking at total electron content data again. And this is using a coordinate system. Each of these frames represents the Earth, and it represents times relative to the onset of the storm. So this is when the storm starts, and then 3 hours later, 6 hours later, 9 hours later, etc. And it shows this is for a and it's organized by what we call magnetic local time. So here where it says 12 MLT, this is the side of the Earth that's closest to the sun. 24 MLT, this is midnight. This is the dawn flank over here, and that's the dusk flank. So depending on what time of day it is, you can see what sort of response you might get. And so you can see for the first, 6 to 9 hours of the storm, we're actually seeing higher electron densities. And then for the next from 12 hours up to 33 hours, we're starting to see the negative phase of the storm, less electron density. So these are derived from total electron content measurements from GPS systems. So in September 2017, not only were there both solar flares, there was also a number of CME, coronal mass ejection induced storms that affected communication systems. And so we can look at the response of the RBN and WhisperNet to that. So now this is a very similar figure to what I showed you before, but now we're showing all of the contest bands from 1.8 up to megahertz up to 28 megahertz. And we're showing it over a 6-day period from September 6th through September 12th. And you can see things are going along just fine. We're also showing out to 10,000 kilometers in communications distance here, not 3,000 anymore. So the y-axis is much larger now as well too. And you can see here's the KP index, here's the SIMH. We had our solar flares right here, but then there's a delay between when the CME occurs and when it actually affects Earth because the solar wind is not traveling at the speed of light. So it can take anywhere from a day to a few days to get to Earth. So when it finally gets here, you get the storm right in this region, and you can see, well, actually, it's kind of hard to see the drop off when you look at it this way, but this is the region in here where the storm is affecting the HF communications. And the way to see it more clearly is if you take this and you subtract off all of the quiet days from the year. So basically, I looked at a quiet baseline and I calculated what the mean and standard deviation for all of these times were for all the days where there were no storm. And I calculated the z-score of that. So now the blue means less activity, less ham radioactivity than usual, and the red means more ham radioactivity than usual. And you can see that within the bounds of the storm, there is a significant drop off in the 7 and 14 megahertz bands. There wasn't quite as much data or observations on these lower bands. And the one thing that was very interesting, and this requires a little bit more studies, we actually did see that even with the storm, there was still a number of 28 megahertz 10 meter communications going on. So trying to understand how that fits into this whole paradigm, that's an open question, and this is what makes ham radio and studying the atmosphere so interesting, because that doesn't quite fit that normal paradigm that all of the higher bands should be shut down. It is worth noting that where do these observations come from? 78% of the observations here come from WhisperNet, and 22% come from the reverse speaking network. So, what mode you're using does affect, whether or not, what your signal to noise ratio is, and whether or not you're going to be able to complete your QSO. This is showing too that for starting on that, normally you'd expect a few day recovery from the geomagnetic storm. But again, something we don't necessarily understand completely is it looks like the ham radio bands never recovered for many days after this storm, even though you would think that they probably would. And why is that? Again, that's still maybe something to research. You might ask yourself, well, if I look just in the Caribbean region, this is during like Hurricane Irma, I believe, and it was we were trying to use ham radio for emergency communications here, and it was difficult because we had all these storms and flares at the same time. And you might say, well, is it just that the hurricanes and the emergency situation put the hams off the air? And I'm saying I don't think that's necessarily the case. And why do I say that? Well, I looked at the reverse speaking network spots, and they were certainly below average for that period of time. But if you look at just the total electron content measurements across the United States, and these are, this is from the GPS system, an automated system in the mainland US, you can see that the TEC was actually below average for that extended period of time as well. And that corresponds with the extended period of time of below average ham radio activity that followed those storms and those flares. Now, the last major category I want to talk about is something called traveling ionospheric disturbances. Now, from a ham radio perspective, these are the things that if you're listening, like let's say you're listening to your favorite shortwave station, a broadcast station, just for fun, and you notice that they're coming in strong, and then maybe 15 minutes later it fades out, and you're like, where did they go? And then like 15 minutes later they come back. And then this happens maybe a few times. You might be like, well, why is this fading? Well, what you're probably experiencing is something called a traveling ionospheric disturbance. And so these are quasi-periodic variations of the F region electron density. And we typically categorize them as either medium scale or what we call MSTIDs, or large scale traveling ionospheric disturbances. So the medium scale ones have periods between about 15 minutes to an hour, and they have horizontal wavelengths between 100 to 250 meters per second, and horizontal velocities, and they have horizontal wavelengths. There are several hundred kilometers, less than 1,000 kilometers, and these often come from meteorological sources. Large-scale traveling ionospheric disturbances, they have wavelengths greater than 1,000 kilometers. They have periods between, say, 30 minutes to 180 minutes, and they're often associated with auroral electrojet enhancement, so basically more auroral activity. Both of these are associated with atmospheric gravity waves. So this is where the whole atmosphere gets perturbed and raises and lowers. And so, as I said above, the ultimate source of these is either auroral or space weather activity, lower middle atmospheric disturbances, neutral atmosphere. So, and actually more and more evidence is pointing to the importance of this. As hams, we don't necessarily think about the neutral atmosphere, the lower atmosphere, causing effects on our HF propagation. We are often taught to think that everything comes from space, and that's not necessarily true. A lot of the variability actually comes from these lower and middle atmospheric disturbances, and that's something I'll show a little bit more in a minute. Now, how does this work? Here's another classic ray trace diagram from a Sampson et al. Paper in 1990, and very similar to what I showed you before, but now he has it so the electron densities are not quite so smooth anymore. Rather, you have these waves that are moving through the electron density profile, and the effect of that is to focus the HF rays in some places and defocus them in others. So these concavities and convex regions cause a focusing and defocusing region, and that means that a radio, here's your transmitter, or if here's your station, you're going to be able to work stations in this, say, 900 to 1,000 kilometer region better than you will be in this, 1,000 to 1,500 kilometer region. And if this is moving, that this focused region is going to move as well. So the region you're able to work is going to change with time. So here's actually a movie that I've made of this. If I can get that to turn off my laser pointer here. There you go. So now I've done a ray trace simulation where I put in my own little I put in my own my own traveling atmospheric disturbances in here. And these are traveling in the typical direction that you'd expect medium scale traveling atmospheric disturbances to travel. You typically expect them to go from the pole down toward the equator like this. And so here's the United States. This is an ionospheric radar out in Kansas, a super darn radar out in Kansas. And then this is ionospheric densities at 250 kilometers. This is the profile that the radar is seeing. You can see the focusing and the defocused regions. And then this is the signal to noise ratio of the measurements by the radar of the ground scattering. You can see the scalloping that occurs due to the traveling atmospheric disturbance. And
about 5 minutes.
Sounds good. Yeah. So that's what you see there. So we can actually see these same sorts of things in the ham radio data. So again, here are the TIDs. So here's the RBN and WhisperNet data again. So I'm 14 megahertz in November. You can see the scalloping in range caused by traveling atmospheric disturbances. Here it is again. I was able to line this up with total electron content measurements over here. So I could estimate the direction and the wavelength of the wave, and you can see how there's a peak in TEC here and a peak down here, and then across the United States you have lower densities. And then if you play this as a movie, it will propagate equatorward with time. And there we estimated those parameters. Here's an example of a day where this is the day I just showed you where you have the TIDs going on. But if you look in May, I picked a day in May, very flat. So you don't see the TIDs as much. And a lot of this is because the TID season, especially for medium scale traveling atmospheric disturbances, that would be in the fall and winter. And that's because, so here red is more TIDs, blue is less TIDs. That's because it's really associated with the polar vortex, the medium scale ones. That's what I found. So if you have a good strong polar vortex, you'll see more traveling atmospheric disturbances. If the polar vortex breaks up, like is just happened right now, we have this cold snap here, the polar vortex breaks up, you actually will see less TIDs, MS TIDs during that time. So the solar cycle forecast. So the NOAA, the forecast comes from the Solar Cycle Prediction Panel representing NOAA, NASA, and the International Space Environment Services, ISDS. And this amounts to the official forecast of the solar cycle. And the prediction panel forecasts that the sunspot number for the solar maximum has predicted cycle 25 to reach a maximum of 115 occurring in July 2025. So that's where the next solar cycle max is predicted to be. But the max could occur. Right now they estimate it anywhere between November 2024 and March 2026. And so this is where we are now. We're at the bottom of the solar cycle. This is the previous solar cycle. This is sunspot number. And you can see they're predicting a peak somewhere around 2025. So probably low bands down here, use more of the high bands up here. And then this is the same figure, just using F10.7 centimeter flux, a slightly different way of looking at a similar phenomena. And so the big takeaway is the ionosphere and HF propagation are highly variable, and we as contesters certainly know this. Models often portray the ionosphere as a smooth monthly median model. This is not reality, and understanding what causes all the short-term variability is still an area of very active research, but we can understand certain phenomena which can help with contesting strategy. And the part that we don't understand is the part of what keeps contesting fun. So thank you very much.
All right, we have a few minutes for a few questions, and John, K1AR.
Okay, we got lots of really interesting questions here. Nathaniel, for you. So let me just start off. I think a lot of folks are new to this whole topic, and you know, for the newbie or the beginner or a new contester trying to really get their arms around understanding propagation and these topics better, Nathaniel, can you recommend one or two locations, websites, online courses, programs you can model on your computer that don't need you to rent a Cray to use them? You know, some of those kinds of things just off the top of your head, knowing you can obviously respond in more detail on email.
Yeah, sure. So if you go to hamsci.org and if you go to resources up here, we have a number of links that include various sites that we think are good to go read about or get information about. So I like the NOAA Space Weather Prediction site because this gives you some real-time information right here. And they often, maybe my internet connections, there it is. Okay, yeah, so you have your real-time status up here. And if you click on any one of these things, they will actually explain to you what many of these things mean. So it can help give you some sort of understanding of what's going on. So I think that's a good resource. The ARRL has a propagation page as well. So if you go to hamsci.org, click on resources, you can find all sorts of links here. And if you know a link that you think that should be here that's not, you know, please send me an email and I'll be happy to add it.
Great. Thank you, Nathaniel. Scott, do you have a question?
Absolutely. Thank you, Nathaniel. A couple of real just quick housekeeping. All of this presentation itself is on contestinguniversity.com, as all of them are. This is being recorded. That recording will be available in a week or two or so, depending on how long it takes to get it ready. There are lots of questions, and this is a reminder, and we're not going to get to them all. So if you have a question that didn't get answered, or would think of something later, at the bottom of Nathaniel's excellent presentation, his email address, and that would be the best way to get in contact with him to follow up for any of your questions. So the question that I have is that low band operators know that the first night after a CME impact is often very good for long distance propagation. Subsequent nights are poor as expected. Is there any suggested mechanism for why that might happen? Or is there some ionospheric structure that forms after the initial impact but dissipates or decays as the full effect of that takes hold?
That is a very good question. I don't think I have a really good answer for that right now. And as I pointed out in my presentation, you saw that extended period of time where we did not have good communications after that storm. So I think that's something that needs to be looked into further, or I need to learn about more.
Okay, fair enough. Nathaniel, this is kind of an interesting point of view, and that is, does terrestrial weather have any impact on propagation, whether it be sporadic-y or other kinds of propagation? If big storms are going by, does that impact propagation as we understand it?
Yes, it absolutely can. The effect of each of those things is not always clear, but I can give you a couple specific examples. So lightning, that's associated with thunderstorms. That's going to both raise the noise floor of the HF bands, and you can also see lightning signatures across the HF bands all the time. Another thing that's very interesting is things like tornadoes. They can actually cause traveling ionospheric disturbances as well. And you can actually, there are some really nice movies out there where you look at the TEC data and you can see waves caused by the tornadoes radiate away from the center of the tornado. And that would, also presumably affect HF signals as well.
Okay. Thank you very much. We have several questions that relate to, total electron content. some of them are what's the order of magnitude of timing differences between two GPS signals when there's measuring a phase difference? Are we talking nanoseconds or things like that? And can you remind everybody again, I believe the TEC measurements are only available on land because that's where our measurement devices are. But people were wondering if, are there ability to add in ship-based measurements or buoy-based measurements or any of those sorts of things relative to TEC?
Yes, I guess there's a lot of questions there. So there are the exact phase differences. I'd have to go back and look at the papers for these exact numbers. Usually the way I interpret these is I often go to someone who's already processed all of this data, so I don't look at that directly myself. But if you want those details of the processing, if you this paper is available for free for download, you can go here and it will explain where you can go get the information on the processing. Yes, I believe you could include data from buoys and things like that. Again, getting that into the network, it takes a lot of money and funding to incorporate all of that stuff into this network. But I do see, the possibility of including information, from buoys. I think that is a possibility.
Okay, someone asked just a fundamental question about the concept of ducting and what that really means and the impact on propagation. Can you just say a few words on that, Nathaniel?
Sure. So ducting is when you're going to have a radio wave be trapped between in a channel of an environment that has like two different properties. So often you read about tropospheric ducting, where you have actually temperature differences create a channel where the radio wave can propagate within the atmosphere for a long distance before it escapes back down to Earth. I guess another form of ducting is where you might have like a Pedersen ray that hangs out, that stays for a long time in the ionosphere before it comes back down to Earth. So basically you have some condition where the radio wave stays within a region of the atmosphere for a longer time than this normal type of refraction.
Scott, let's make this the final question.
Okey-doke. This one really relates to the ability to do some of this modeling and ray tracing at home. And I know you sort of touched on it earlier. There's a lot of interest in what can be done at home from on my PC, whether it's local software or whether it's something that can be done via the web. And so what choices would there be for that? And I know that in some of the modeling, we see like 10% reliability. And if you could just describe what some of those terms might mean in this context. Thank you, Nathaniel, for everything.
Sure. Let's see. So I'll start with where I go for doing my modeling. There's a program called FarLap, and it actually is available for free for download if you Google FarLap in ionosphere. And there's a link in my presentation as well. This comes from the Australian Department of Defense. And it's a MATLAB toolbox that lets you do the ray traces that I showed you in this presentation. So the downside of this is that you have to have MATLAB, and that does require a license. I'm talking with the person who authored this to see if we can get it ported to Python, which would then, you wouldn't need to have a license for. But you can get this code for free. You can also, for ham radio operators, I know there's a program called PropLab Pro, which will do ionospheric ray trace modeling. So you can order that as well. You can, those are probably the main ways of doing ionospheric ray tracing that I'm aware of. And as I become aware of some more free options, I think I will recommend those.
All right, Nathaniel, thanks very much. Great presentation. Nathaniel's slides and all the slide decks are available on the Contest University website. Terry has posted them in the course outline area. You just hover over the title of the course and click on that link, and that active link will give you the slides. And we are recording today, and we're also recording the Q&A and chat, so that'll all be available for later review. And so thank you, Nathaniel, and thank you to our outgoing moderators, John K1AR and Scott N3RA. You guys did a tremendous job. And welcome to our new moderators that will be taking us for the next couple of hours, all the way till 1 o'clock. And that's Dave KM3T and Nathaniel W2NAF, who just presented. He will now turn into a moderator. And the next presentation is from N6 TV, everything you need to know about USB and serial interfaces. TV Bob is an active CW contester and wind test supporter. He's been licensed for 48 years. He's competed at WRTCs, and he's also won the ARL November sweepstakes at W7RN twice. And in 2017, he was inducted into the CQ Contest Hall of Fame. Please welcome N6 TV, Bob Wilson. Bob, it's
Thank
all
you,
yours.
Tim. Thank you, Tim. Greetings from sunny and somewhat cloudy San Jose, California this morning. And let's get going. If you have any questions, please wait till the end, although I might be able to take some in the middle of the presentation. Here's an overview of what I'm going to talk about today. Talk a little bit about legacy PC serial ports. And the reason behind this talk is that a lot of folks have trouble getting their computers and radios and other devices to talk consistently, and it usually has something to do with getting the serial ports set up. We'll talk a little bit about USB ports and devices, and what types of adapters are good and which ones are not so good. The Windows Device Manager is key to this talk, using it to manage your virtual serial ports and their port numbers. And also talk a little bit about using serial ports as keying devices for CW or RIDI or your push-to-talk. And then a little about sharing serial ports between different programs and USB sound cards, and there will be a Q&A at the end. So if I could ask Corey to put up the poll that I prepared. We had kind of curious to see what kind of radio devices people are using. And if that poll can be presented by Corey, you'll all get to vote and tell us what kind of radios you're currently using. A lot of them have USB and serial ports, and they can be automated. There's the poll. I could only list 10 radio types on there, so if you don't have one of yours listed, please click Other, and we'll wait about a minute or so for that to go away. And I think when the poll results are done, we'll have Corey present the results. Thanks, Corey. So a little bit about legacy serial ports. Originally, the first PCs had 25-pin male serial ports on them. You see a 25-pin female connector in the picture here, right there. But the male one is the serial port. Here's a 9-pin serial port that you may be familiar with, and it replaced the 25-pin connectors in more recent times. In the early days, life was very simple with serial ports. Your PC had 1 or 2 male DE9 connectors. I don't call them DB9s because the letter refers to the size of the connector, and the number is the number of pins. So the shell size is the what the letter is. DB is for the big 25-pin, DA is for a 15-pin, and DE can be a 9 or a 15-pin. So I don't say DB9, I say DE9, which is actually technically the correct term. And usually if you had 2 physical serial ports, they'd be COM1 or COM2 on your computer. And sometimes it's called a CAT port, computer-aided tuning or technology, but RS-232 is a more common way it's referred to. Unfortunately, the manufacturers couldn't agree on what kind of connector to put on their radios. As you can see here, Yaesu and ICOM 7700, 7800, they used a female connector, sorry, Alcraft and ICOM. Yaesu used a male and Kenwood uses a male. So if you had a nice serial cable for one radio, it wouldn't work on the other radio and you had to buy a new cable, which I found out when I switched from Kenwood to Yaesu and then finally to Alcraft. Well, someone decided that computers were kind of like humans and they needed to get thinner and lighter. So the real serial and parallel ports disappeared. And in notebook computers, we used to have these slots in notebooks called PCMCIA or PC card or express card slots. And you could plug a card into those and get a real serial port back on your laptop. Well, those days are long gone. But until recently, all of our radios and all of our peripherals still were using 9-pin serial ports. And it's still true to this day. You'll find remote rig boxes and rotator controllers and step-IR antenna controllers and some band decoders. They all want to listen on the serial port. And I should have mentioned that, of course, there's these automated amplifiers from from ACOM and from Expert, SPE Expert, and so on. They have serial ports on them and they're used to sniff at serial port traffic so they can automatically change bands and follow the radio. So we're still living with real serial ports here. Maybe someday all of our radios and amplifiers will have Ethernet ports. I'm not sure if that's going to be better or worse, but the common solution these days, since we don't have real serial ports on our PCs, is to use a USB to serial adapter. So you've all seen these types of connectors on the back of your PC. Type A is called, it's a USB connector that's on the PC side, and type B is on the device side. And in more recent times, they've come up with this USB 3.0 or the super speed devices. The blue ones on the right there have more pins in them and they can have a higher data rate. But the only radio I know of to date, the only transceiver that has this type of B connector is the IC7610, and you don't want to plug your rig control USB cable into that port because it won't work. It actually turns out that because of the connector shape, you can plug a USB type B cable into either one of these connectors, but you want to avoid the blue on the IC7610. It's reserved for high-speed IQ data for SDR output. So the blue is not for you, but what kind of USB serial adapter should we use? Well, reliability and compatibility varies a great deal between various makers. The excellent one, and the one that is the most capable, is made by Edgeport. It's 100% compatible, as far as I can tell, with just about every USB or every real serial port that's out there. Altima serial ports are supported by microham interfaces. I'll show you a picture of that a bit later. The FDDI is excellent. It's very good and stable, but it cannot be opened at 45.5 baud like the edge ports. So if you want to use it for RIDI keying with MMTTY, you need to use an extra program called EXTFSK. And I'll have some screenshots showing how to set that up a little bit later in the talk. The radios made by ICOM, Kenwood, and Yaesu, they support the Silicon Labs drivers generally. And they're also very good and usually pretty stable. But there's one brand you should avoid, and that's made by Prolific. If you have a USB to serial adapter that's made by Prolific, I strongly recommend you uninstall it and uninstall the drivers and recycle the device so nobody else can use it, because maybe I should say throw it in the trash rather than recycle, because it causes a tremendous number of problems. Just even if it's not plugged in, if the driver is present on the system, it can interfere with other drivers. I've had nothing but bad experiences with Prolific drivers, so I recommend you get rid of those. The best one is the Edgeport 4. It's kind of expensive to buy new, but you can find it somewhat reasonable prices on eBay, and gives you 4 serial ports, 1 USB. It's self-powered, and Windows has the drivers built in. There's an 8-port version, although I think the best use for that would be something like a whole bunch of rotator controllers. StarTech came out with similar ones. You can buy these on Amazon. They are based on the FTDI driver, and they have a separate 5-volt power supply, and they make an 8-port version too. Microham's devices, you can define lots of virtual serial ports with those. They come with a cable to control your radio, but the extra virtual serial ports can be used for CW keying or FSK, switching A and B for SO2R purposes. It's an expensive box, but it just does about all of it, and it has the virtual serial ports that you all control through their Microham router software. And if you don't want to go that expensive, for $16, you can buy this FTDI brand Chippy X10. It's an excellent USB to serial adapter. You can order it from Mouser or DigiKey. The Gizmos are also very good. They're on Amazon for very good prices, and you can see that these have 2 serial ports and these have 4. So you can get quite a few serial ports for a portable operation. These would be pretty nice. But the prolific ones, as I mentioned, they're usually the cheapest one you can get is the prolific for a reason. You get what you pay for. It doesn't play well with others, as I mentioned. So just please don't use them. If you have them on your system and I dial in via TeamViewer, I'm going to start uninstalling them because they just cause no end of problems. I don't want to deal with them anymore. They often look like this, but the only way to tell what it is to plug it in and see what the device manager shows. So what do? Well, connect your USB to serial adapter. You can just normally, if they're made by FTDI or Elecraft, which uses an FTDI internal or an edge port, you can just plug that straight into the serial to the USB port of the PC, and Windows will almost always locate and install an appropriate device driver for those devices. The COM port number will be assigned according to Windows' hard to understand algorithm, but it's generally increasing in numbers. And then you can use the Windows Device Manager to look at the assigned port number. So, but when you want to connect the radio, things are different. You don't just plug in the USB cable to radio and expect everything to automatically get loaded. It's very important that the first thing you do is install the manufacturer's device driver. Do that first, then plug in the USB cable and turn on the radio. That's really important with Icon, Yaesu, Kenwood, and Microham. You don't usually have to do it for FTDI because that device driver is about the only one that's built into Windows, and Elecraft supports that. Now, a lot of hams just don't read the manual. They go ahead and plug in the USB cable, expect it to work as easily as a mouse. It doesn't work that way. So if you do forget, in the device manager, you'll find an unknown device, and you can right-click on that and delete it, then install the driver and start over again. And then your radio will work the way it's supposed to. So please remember to do that if you forget, and install the USB cable first instead of the driver. And the COM port numbers, again, will go up sequentially. So how do I get to the Windows Device Manager? Well, the easy way is just right-click on that Windows Start button in the lower left corner of your taskbar, and you should see Device Manager pop up in the display. A nice shortcut that will help you in the future, I recommend, is you find that Windows key on your keyboard next to the Alt key, and hold that down, tap the letter R for run, and the run box comes up. Type in devmanagement.msc as shown there, and that will launch the device manager. And the next time you hit Alt R, it'll be right there already pre-filled in the box, as well as any other commands that you run that way, and you won't have to type devmanagement.msc again. So that's an easy way to launch the device manager. Here's an update compared to when I did this presentation the last time. I used to think you had to set an environment variable to see all the devices properly in the device manager. It turns out that Windows 10, you don't have to do that. But for those folks who are watching with a prior version of Windows, you do need to set this environment variable to see all the devices in the device manager. So I'm just going to briefly show in these slides, and you can refer to them later, how you get to the environment variable window, edit the system environment variables, go to the advanced tab, click on the environment variables button highlighted at the bottom, and go down to the system variables section and click new. Enter the name, and it has to be spelled exactly like this, although the case doesn't matter, upper or lowercase is fine. Set it to 1, click OK, and then you're ready to launch the device manager and see all the devices. Again, that's only necessary on before Windows 10. On Windows 10, it's not. But on all versions of the operating system, when you get to the device manager, you always, every time you open it, have to go view, click view in the menu, and then click show hidden devices. What's a hidden device? It's one that's not plugged in, or the Windows driver is there and the device name is reserved, but it's hidden. And the way you see it is it's going to have this gray icon that you see right here. That means it's a disconnected device, but you can still work those disconnected devices, and you may have see dozens of these if you've tried connecting whole bunches of things to your PC over the years. And I recommend you remove the ones you're no longer using and clean up your display. Then you can get a little bit more control over your COM port number. So here's what happens when you right click on a device. In this case, I have a USB serial port. I'm not sure what it is or if I'm using it anymore. So right click and select properties. You'll see a window that looks like this. Right here, it shows you the device provider. In this case, it's FTDI. Everything's cool. If you see prolific, you're going to want to click uninstall device, because you're not going to want any prolific devices messing with your system. And when that dialog comes up, be sure to check this box right here that says delete driver software. They're not just uninstalling the device, they're also trying to get rid of the driver software. That I tend to delete all the devices one at a time, and then when I get to the very last one, by that very last prolific, then I'll delete the driver. But even if it's a good FTDI device, there's a very important thing to do, and that is to go to this port settings tab, which is shown right here, and then click the advanced button. Now, just FYI, if you don't see a port settings tab, and this happened to me just recently, it's the first time I've ever seen it for a good FTDI device. The way you get it back is you uninstall the device and then plug the USB cable back in. That'll reinstall or uninstall the device and the driver. Plug the USB cable back in, Windows will find a new driver, and your port settings tab will come back. That was new news to me. I just learned recently. But anyway, you click on the advanced button down here, and here's where you can renumber the COM port. I'll show you that later. But default options for good old FTDI devices are not very good. They will often key your radio or cause strange things to happen when you reboot or power up your PC or connect the cable. They've got this default setting here for backwards compatibility, serial enumerator. What's that mean? It means go out and look for a serial mouse, a mouse that was connected to a serial port. Well, I don't think too many of us have mice that are still connected to serial ports, so we don't need that option. And the other thing it does is it goes off and looks for a modem. So for every FTDI device you connect, including Elecraft radios, go into those miscellaneous options, uncheck the serial enumerator, turn that off so it's not going to look for a serial mouse, and always check this disable modem control at startup. What that will do is prevent it from sending a bunch of commands over the serial port as soon as you connect the cable or power up the PC, as the device is trying to see if there's a dial-up modem connected to your USB to serial adapter, which is pretty unlikely. But those are the default options, and they may always be that way. So again, recommend you always do that for every FTD device. And you have to do it on each individual serial port. One more important thing to do is go down to the section at the bottom called USB serial bus controllers, and you'll find various hub devices usually have this power management setting. And you don't want Windows to suddenly turn off the power to that device if it's a radio or rotator controller or something like that. So I highly recommend you go into every one of those. If you see a power management tab, uncheck this box. It'll be checked by default, so that allow the computer to turn off this device. Well, you don't want to allow the computer to turn it off. So you want to uncheck that box. There's another tool besides the Windows Device Manager that you can use. It's called Device View, USB Device View by Nersoft. You can download it for free. It's a little, there are pages full of stuff, but if you scroll way down to the feedback section at the bottom, you'll finally find the links where you can download the USB driver. If you have a 64-bit Windows system, download this one here. And a screenshot of what that looks like is shown here. It's kind of handy because it has this column, last plug, unplug date. So you can sort of see what device it is if you're having trouble figuring out what serial port is what. thing to do is you want to manage your serial port numbers, because every time you plug in a new serial port device, Windows is going to assign it a new number that's probably higher than the highest number it's seen before. You get gaps and strange sequences and very large COM port numbers. And there's some software like WinTest that doesn't support a COM port number higher than 13. So you really want to renumber everything so it's down below 13, at least everything WinTest needs to control. And so I kind of try to do things a little bit logically, maybe left to right, or if you're in a Middle Eastern country, maybe right to left. Number these things so that they match your station layout. So you can think logically, okay, the left radio is COM3 and the right radio is COM4 and the amplifier above it is COM6, even on the right, out on the left, something like that. And you can use the Windows Device Manager first, though, to uninstall all those serial ports that are grayed out and no longer in use. And then you'll see that there's lots of gaps and COM port numbers you can reuse again. So you want to take all these remaining COM ports, right click on them, go to the port setting tab and advanced button like I showed before, and then you're going to renumber the serial ports. So a screenshot, if it's an FTDI driver, you put the COM port number way up at the top here, and I can pick any of these ones to reassign to it. Now you see some of these marked in use, and you'll see that if you don't delete all your unused ones first. What does in use mean? Well, it doesn't mean the device is connected. It means that at some point in history, maybe years ago, that COM port number was assigned to something, and it's not going to let anybody else use that COM port number until you delete it. Although you can usually go ahead and reassign that COM port number without deleting it first. If it's grayed out, means it's not plugged in, it's not going to break anything because nobody can connect to it. Again, as I mentioned, uninstall the disconnected and no longer used devices first, then their numbers free up and they won't be marked in use anymore. But if you do try to reassign one that's marked in use, you'll probably get this warning message that this COM name is being used by another device. And it can lead to inaccessible devices and change settings. Do you want to continue? Just go ahead and click yes. But sometimes what happens is you've got a real COM port number and your logging program can't connect to it. And you don't want to figure out, well, why can't I connect to it? Is there some other program that's currently using this serial port? And this is something took a lot of research to discover. There is this wonderful tool called the Windows Process Explorer, which you can download from Microsoft for free. And on Windows 10, you do need to run it as administrator to see all the devices. So you right click on the executable and click run as administrator. And then there's a little search button that looks like a binoculars icon. I'll show you a screenshot in a second. And if you search for any one of these partial strings in the search box that pops up, you can figure out what program has got the serial port open and why your logging software can't get to it. Maybe there's another copy running, maybe there's some strange program that's opened the serial port. And I needed to figure this out once when Ham needed help. We couldn't figure out who was grabbing the COM port for his ICOM radio, and we thought he had no software running, or it turns out he had an old USB device that he wasn't using anymore, with some kind of a rangefinder for a golf course. And that software was scanning the whole system, finding a serial port and connecting to it every time he booted Windows. The only way to figure that out was to use this Process Explorer program. So here's the little binoculars icon. I've clicked that. It pops up with a string. You can just put in a partial search there. I don't think it accepts any wildcards. But I knew that the serial port started with VCP, so I put device /VCP and I clicked the search button, and it popped up and told me the WinTest process has got that device open. Sometimes people will use OmniRig. I'm going to talk about that a little bit later. In this case, it shows that OmniRig has got the serial port open. So a lot of programs use OmniRig, and we're wondering why N1MM can't open the serial port. Is because OmniRig has already got it from some other program. And you can figure that out using this Process Explorer. Now, sometimes you're really not sure what string to search for. So they provide this very handy little kind of strange icon over here. And it's called the Find Windows Process icon. And you know what you do is you go ahead and grab that with the mouse and you drag it on top of the window where you have a known program that's opening a serial port device that you can get to. You're just not sure what string to search for. So when you drag and drop that icon on top of the window that's got your running program, it will automatically highlight. It's a little hard to see, but right here it's highlighted the WinTest executable because that's the screen that I dragged the icon on top of. So it jumps right to the right process. And then you go up to the view menu and you select on the lower pane view, you want to see handles. Handles is the Windows term of what they use to grab a hold of a device. They use something they call a handle. And then on top of the screen, you can click on by sort by type, but you really want to sort by name, which is this column over here that's buried. And then you can see all the devices. And down here, you kind of have to scratch your head and figure out what looks like a serial port. Well, VCP, that sounds like a serial port. That's virtual COM port. So that's the kind of string you want to look for. You might sign a device using VCP1 or VCP2 instead of VCP0. So that sort of covers everything about how to use the device manager and process explorer. And did we ever get the poll results to display on who's using what devices?
We have them, and I will display them right now for you, Bob.
Thank you, Corey. Well, look at that. Most of the users here are using ICOM, I'm sure, and 9J is going to be happy with that. 538 ICOM users, Flex Radio and Elecraft, very popular. Kenwood and Yaesu is about even with Elecraft. That's very interesting. Not a single viewer clicked Homebrew, so I guess Homebrew transceivers are a thing in the past. Well, thank you for that. I appreciate that. If you could clear that from the display. Thank you. So what else can I use the serial ports for? Well, this circuit has been around for decades. It's a very simple 1K transistor. It's not critical. And an NPN transistor, any signaling transistor. I like the 2N2222 myself. They can key just by when these pins on the serial port or the virtual serial port go high, like when this DTR pin or pin 4 goes high, it's going to turn on this transistor and it's going to, whatever device is connected here is going to go to ground. So you can key CW with that, or you can key PTT with that. And it's very reliable and very stable, and a lot simpler than trying to get a WinKey to work, in my opinion. But you do need to build the circuit, but it's a good way to do it. Now, the radio manufacturers figured out that a lot of hams, especially contesters, were keying their radios that way, or push to talk. And as far as I know, the Elecraft K3 and the K3S, they were the first transceivers to just say, well, we're going to put the keying circuit right there inside the radio so you don't have to build anything into a connector. It actually has a way to do the keying by the RTS and DTR pins, pins 4 and 7 of the serial port, because they don't use them for the normal RS-232 handshaking. So you have to enable that in the K3 menu by turning on this config PTT-key menu item. Normally it's set to off. The way it's set there with RTS DTR means the PTT will be on the RTS pin and the key will be on the DTR pin. And this actually works over both a real serial port and a USB or virtual serial port. People thought, well, you can't possibly get good timing over a USB cable for CW keying. Well, that's false. Maybe it was true in the very early days, but even with a USB connection to your transceiver, you can key very well timed CW or PTT from lots of software, lots of contest software. It's a very simple way with one cable to get rig control and keying over a single USB cable. But as I mentioned earlier, you do want to prevent unwanted transmissions when your PC reboots, especially if you have an FTDI device. You got to uncheck that serial enumerator and check the box that says disable modem control at startup. Otherwise, if those options are enabled and you turn on your PC or reboot it or plug in the USB cable, it's going to key the radio, and you don't want that. ICOM got a notice of this, I suppose, and they copied what Elecraft did, but they also did one more than Elecraft. That is, they added FSK or RTTY keying, frequency shift keying, to their support. So you can pick the RTS or DTR pins and use them for keying CW or RTTY. It's supported by these ICOM models. There may be newer ones, but none of the older ones, like the 7700 and 7800, have this feature. When you connect a 7300, there's just one virtual serial port created. When you connect these models, there will be two Silicon Labs serial ports created. In this case, it looks like COM5 and COM6 got created. Again, this is a little snapshot from the device manager. You have to use the Windows device manager usually to figure out what COM port numbers are assigned and which one can be used for rig control and which one can be used for keying. Keep it really simple. I always recommend, just for consistency, use the DTR pin for keying and always use the RTS pin for PTT. You can certainly reverse those and it works fine, but it's a little harder to remember. And if you want to use MMPTY for FSK keying, well, you normally can't open your logging program and have it open the serial port and then have MMTTY use the same serial port because they're not shared. So I recommend use the B port or the secondary serial port for dedicate it to MMTTY if you want to use FSK keying. Easy way to remember this is if you look at the letters in the alphabet, CW and DTR and FSK, they're kind of close to each other in the alphabet. And RTS for send is what some radios like ICOM call key out or key PTT in. Those PRS, they're close in the alphabet. So think of PTT on the RTS pin. And that's a handy mnemonic. Now, if you do have an ICOM radio, like many of the folks that connected to this, especially the two-port models, like the 7610, you really got to figure out which one is port A and which one is port B. Even though they're numbered 5 and 6 in my example, they may be reversed. And A is the one you have to use for rig control, and B is the one you can use for other purposes. So you can't use B for rig control as far as I've been able to determine. But you got to figure out which one's A and which one's B. And again, you use your friendly Windows device manager. You go to the Details tab, and you click on this little drop-down list here until you get to Device Instance Path. By the way, a tip for all Windows drop-down lists, many people don't know this. Once that list has the focus, you can just type the first letter, like a D, and it'll jump right to the Ds in the list, because this is a very long list. And that's a shortcut for jumping right to all the Ds, and you can type D again, it'll get to the next D. But right here is the critical thing. At the very end of this long, hard to understand string, it says 7850 is the radio type, but there's this letter A. So that means that COM5, the one I'm looking at up here, is the port A, and that's the one I can use for rig control. And I've seen this get reversed. I've seen COM6 come up as A and COM5 come up as B. It's hard to determine why Windows does that, but the best solution is to look in the device manager and figure out which one's A, and then you can control your rig with that one. And usually I'll renumber them. There's no harm done as long as the program isn't running. You can renumber them and put them back in numerical order 5 and 6, A and B, so things make more sense. In the 7300, and I'll try to run through this kind of quickly, there's a lot of detail here, but this is how you enable the equivalent of what I was doing in the Elecraft with the PTT key menu. You set USB keying CW to DTR, or you can set USB keying RTTY to DTR, and you can key your FSK that way. And then you set USB send to RTS. Send is what ICOM means by PTT input or key closure. In the logging software, and I'll show you some screenshots of the logging software, you can say put the DTR on CW and the RTS on PTT for the rig serial port. There is a problem though, because in the 7300 you only have one COM port. So if you are going to give a COM port to MMTTY so that it can do FSK keying with the 7300, well, your logger can't use that same COM port. But like all ICOM radios, they also give you this remote or CIV connector. And if you have a CT17 adapter, or there's a lot of equivalents you can buy that have a USB cable on one side or USB connector on one side and a CIV connector on the other, you can automatically control your rig with that one for the logging software and do the keying on the USB cable. So you do get two serial ports and they operate independently in the ICOM 7300. there's a menu item unlinked from remote that it's important to turn on so that those two serial ports operate independently. Well, on 7610, things are a little easier. You've got these A and B USB ports. I mentioned the blue connector and the other connector earlier. They call the blue one USB 2, so you want to do everything on USB 1. And A and B are the two serial ports that I showed you the screenshots of earlier in the device manager. And you can key CW on the A, the same one that you're using for rig control, but the RIDI keying should be on B because it has to be a separate independent serial port from the one used by your logging software. And similarly, you set DTR and RTS in your logging software to whatever serial port is labeled A, and in MMTTY, you use the B port, and you set FSK keying on DTR and PTT keying on RTS. By default, I think MMTTY would key RIDI on the TXD pin. That's not supported by the radios. You've got your choice of DTR and RTS, so you need to change it. But again, you can't have both ports using hardware PTT. So, because the ICOM only gives you one choice for which pin do you want to do sending on. They don't support two in parallel. So in that case, what I would recommend is in your logging software, you could use software PTT for CW and phone, and then use hardware PTT in the MMTTY for RIDI. Then you don't have to switch things when you switch mode. Same story in the 7850 or 7851. They just name the things a little differently. There's no blue USB 2 connector, so they call it USB 1 and USB 2 in this radio, and it's the same idea. Again, you can't use both ports at the same time, but you can do software PCT in your logger and hardware PTT if MMTTY if you want to do it that way. Yaesu FT991, I think the 891 is similar. Again, you get two Silicon Lab virtual serial ports. They use a little different naming convention. This one's called the enhanced COM port, and this one's called the standard COM port. A little hard to read there. And the menu items are a little bit obscure, but this one's important, by the way. 232C timeout timer. The default is only 10 milliseconds. If your PC doesn't respond that fast or it doesn't absorb the commands that fast, things will stop talking to your Yaesu rig. I always recommend increasing this timeout timer above the default 10 milliseconds for all these modern Yaesu rigs. I don't know why they chose that default. You want to use that RTS pin for keying and not for RS-232 handshaking, which is the other Yaesu default. So you can turn that off, though. You can set RTS to disable, and that frees up the RTS pin to be used, as I've shown here, for PTT and data mode, or for RIDI for PTT and SSB mode. Each mode, they want you to turn it on in Yaesu rigs. It's not a universal thing. The logging software, this is different between Yaesu and Kenwood. They want the enhanced port to be used for rig control. They want the standard port to be used for the keying. So you would use the standard port in MMTTY. Yaesu FTDX101D and MP is very similar, although the menu settings are different. Again, you've got this timeout timer. You want to turn off CAT RTS. And again, the enhanced port is for rig control, and the standard port is for your keying option. The Kenwood, as I mentioned, does things a little differently. They don't label, at least so far that I've seen, which one's the enhanced and which one is the standard. So again, you have to go into that details tab in the device manager. Then they call it the standard one is the one you want to use here for logging, not the enhanced, and use the enhanced for keying. Exact opposite of what Yaesu did. And here's the menu options for that. So how do I get my logging software to do keying of CW and PTT on the same port that I'm using for rig control? Well, in this case, I've got COM 12 assigned to my Elecraft K3 12 here. I have to check this box that says CW other because I want to do keying on that same serial port or same virtual serial port. Click the set button. Next dialog you see lets you enter what you want for default. You don't want to put handshake in here, which might be or always on or any of those values. You want to set DTR to CW and RTS to PTT. And if you decide to dedicate hardware PTT to MMTTY, you can check these boxes that say PTT via radio command. But I would never recommend enabling both hardware and software PTT. That just is going to lead to confusion and problems that you don't want. So that's if you're using the keys for CW and for RIDI, and for PTT. This is how you enable it in the N1MM software and click the OK button. For WinTest, it's a very similar dialog. You set your CW and PTT functions. I probably should have changed this to active with Radio 1 or Radio 2 for an SO2R situation. So what about RIDI keying with MMTTY software? Well, you start out on the TX tab and you go to this port number here, and you can't normally, if it's an edge port, you could probably put in the real COM port number and it would work okay because edge ports can be opened up at 45.5 baud, but you cannot open up most USB to serial devices at that baud rate. So you select EXTFSK there. Before you continue, you want to click this radio command button. Make sure that port, there's no port number listed here because you don't want this port number to be grabbed by MMTTY. You only want to dedicate it to EXTFSK. If you change this to clear here, it'll wipe out all these possible commands that could be sent over that serial port for software PTT. You don't want to do software PTT and MMTTY. It's just kind of a mess. The final thing you want to do is go over to this miscellaneous tab. You always want to say, I'm going to be using it defaults to this TXD pin, but we're going to change that. And finally, click this USB port button. You only have to do this once when you're setting up MMTTY, but if you have multiple instances, you need to do it for each one. Click that USB port. Make sure you always check C for limiting speed, as most users of USB to serial devices know for MMTTY. And finally, when you click OK and close all those setup dialogues, a new pop-up window will show up from EXTFSK or EXTFSK64. Then this is the only place you put in the COM port number. I probably should have put in COM6 in my example as the secondary serial port of most of my other examples. You tell it I want to do DTR keying on the FSK out for FSK, and I want to use the RTS pin for PTT. And I never need to check these invert boxes, so I recommend you do not check those when you're using this type of keying. So, serial port hardware sharing. Well, as I mentioned, usually two programs cannot open a serial port at the same time. And it's certainly true that if you're trying to connect two serial ports in parallel, for example, an amplifier that wants to monitor the radio's frequency, like an ACOM or an SPE Expert or an Elecraft amplifier, they all have serial ports that are designed to poll the radio, but you don't want to connect that polling connection to the serial port if your logging software is using that serial port, because in the RS-232 protocol, only one transmitter or TXD line can be connected between the PC and the radio. No other device can connect to pin 3, just like you can't connect two transmitters to the same antenna, but you can connect all the receivers you like to the same antenna and do no harm. So only one device should connect pin 3. Normally a PC will send commands to the radio polling on pin 3 or the transmit data pin, and the radio is going to send its response on pin 2. Flex radios are a little different because they're more like PCs than radios, and so they've reversed those pins, and you often need to use a no modem cable connection or with your flex radios. There's another option though, and that is you can turn on auto info mode. That can be made a sticky setting in Elecraft radios, but it's not sticky in Kenwood or Yaesu radios, so it doesn't work as well. Again, since there's a lot of devices like step-by-R controllers and some band decoders and those amplifiers that want to monitor the radio's frequency so they can automatically change bands. And again, in an optimized contest station, you want as little to go wrong as possible. You always want the amplifier to follow your radio and the antenna, if it's a step-by-R, to follow the radio or the band decoder. So what you can do is you can connect multiple devices to pin 2. Instead of building your own Y cables to do that sort of thing, if you don't mind a shameless plug here, I've created a box called the Serial Box that allows you to wire up to 4 devices in parallel to just the receive data line. And it's ideal also for radios that don't support this handy RTS and DTR keying, because there's 4 NPN keying circuits built in, and there's 4 RCA connectors. So if you have one of the older radios listed or something even older, and you'd like to try CW keying over the same serial port you're using for rig control, or you need an FTDI adapter inside a nice metal box, this is available to you. All right, what about
5 minutes?
Okay, I'm almost wrapping it up here. Thank you, Tim. So what about using software to share the serial ports? Well, there is a program that will do that so that 2 software programs can open the rig control port at the same time. It's called OmniRig. It's built by VE3NEA, the same genius developer who developed Skimmer Server and Morse Runner and a lot of other great software. It does it well. And the good news is that and you can open up a whole bunch of logging programs at the same time, including WSJT and any of these loggers. And if they're all set to OmniRig mode, then they'll all share through OmniRig. By the way, there is an OmniRig version 2. I don't recommend using it right now. It's not compatible with OmniRig version 1. It was not developed by VE3NEA. And fortunately, the HDSDR folks have switched back to giving you a version that can use version 1. So you can download that now. But unfortunately, N1MM software and N3FJP and some others, they do not have OmniRig as an option. And so you can't use a program that uses OmniRig and N1MM at the same time if they both want access to the radio at the same time. Since OmniRig is going to own the serial port, it'll do proper traffic cop jobs and make sure that there aren't collisions and conflicts between programs that are trying to get to the radio at the same time. There are these port sharing programs like VSPE and VSP Manager, and maybe you can get them to work, but maybe not all the time, because I think they're not really aware of what the beginning and end of a command is from contest software. So there might be collisions and conflicts if you try to use those. You may not be happy with the result. One downside of using OmniRig is that you can't do the CW and FSK keying through it, although with something like a serial box, you can split out those pins to separate connectors and a keying circuit and key your radio that way and still only have one USB cable. So there are some radios that have both USB and serial connectors on them, and that way you can, in parallel, kind of use both ports on a radio. The K3, you cannot use both at the same time for rig control. You can use the USB for audio and use the 9-pin for rig control and keying, but they are wired internally in parallel, so you can't have 2 logging programs connected to both at the same time, or 2 PCs. But I understand that the Elecraft K4 is going to eliminate this. You'll be able to have multiple programs talking to different serial ports on the radio at the same time. The Kenwood radios, they do support simultaneous use independently by the 9-pin serial port and the USB port. And ICOM radios, you can use the CIV ports together if you select that option, unlink from remote. That'll have 2 radios at the same time, or 2 devices, one on the CIV port and one on the USB. Briefly, a little bit about your sound cards. When you connect these modern radios, you get a USB sound card, and it's ideal for using for RTTY AFSK keying or voice keying. It's called a USB audio codec. You'll see that in Device Manager when you connect it. But often it's difficult to figure out what sound card is my radio and what sound card's in my PC or other device, or if I have 2 radios connected, which is which. So you right-click there, open up sound settings, and you'll see the little link for sound control panel in 2 different places depending on how wide your screen is. It'll either be at the bottom or at the top right, depending on how wide the screen is. But a shortcut is, because you want to get to that sound control panel, hit the Windows key and the letter R for run and type in mmsys.cpl. That'll pop up this display right away. This is the one that is your friend. You figure out which device is your radio by just watching which one disappears when you plug and unplug the USB cable. Go ahead and click that properties button. And then you want to label the recording and playback devices with the name of the device. So here's where I've done that. It used to say microphone. I changed it to microphone IC7610. So now I know that's the device that'll receive audio from the radio. And you can also click that change icon button. Let me go back one slide here. Here's the change icon button. Windows have some little icons. I like to make the things that are radios look a little bit like radios. So I've changed that icon right here. So to sum up the talk, there's some key points to remember. First, if you're not using Windows 10 and you want to see everything in your device manager, go ahead and set that show non-present devices environment variable to 1. Always use the Windows Device Manager to manage and renumber your COM ports, or you can use the USB DView. Always uninstall those prolific devices and drivers, and always change the FTDI default options. And when Windows Update comes around, and they may change all those options back to the default again when a major Windows update comes in, or they reinstall the device drivers. So watch out for that. You may need to do it more than once. Try the CW FSK and keying through the serial port pins. It's very handy. You don't need any external hardware. You can plug paddles into the radio and use the internal keyer for hand sending. Don't want any serial port conflicts. And again, label your audio codec devices. So copy of this, an earlier version of this presentation is on my qrz.com page. There are 2 programs I mentioned to download, Process Explorer and USB Device View are there. And if you're interested in the serial box, you can read more about it on that link there, or contact me by email. So go ahead and let's have some questions.
Okay, Bob, thanks very much. Dave and Nathaniel, KM3T and W2NAF. And Dave, are you here?
I am here. Can you hear me okay?
Yes.
Do you have a question for TV Bob?
Yeah, we do. Just when I thought I knew everything about serial and USB, boy, I learned some stuff. Nice job, Bob. One of the top questions is, could you talk a little bit about RF interference caused by USB connections to rigs? Any tips for how to avoid that?
Well, yeah, I've seen that occasionally. The standard processes apply, ground all your PCs and rigs with nice heavy braid to a single common ground point. Put ferrites, mix 31 ferrites, wrap as many turns as you can around the USB cable. Try to use a very high quality or more expensive USB cable with better shielding. You know, if you're using an internal sound card in the PC, try an external USB sound card instead, or the one built into your radio.
Great answer. Over to you, Nathaniel.
Let's see here. So another question is, the serial port cabling can provide a path that can damage radios and devices from EMP, lightning, and electrostatic discharge events. Are there any devices that are sold that are effective at providing good protection to these types of events?
I don't know. I do know that USB cables, especially on the TS590, will often damage the USB connector inside your TS590 just with a nearby lightning strike. It doesn't even have to be a direct hit. Seems to send a big pulse over the USB cable. RS-232 ports seem to be a lot more immune. They're higher voltage, the -12 to +12 or -6 to +6 instead of 0 to 5 volts like a USB cable. There probably are surge protector devices for USBs. A lot of power strips have those built in. I live in California where you don't get much lightning, so I'm probably not the right guy to ask for that. But I would consider using any kind of USB surge protector. Serial cables, I don't know of any that are needed, or I'm not aware of that. You can always uninstall stuff when a lightning storm comes by.
Hey, thank you.
Great.
You know,
Go ahead.
another question people have been asking. Do you have resources for people who have Windows or Linux machines, or have some suggestions on where they could look for similar types of information for Linux and Mac?
Well, I do know that Mac does a very good job of supporting the FTDI USB to serial devices. Their names come up differently. And I think you may have to install the drivers manually instead of automatically on a Mac to get a FTDI recognized. I believe the radio manufacturers have drivers for Mac, but I am not sure. I'm not really a Mac person. And Linux, I'm gonna defer to Dave Cam3T on Linux USB serial ports because I really don't know how to do it, but I assume it's similar to what you do on a Mac.
Yeah, the Mac is actually pretty well supported in terms of manufacturers' drivers. Linux, there are drivers out there. Many of them are already sort of built into the kernel for all the major manufacturers. The overall thing I would refer people to on Linux is to look at Hamlib, Hamlib. Just Google that and go take a look. It's a general purpose library that allows communication to radios, and there's a whole bunch of information out there about interfacing and drivers and stuff.
You have another question, Dave?
Yeah, Bob, do you think ham radio equipment manufacturers will eventually move away from USB and serial interfacing in favor of Ethernet or some other standard?
Yes, that does seem to be the trend. If you are using Ethernet cables in your shack and you're hearing birdies around 14.030, it's probably caused by 100 megabit Ethernet connection somewhere in your house. DX Engineering makes a nice birdie suppressor for Ethernet cables, or you can switch to shielded Ethernet cables. I do think that is the trend. I think I'm certainly Elecraft K4 will have an Ethernet jack. The Flex radios already have Ethernet jacks. I believe the Power Genius amplifier might have an Ethernet jack in some of their devices. So I do think that we will move toward Ethernet, but I've never heard of anybody keying CW or RIDI well over an Ethernet cable. There's going to be more latency and buffering. So I think the serial ports will be around for a while.
Nathaniel, do you have another question?
Yeah. Do you know about the practicality of a wireless serial port replacement, such as Bluetooth?
I don't. There are ways of getting serial ports over Ethernet and Wi-Fi for low speed kinds of things, like rig control. That's probably going to be fine. But it could solve some of the lightning problems. So if you have a lot of nearby lightning, a wireless device might be a good idea. I would Google that, but I'm not familiar with those.
Dave, do you have another one?
Do you know if there's a software package or utility that'll tell you if you have a real or a fake FTDI chipset in your converter?
I believe that, yes, on the FTDI website, there is some software that you can download. I don't have the link handy here that can, look at the device. And I assume it will tell you. I haven't heard too much about fake FTDIs. I imagine there are some. Fake prolifics were much more of a problem, much more common, and why prolific had such a mess. But even real prolifics, their driver software seemed to have some issues. They'd work for a while and then quit. So if you have a USB to serial adapter and you've turned off the power management setting and it still seems to work for a while and then quit, well, it's probably a good sign that it's not a real one. You should try another one. The price of it, it should be north of $15 or $16 for a real FTDI. Anything cheaper than that is probably a fake.
Nathaniel.
Yes. Do you have any idea why a radio computer interface might fail on an intermittent basis? So using N1MM software, everything works okay for a while, and then radio cannot find this COM4 port anymore. Any ideas?
Yeah, it could be a loose USB cable connection. It could be a dirty one. It could be a fake a USB to serial adapter. It could be the power management setting. Any of those things can do it, or perhaps even some RF getting into the cable. I've seen RF, especially in high power stations, get into USB connectors on amplifiers, and the solution was mix 31 ferrites around the USB cable right at the back of the amplifier, right around the radio connection. If it's happening when you're not even transmitting, then it's more likely to be something else. But first, see if it's RFI related.
And Dave, this will be our final question.
Okay, Bob, you haven't mentioned the CH340 USB to serial chip, but it's neither prolific nor FTDI. Do you have any experience with that chip?
Yeah, I think, isn't that, I think the Morty device uses that, if I recall. It's fine. I haven't had any bad experiences with that one.
All right, Bob, thanks very much. Great presentation. The comments were just super supportive and you cleared up a lot of problems for folks. And if you need to ask questions to TV Bob, didn't get all your answers here today, you're more than welcome to go to Bob's QRZ page. His email address is there. He is very responsive, and he has done a lot of great work over the years. And now comes to the sad part of Contest University. Normally we do this at the contest dinner, but I've asked the MC of the contest dinner to go through the contest related silent keys. And we apologize in advance if we didn't pick up all of them. Bob N6TV keeps track of these every year. It's very unfortunate. We're very sad. And John, K1AR, if you would go on with the silent keys.
Okay. In some ways, it's an honor to do this, and in a lot of other ways, it's just sadness. But I think every time I do this at the contest dinner, some 25 years now, the one thing that is happens every time is we remember just what a tight group of people we are, and the camaraderie that we share, and what contesting is truly all about. And when we lose one of our brethren to death across the year, this is just at least one way where we can just pause for a second and remember people. So with that in mind, and it's with regret that I want to read the following names, and then we'll have a moment of silence after that, and then I'll turn it back over to Timmy. So let's begin. K5 Alpha Quebec, W4MPY, W6 BSY, VU2 PAI, E73 Whiskey, N2 AA, W2OO, K1JGA, W9IU, AA8U, K0IO, JA1AA, Kilo Echo 7 Victor, W7SE, DJ2 Yankee Echo, K1GW, NK3Y, K3ANS, W2OB, Y08 Sugar Sugar, JA2BAY, N2CQ, N7RT, N4PN, HS0ZLM, also OZ1HET, K6HNZ, DK8SG, VE3XT, K5AAD, VE7NKI, K5DJ, PY5ZBU, K5YAA, W7QN, WV2ZOW, K8LEE, W4OC, VQ9QM, also W4QM, W7NI, K9HMB, W6MVW, WTHC, N8MUN, W8ILC, K1LPS, W8RC, KH6DX, W3YOZ, K2MFY, NA3D, K2RIW, K4LTA, KV4FZ, and one more that I just learned during this call, Kilo Mike 8 Quebec. And with that, let's just take a moment to just have a moment of silence for just a few seconds, and then I'll turn it over to Tim. Thanks a lot, guys. Over to you, Tim.
Okay, thank you, John. So we will be now on lunch break or dinner break or breakfast break, depending upon where you are. Don't forget that this Saturday is the Hamvention QSO party. Great time to be had by all on the HF contest bands. Details are at hvqp.org. So come back here in 25 minutes, and Marty NN1C will be our next professor. So enjoy the time off, and a couple of us will be here chatting, and of course the chat room is open, and so you can see on your screen your lunchtime entertainment is here. And so let's start out with Bill, W9KKN. How are things out in California, Bill?
Very, very good, Tim. Thank you. I mean, I'm right next to Bob. It's sort of a cold and gloomy day over here. We're all getting excited for WPX coming up here. The entire MCCC. We're gonna try to get as many of us on as possible. Just you know, of course, doing social distancing. Not going to be a lot of multi-ops going on, but other than that, very, very good.
Well, that's great. It's good to have you along with us today. And Corey, how are things back at Contest University headquarters there?
Things are going pretty well here. We got a lot of people on. We're monitoring all the live streams and the chats and doing the best we can. There's a lot of questions and stuff, and we're trying to get through everything we can. And like we said, we're saving everything off for the future. So
Thanks for doing that, Paul. Corey.
Great, thank you, Corey. And there was a Cabrillo T-shirt at K1DG. What's the story behind that, Doug?
Well, ta-da! As most of you know, our logs are almost always submitted to the contest sponsor in the Cabrillo format. And most people have no idea where the Cabrillo format originated and how it got that name. At least on my screen, the guy 3 seats over that way was responsible for it. But turns out that the guy who created that standardized format needed a name. At the time, he was taking an immersion Spanish course at a local community college in California near where he lives called Cabrillo College. And he said Cabrillo seemed to be a pretty neutral name. It didn't endorse any one contest sponsor over any other. And so he proposed that as a name, and everyone sort of said, well, okay, sounds pretty good. So I was out visiting Trey some years ago, and I said, we need to make a stop at the Cabrillo College bookstore so I can buy a Cabrillo shirt. So there you go. That's the story behind the Cabrillo shirt.
So Trey, what prompted you to write this Cabrillo spec, and what year was it?
Like to see if I get this into the picture. Oh, it's the wrong color. I got my clean sweep mug here. So it was probably in the late 90s is when the Cabrillo business got started. And there was already a thing called the ARRL format. And Cabrillo was really just kind of like taking that and formalizing it a little bit and adding a few bits that it was missing. And the actual story about how he came to get the name together is there's sort of a political aspect to getting everyone to agree to all get on board with the Cabrillo thing. So I tried to get all the people around the world that sponsored contests to sign on and say, yeah, we'll do it if you do it. And one of the sponsors says, we will not get on board if you call it the ARRL format version 2. It has to have some name that does not belong to anybody. So I was going, oh my God, what am I going to do for a name? So I remember I was at a RSGB HF convention one year driving around with G3 XTT, and I saw a sign that said Maidenhead. I said, oh, is that like the grid squares? He goes, yeah, there's a story behind that. And that's where the guys were, you know, thinking about grid squares were living at the time when this came about. So I thought, I need a name. So I was driving around in my neighborhood, and there's a lot of things named Cabrillo around here. The Cabrillo, you know, cafe, the Cabrillo highway, the Cabrillo liquor store. for Cabrillo College. So I thought, Cabrillo, that's a name that means nothing in ham radio, so nobody can object to it. And I thought I was great. I'm in business, so we gave it this name, Cabrillo. And of course, no good deed goes unpunished. At which point, all these trolls came out of the woodwork and said, "You must be a terribly vain guy that they have to give it your own name rather than calling it something generic like the ARRL format." So that's the story, how that goes. Back to you, Tim.
That's a great story. And we have the mover and shaker and the lead cook behind Papa Japan 2 Tango with us. Jeff, how are things in Idaho today?
Morning, guys. And geez, Corey, thanks for all the work you're doing to make this magic happen. This is phenomenal. And Tim, you've pulled it off again, another miracle. And we're all, we're just grieving, missing our Dayton experience. But this is sure the next best thing. And it's great to see everybody and great to hear from everybody. Things in Idaho are good. There's rumors that there's a pandemic, but it's not reached us. We have almost nothing happening. And still continuing to be careful and keep our heads down. And other than that, not much to say from this ham radio desert here. I'm in a restricted condo. We're not even allowed to think about antennas. I'm not permitted to have a photo of an antenna on the wall in my office here. But I'm well along the way to solving that. HOAs and ham operators are born natural enemies, right? But my solution is I've now joined the HOA, and in June I become president. And so the way to defeat the HOA is to just become one, and that's my solution. So I may be on the air yet.
That's great. Are you doing any remote to PJ2T?
Yeah, we can only do that when there's somebody at the station under their rules down there. And of course, that place is in total lockdown, and the island is in lockdown, and we're not able to be very optimistic about getting there for the worldwide contest in the fall. Because if they let us in, which is doubtful, and if American Airlines is flying, which is questionable, we're stuck in quarantine upon arrival anyway. And so just marking time and watching like everybody else watching to see what happens. I was supposed to be going to the island on 3 June, and that's not happening for obvious reasons. So it's wait and watch and keep our fingers crossed.
Hey, Jeff, just remind them that HOA stands for Hams on the Air.
Is there a decal or a logo for that?
I don't know. I just made it up, but that's your first step is to fix the bylaws of the name change. Okay.
I'll take that on as a challenge and create said logo. I'll do it.
There you go.
And I see, speaking of serial interfaces, I see the Drake line that is behind K5TR down there. What's the story on the Drake line, George?
Well, I got into ham radio about the time that was on the way out, I guess. Some of the last ones were made in like 1978 and 79. I was licensed in 76. I got to use the Drake line a few times. We had one at I think there was one hanging out at N5AU that was used on 160 a lot, and I operated several times at K5TM station, and he had actually 2 Drake lines. That was very impressive. 2 SO2R, sort of before SO2R, early beginnings of that. 2 Drake lines with L4Bs, and I always wanted a Drake line. I came close to buying one, but I bought a TS930 instead, which was probably a much better thing to buy than buying a Drake line in 1983. But I always wanted one, and I've been thinking about it for a while. And finally, about 6 months ago, I found a guy locally, and he had 2 R4Cs. And I said, okay, I'll buy those. And they were at the right price. And then over the next couple of months, I collected all the other bits and pieces to have a complete station. And it all works. And I didn't have to do much on it to make it work. So I'm very happy. And the receiver's full of crystals, so I can listen to lots of shortwave bands. That's the story on my Drake line.
Very cool. Very cool.
Comment on Drake, Tim?
What's that?
Comment on Drake, if I may.
Sure.
2 years ago, we were at PJ2T, we were planning to do the 50-year reunion of WNFJ's 1967 win, and I proposed to my guys that we set up one of the stations with a C line, just to be true to the era. And they laughed me out of town. I thought it would be fun. and romantic, and it absolutely didn't happen. And my other Drake comment is I was lucky enough to be Bob Drake's double E classmate at the University of Cincinnati way back in the 60s. Pretty cool guy. Thank you.
Oh, that's a great story. Ed, W0YK, you did have your camera on there before. Maybe you stepped away. Wanted to see how things were with the wine business these days. And Marty, are you staying busy? And let's see, you're a senior this year, is that right?
Yep. Yeah. I have a virtual graduation in a couple days. Diploma in the mail is how they do it these days.
Well, that's great. And where are you going to go to college?
Northeastern University in Boston in the fall.
Okay, and you're going to be studying?
Electrical and computer engineering. So thank God for ham radio. It did some good for me.
Great. Do they have a ham radio club there?
Yes, they do. W1KBN, which is their wireless club. They have a nice tower, and I know I need to make sure I don't spend too much time there and more time studying, but I'll make sure to pay a visit to the club, certainly, during my time there.
Oh,
Marty, we all said that, but it's not going to happen.
Yeah, I've heard DG's, maybe Doug could comment on his, did you major in ham radio or engineering there, Doug?
About 50-50 mix.
I am curious, Marty, has Northeastern said anything about in-person classes yet?
Yes. The president was on CNN last night saying quite confidently how they plan on opening on the fall. When people ask what I think, I'll see it when I believe it. I believe it when I'll see it. And I'm cautiously optimistic.
Well, there's Dr. Beldair from Missouri. Ward, how are things? Yep, you're muted, Ward.
Leave him muted. We like him better that way.
Unmute, Ward. There we go.
Oh, I'm a CW guy. Who cares? It's like, yeah. Well, howdy. What a great morning of stuff. It's interesting. We had receive antennas and ionospheric stuff, and then we learn way more than any mortal should ever know about serial ports. It's cool. So we got a big lineup coming up. So yeah. All set. I'm grounding and bonding. I'm ready to go.
So is it a full-time round-the-year type job that to put together the ARRL handbook?
Yep. It never goes to sleep. There's always another bus coming. And so I have a giant list of things headed for future editions. I'm always collecting stuff for handbooks and antenna books.
Oh, that's great. Thank you for all your hard work on that. And Doug, we need to have an EME update, 2-meter EME update now, please.
Oh, that's life after HF is EME when there's nothing left to work on HF. So I'm just waiting for the moon to come in a little bit closer at the end of the month, and the degradation to drop down a little bit so I can get on and work a few more guys. I saw W5ZN check in on the chat there a little while ago, sending me some ROs. So RR back at you, Joel. But I have very important inbound traffic, by the way. OH1RX, who apparently is watching, just texted me something about a Finnish version of Cabrillo. Let me see if I can get that up on the camera here. It's actually Carillo. I guess they're a little spelling challenged in Finland, but it says original Finnish bitter since 1969, so it predates the Cabrillo format. 21% alcohol by volume. So there you go.
That's great. How about
you'd have libation fading if you drank too much of that.
In the Santa Barbara and Ventura area of Southern California, there are 3 exits in a row. I don't remember the order: Castillo, Cabrillo, and Carrillo.
Nathaniel, you just speaking of HOAs, you just purchased a new place outside of Scranton, right?
Oh my gosh, are we lucky? um, I was watching Frank LPL's talk about like antennas for small lots and large lots, and I think we can actually consider doing some of the large lots now. So we found this property that's only 15 minutes from the University of Scranton where I work, and it's 28 acres on the top of a hill adjacent to 3,000 acres of state game land. So it's like far away from electrical power structures that I think will be noisy, and it's up high, and it's only a 15-minute commute to work, and there's this beautiful field where you could put antennas and towers, and so it's very exciting.
Will you need a generator?
Well, we do have power that goes out there. It's just the poles go up to just the edge of our property, and then they have the power underground from that pole into the house. So I think it should be a pretty good situation.
Super.
Yeah, right now I'm renting. My wife and I are renting a house where I am right now in the right in downtown Scranton, which is in the valley. And then the antenna I have set up, I have a G5RV, a shortened one that is sloping, which I know you're not supposed to do, but I have a sloped G5RV going broadside into the hill in the back of our antenna. And the reason it's into the back of our house, and the reason it's sloping is because there are power lines that go diagonally across the back of our backyard. So I have to slope underneath the power lines to get that safely there. So it will be very nice to move to a property where we don't have these restrictions anymore.
That's great, Nathaniel. Looking forward to you putting up additional antennas and having fun up there.
Thank you.
Ray, how are things down in Texas?
Things are going pretty good. Just staying busy with daily work things, helping the guys troubleshoot some installations of remote software and things like that.
You had a comment about some of the connectors or connections for the IC705.
Yeah, playing around with the prototype, it was interesting to see that there were Ethernet settings for audio, keying, and a few other things. So that is a direction that we're going into.
You talk a little bit about the IC705. That one's new to me.
It's our new QRP radio. Hopefully will be coming out in the next few months. Because of why we're doing this remote, there's been a delay in the release of the product. So hopefully some good news over the weekend out of Japan on what's going on with that radio.
Does it have USB and Ethernet and CIV like others?
Right now, what we have seen, there's really no documentation on the capabilities. There is Bluetooth connectivity, USB, Ethernet, as well as wireless LAN. So it has the whole gambit available to it.
Thank you.
Very cool. I see Terry's got her camera going. Terry, how are things at CTU headquarters? You're muted.
Things are going well.
Good, good. Thanks for taking care of the website and the refunds and everything else that, well, I'll tell you, you know, when you have 500 people for dinner, 300 people for CTU and top band dinner and all this thing collapses around us, Terry took it on and has made it work smooth. So thank you for all you do, Terry.
You're welcome.
So there's Ed, W0YK. Ed, how's the wine business at the moment?
Well, as you might things, it's pretty slow in most markets. The one thing that had a very small uptick is just a lot of people wanting to support small businesses, put in orders, you know, curbside pickup or home delivery orders. So that was real gratifying. But in terms of substantial business, it's really rolled off. Here in California, the tasting rooms are destined to open, we think, in another couple of weeks, along with some of the restaurants and all. So hopefully it'll be a phased opening and we'll get going more pretty soon. But we're off to a big start in the vineyard. So very busy these days. Things are growing leaps and bounds.
Well, that's good, Ed, and thanks for all there. Hey,
Bill Faring with the wine club.
Bill's got a bottle of Munn's wine. That's great.
I hope he brought enough for. I hope he brought enough for everybody.
Munn's Vineyards, a fine local brewery. Terry, I think your audio is still on. We're hearing some radio or TV in the background. You might want to mute. Thanks.
Say, Bill or Bob or somebody, I have a couple of technical questions. One is, how can I turn off these pop-up notifications on the chat? I searched the web and it.
People have been asking that. The best I found is to pop it out into a separate dialogue and then drag it off slowly into the corner, so you only see a little bit of it. But that's something Zoom should fix.
If you press you do the pop out and drag it, hide it, you can minimize the window. That's what I'm doing.
Hey, Tim, I have one more comment I'd like to dump in.
Sure.
So just wanted to thank you for organizing all this. It's really phenomenal to see these giant lists of people that are tuned in and watching these presentations. It's fantastic. And I also want to give a shout out to Whiskey for Victor Papa Zulu, who I see on the attendee list. She is interesting to me because she and I were kindergarten classmates in Huntsville, Alabama. Back to Ned.
That's very cool. Corey, do you have any fun facts for us? You're a data guy. Do you have any fun facts about Contest University today?
At the moment, I mean, just trying to pull down all the data. People are still registering and joining as we go throughout the day. YouTube stream's been played back almost 3,000 times so far. We got about 309 concurrent viewers, about 2,100 people as attendees watching us right now. So glad to see everybody out there. Most of us, 86% are from the US. And so we've got some more data we're going to pull from it, but it's really good to see everybody out there. Glad everybody can make it today.
Okay. Thanks very much for the update. And Dr. Dave, KM3T, you're going to continue to be the moderator here. How are things in New Hampshire?
Great. We're in spring, I think. A nice sunny day here, and thoughts turn to 6-meter DX. Little known fact, I got my start in contesting through VHF contesting. I stumbled on one June long ago. So on 24-hour 6-meter DX watch alert here with the renewed interest in operating there. And I've been doing a little bit of something else that I haven't really done in ham radio in the last 40 years, and that's a little bit of satellite operating. So having some VHF fun on a little break before the fall contest season.
Great. Are you doing any biking at all, Dave?
No, right now I am waiting for my wife to get one, and then we're going to go together. We're doing a lot of hiking though. A lot of mountaintops locally. We've been doing that pretty strenuously for the last couple of months.
That's great. Well, thanks for all you do, and I really appreciate your help and all the other moderators here today. Scott, N3RA, everything okay over there in Ohio? Muted.
Everything is good here. It is raining. What a shock. We're starting construction of the Arc here later this afternoon, so anybody wants to help, feel free to come over. Hopefully spring actually occurs eventually. They keep telling us there's rumors of good weather on the way for next week, so hope spring's eternal. And, looking forward to that.
Worked anybody good on FT8 lately?
No, I haven't been on the last couple of days much. Just got finished 6-band DXCC there, and 6 or 7-band worked all states now, just trying to finish up some 6 and 10 meter stuff with my my trusty old dipole.
Very good. Well, I'm sure if there's an opening, you're going to catch it. So let's bring Marty up. Marty, are you ready?
I am always ready. I am
all right. Great.
So ready.
All right. Well, you're going to talk about what's going on with youth. Marty Sulloway, NN1C. He's 18 years old. You can find him on the bands in most major U.S. and domestic radio sport contests. He's been operator at various contest stations over the years, such as ZF1A, W1KM, KC1XX, K3LR, K1LZ, K1VR, K1IR, BY1AAA, and in Israel at 4X6TT. Recent contest successes: Marty, first place USBE in both modes of ARRL, unlimited low power, that was in the DX contest, and claimed #1 in the World Unlimited Low Power in the CQWPX SSB 2020. He enjoys digital, CW, and SSB operations, and he's also a proud member of CW Ops. So Marty, the floor is yours.
Well, thank you very much, Tim. 1 second here. We're just got to get the screen share going, and we'll be off to the races. Let's see. Can you see the screen?
There we go.
We're good. Okay. Well, hello, everybody, and thank you so much for letting me jump in today to talk about a subject that is very near and dear to my heart in amateur radio, because it's you know, my introduction, my life, and channel I live, which is kind of youth in contesting. So how we're going to do this today, I'm going to talk a little bit about me for a second, but Tim kind of gave you my story there, so I don't need to dwell on that too much. We'll run through some slides, probably about 15 minutes or so, and then I'm going to open it up to you, the audience, because I know there's over 2,000 of you, and I assume and hope that there's some questions to ask. But before that, I just wanted to say thank you to Tim for an excellent program today, and Terry, Kate, MNJ, and everybody else at CTU, Ray, N9JA for making CTU digital on Zoom happen, because this is just fantastic with so many people on, and I'm proud to be able to join this awesome crew of people working on this. So a little bit about me. As Tim said, I'm located outside of Boston. I got my start in contesting in 2015. I used to be that long call KC1 CWF, and I've gotten to play radio at a lot of cool places. So I'm quite fortunate and lucky. Outside of purely contesting, I'm kind of a radio tech guy. I've done a lot with remotes and designing hardware for contesting and ICOM radios and all different sorts of stuff. So ham radio is what I live for, and contesting is the highlight of that. So we're talking about youth and ham radio, young people in ham radio, if you will. And when people always ask me, you know, is this something we need to worry about? Is this something to think about? Why should we bother getting youth in ham radio? This seems silly and a waste of time, and young people shouldn't be interested, and it's all old school, yada yada yada. So a friend of mine, Jim K1IR, had this slide about youth, young people, and the ages of people and contesters. And it has to do with the really fantastic CW membership club, CW Ops. This is the membership of CW Ops as distributed by birth year. What you can do with this data is take a good look at that big peak in the 40s and 50s. I call that the problem. Because what you can do is you can do a little bit of analysis and figure out when using the average age of those people and their expected lifetime, you can figure out when they're going to die. As sad it is, this is the graph that's going to show the membership of CW Ops if we don't change anything today through the next 10, 15, 20, 30 years. And it's pretty grim. You can see that at 2040, 20 years from now, the majority, actually the plurality of the membership has disappeared. So it's a serious interest. It should be a serious interest for people in the hobby to want to cultivate youth in amateur radio. So here I am today trying to drive a focused effort to invigorate the next generation. So we talked about that big circle I circled, and I called that the problem. Well, the good news is there is a solution. That solution is way down in the bottom of that data, and that post-1990 group. So those are people kind of who are from age like 28 on, if you start at 30 on, if you start in 1990. So what I want to do now that we've looked at my logic and my inspiration and a little bit of humor to kick this off, I thought we'd do a brief kind of overview of some of the youth in contesting landscape here in the U.S. and around the world. And so the way I'm going to do this is I'm going to just talk about a couple of kind of the popular or more well-known programs that have to do with youth and amateur radio in the U.S. and the world. And then afterwards, I'll drill down with a couple thoughts, and that'll be that. So the first thing is just this kind of list here. We're going to talk about YODA, Youngsters on the Air, their youth contest program in Europe, Youth on the Air here in Region 2, the Dave Coulter YDXA, which is quite near and dear to a lot of people's hearts, especially regarding Hamvention, and Team Exuberance, something I have to do with, and then another up-and-coming program in the U.S. called YARC. So let's get going on this. The first program, it's actually kind of the program with the longest pedigree in the youth and contesting landscape is called Youngsters on the Air. It's a program that exists in IAR Region 1, which is Europe, and is active in engaging youth to go to European multi-operator stations to do contests together in youth-led, youth-focused teams. You'll hear me talking about throughout this presentation the importance of activities that young people do that are led and managed by them. I think it's very important that when people are taking activity, they can take some ownership and leadership for that. And I think there's a lot of skills you can learn as a kid if you have the opportunity to not only say, go operate a big station, but do all the strategy and the planning and the logistics for that. There's a lot of good skills along the way you can learn. So YODA in Europe, a huge success. They not only do multi-operator contests, and you can see my friend Tomi H8RT in that picture on the left with some of his friends at I believe that's at Lima X-Ray 7 India. They also have annual camps in the summer in Europe, and we'll touch on that in a second. And really just a great thing. So in the U.S., a group led by Neil Rapp, WB9VPG, said, whoa, they're doing a lot of great things. How can we bring that to the U.S.? How can we bring that to the Americas? And with that, Youth on the Air Region 2 was born. Now, their first big project was a summer camp slated for this summer. Unfortunately, COVID-19 has pushed that back, but that is going to be pushed to summer 2021. And certainly contesting and DXing and lots of really important skills for young people in amateur radio. Kit building workshop. I know they have it's a week-long summer camp that they're putting together in Cincinnati, Ohio, about all things ham radio and especially contesting and DXing. And I know ICOM is a proud sponsor of that. So Youth on the Air Summer Camp 2021 will be certainly an amazing opportunity for youth in here. And also I know that they have a lot of other programming in store. And two components of that program that I thought were worth highlighting were, number one, myself and my dear friend and ex-WRTC participant and just operator and human extraordinaire, Bryant Rascal, KG5HVO, will be presenting there along with myself in a workshop about contesting. And Tim K3LR, who is the master of ceremonies here at CTU and amazing multi contest host and ADRL Foundation member and has done so much for amateur radio, will be the banquet speaker at Youth on the Air 2021. So if you don't know anything about them, check out their website and give them some love. I know they are doing awesome things, not only for contesting, but to invigorate youth in North America in radio sport and ham radio. The other program I wanted to highlight that involves with young people in contesting and DXing is the Dave Coulter Memorial YDXA, which is a organization which makes a yearly trip to some DX location with a group of children, and it's in honor of Dave Coulter, KB8 OCP, who is just a legend and did amazing work in amateur radio. And each year, the Dave Coulter YDXA fundraises and operates a trip to a different DX locale. They've been to TI Costa Rica. They've made several trips to the PJ2T contest station, where Jeff W0CG and others have graciously hosted them, and PJ6 Seba. And this trip isn't purely for contests. They're not really doing a contest while they're on these trips. But if you think about it, in a DX location, a lot of the skills that you practice in running DX pileups are just as applicable in contesting, and how we work people quickly and efficiently and pick out call signs. So that program is really special. It's an opportunity for kids to experience kind of the other side of the pileup, and for a really, really great cause. And they do good work. I'd also say that again, I can't stress this enough, that when you're engaging young people in an activity, letting them take ownership and run the show a little bit, is something that YDXA does well, and I think is so important in this next generation of contesters. When you want to, this is kind of more thought, but I'll throw it in there, which is, please, bring young people to your stations, bring new hams to your stations. But when you do, there's something very important to remember, which is, if you're a contester and you're showing somebody, a new friend, contesting, it's very important that you don't just say, okay, well, welcome to my station. I'm going to throw you on 160 meters at night, 160 meters during the day, and where you're not going to work any station in 12 hours, and you need to sit in that chair. No, engaging people in contesting is sitting down with them, mentoring them, let them get on 20 meters when the band's wide open to Europe. If you're not prepared to risk your score, you should really put learning and mentorship above contesting and developing the next generation. So great work that YDXA is working on and doing. The next program about related to youth and contesting, very specifically, is Team Exuberance, which is near and dear to my heart. Team Exuberance is a nonprofit. It's a 501c3 nonprofit founded by my dear friend Violetta KN2P, and is currently led by myself and Bryant, KG5HVO. And what we do is very simple. We create opportunities for young people to form serious competitive multi-operator contest teams at some of the best stations in North America. And we're very proud of what we've done. We had a hugely successful operation last March at K3LR in the CQWPX phone contest, and had another one planned for just 2 weeks from now in the WPX CW event. And what we do is we as youths plan and operate these serious competitions independently, with lots of mentor and adult support, but the only people touching the radios are young people. And we're proud of what we've done. Here's just some of the people who have been involved. You see Tomi HA8RT up in the top, who is an XWRTC op, myself in the middle of that top photo at K1 Lima Zulu on a Sunday afternoon in a contest, leaning back and relaxing when I should be focusing. Bryant, KG5HVO, my dear friend and amazing WRTC operator, just like Tomi. Violetta, KN2P, who is the original founder, and my friend David V7DZO in the bottom. So those are just some of the faces of Team Exuberance, and we are quite proud of the work we've done. We try and make all of our events and financially accessible to anybody who wants to take part. For both the last year's operation and this year's operation, we were able to launch a GoFundMe and raise several $1,000s so that the cost of traveling across the U.S. or across the world is accessible for participants and isn't a financial burden, to make these experiences something that's not just something that rich people can do, but that anybody can do, because we want to really embrace and cultivate and be that next generation of serious radio sport competitors. There is one piece of breaking news you see on the slide, which is fundraising paused, will resume soon. I'm very proud to announce that this morning, when I went to check the mail, I got a very important letter from the Internal Revenue Service saying that, yes, Team Exuberance is a tax-exempt 501c3 charity. So we are very much soliciting donations for our next operations coming up. We have a lot of exciting things planned. And please go to our website, teamexuberance.org, and click that donate button. Your donations are tax exempt. You'll get a receipt. And we seriously need your funds to keep doing the work we're doing. We want to bring more young people into contesting, mentor people, do more multi-ops, expand, grow, and really try and keep contesting going. So instead of seeing that CW ops graph with that slipping line down to 0, but a big spike for the next generation of contesters, because I know that amateur radio has done so much for me individually, both in my academic life and giving me research opportunities and business opportunities to I'm going to college in the fall to study electrical and computer engineering. I can tell you for a fact, if it wasn't for amateur radio, I wouldn't be doing that. And Tim has said it, and I'll say it again. Amateur radio just opens doors and changes lives. And the experiences I've had in this great hobby would not be possible if not for the contesting community and the amateur radio community at large. And I'm so grateful to be here today at Contest University among all of these great contesters, and just talking a little bit about what I'm doing and encouraging you to bring young people into your stations. And let's see a bigger growing movement of young people in amateur radio. So thank you so much. Those are the slides I prepared, and if we have time, I'd be happy to answer
All right.
any questions.
Nathaniel and Dave, what do we have?
Well, let's see. First question that just popped up is, Marty, how would you suggest that we get youth interested in CW?
So that's a really good question. Thank you for asking. I think CW is really where it's at as far as the cool skill to have in amateur radio among young people. A lot of my friends who are young are CW ops. Actually, from our SSB crew at Team Exuberance last year, the plurality, I think all but one of us were serious competitive CW operators. And CW is like a really fun game. You know, it's a challenge to learn, but there's a lot of great resources out there to learn CW these days. The CW Ops, CWA academies programs are fantastic opportunities to learn CW and digital groups that meet every week to practice and improve their skills. It's cwops.org, I believe, is the website. You can sign up for a class, and they have different levels of class of courses in learning your CW skills. So I would say check out the CW Ops site if you want to learn about how to learn CW. But I think the appeal about CW is tune down in the bands on any evening on 40 CW, 80 meters CW, and the CW is popping. CW is alive, and it's there's a lot of activity that you miss out if you don't. There's only so many characters, and I know I had a family member who's not even a radio ham who we practiced for a week, and by the end of the week she was slapping that key at 30 words a minute away. So I know you can do it, and CW is a lot of fun to learn.
Dave, do you have a question for Marty?
Marty, here's one. Do you think streaming of contests on websites like Twitch and Facebook, YouTube will become popular with young people?
So streaming, that's a very interesting question, right? Because, engaging on social media and the internet is a very exciting part of contesting, but it's very, very important that streaming is in no way an advantage to the contest. And I think, amateur radio contesting happens on the radio. And I think it's important that engaging with people digitally doesn't compromise the contesting or give people an unfair advantage or another way make the process different, right? I think if you, outside of contests, if you want to interact with people on social media, do live streams. I know DX Engineering does a lot of fantastic live streaming, or post your audio after the contest, or streaming your video, but not in any way enhancing the contest operations. I think a lot of the live streaming I've seen in the past seems to kind of give an inappropriate advantage to some people, and is unethical. So I think most of the larger contests have some pretty clear-cut rules on what's acceptable. And if you can follow those rules, I know Randy K5ZD has live streamed his audio successfully and legally for years. But there's a really fine line, and I think ethics and integrity are very important parts of this hobby. And if you're going to live stream, if you're going to share what you're doing digitally, I think it's very important to do that appropriately.
Nathaniel, you have
One other quick one for you, Marty.
yeah.
Was CW a significant learning curve for you, and how did you gain the confidence to go on the air?
I think Tim, were you interjecting there, Tim?
No. Go ahead and answer that question.
CW, that's a good question. So I learned CW using VE3NEA's Morse Runner, which is a fantastic piece of software that simulates what CW is like on the air. And I have to say, after spending many an hour on Morse Runner, improving my skill, and the first time I hit the air, it was the same thing. So I think it's there's no shame in being a new CW operator. We all want to work you. It's very exciting. Send at a speed you're comfortable at. And well, if you call me at 12 words a minute, I'll come back to you at 12 words a minute, because CW is something that should be accessible and not scary. And I look forward to working everybody here today who isn't on CW in next time I'm on the air, because I would love to work you.
You have another question, Nathaniel?
Yeah, first I just want to say it's neat that you use VE3NEA's Morse Runner program. Alex, VE3NEA, he has been, like, his software, I think, has really impacted amateur radio tremendously through teaching you CW. His software observing WW, the NCDXA beacons, has been skimmers, the RBN skimmer. I don't think we can underestimate the impact of his work. So
OmniRig, yeah, there's so many things that Alex has done. It's impressive, and it's been a big impact and benefit on the game. And I also say, Dave Cam3T is also in the background here. Has done a lot of work on skimmer and other stuff. So I'm hats off to him, certainly.
Mm-hmm. I agree. So the question says, Mark Williams, K9GX, says, I'm the president of the Kentucky DX Association. We invite locals to our monthly meetings via our Facebook page, presentations at local general interest clubs, and guest stops at my stations. It's difficult to reach out to young locals. How do we reach them?
That's a good question. That's a I think we all want the how to reach out to our audiences is always difficult to think about, but I always say, you can make it fun and give a demo and hook people in. I always love playing videos of contests when I go to a club and speak, or the appeal. I think sometimes contesting is thought of as old men in their basement grinding away for 48 hours, and that doesn't sound so fun. But to show the excitement and the joy of what we do, of contesting, and I think let's not make it that scary, unnarrated exchange. But if we can break it down and show people what we're doing, I think that's a good thing.
So Marty, a lot of clubs are doing their meetings on Zoom now. Are you available to be a guest speaker for a club anywhere?
I am. I've done a lot of presentations for Zoom and on Zoom for clubs, and it's something I love doing, and meeting new people in this hobby. If anybody has any questions or wants to talk more after this, just shoot me an email, nn1c@nn1c.org. I'd be happy to talk.
Great stuff. Dave, you got something else for Marty?
Yeah, so Marty, so in this age of internet, cell phones, instant worldwide communication, how do we get young people excited about the magic of radio? And what was
magic of radio? The magic of radio. Well, I think the important thing about amateur radio is it's not just a contest. It's not just one thing. It's this big opportunity for learning and excitement and science and technology and research and all the other, all of us know that turning on the radio is just one step in the whole spectrum of things we do. But I'll tell you, that magic of making a contact never goes away. I've spent days sitting at KC1XX next to Dave, listening to him run guys faster than I can ever imagine. And every time a new rare contact comes in, it's very exciting. But I think for amateur radio, to me, the excitement is just there's so many different things to do and explore, and scientific research and technology. There's so many cool things that I've seen developed in amateur radio and then done elsewhere. So it's just the best hobby in the world.
Nathaniel, do you have another question for Marty?
Yeah, this is kind of a follow-up to trying to get young people involved. But one person says, for years, I've wanted to get a radio club station set up at our local high school where I used to substitute teach. What resources are there on how to best go about doing this? Or what should I do first? What do you suggest are best steps?
Oh, that's a good question. And I know, getting into schools is a fantastic opportunity. I would say if you want to start a club, I think it's always best if, there's people interested, but that's hard to do. I've never actually started a club in a school, so I'm not an expert on that. But I'd say, getting a talk to administrators. I know that fantastic things that go with schools are high altitude balloon launches. There's a lot of cool crossover into science classes. And then that can kind of be a bridge I've seen done quite successfully into school clubs. And, once you get that excitement going, it's hard to go wrong.
I think a follow on to that too might be to say, you really want to try and find a teacher at that school who will be friends with you and who is interested in integrating it into their curriculum.
It's very hard to build that in from the outside if you have that resource. Yeah, you're a professor. You could speak.
Yeah,
to that
you
better than I can.
really need a teacher from the inside who's on board with you and really wants to. If you can do that, I think you'll go far.
Yeah.
So Marty, how young were you when you first got licensed?
Oh, that's a good question. I was probably 12 or 13 because it was, 12, I believe.
What sparked your interest?
What sparked my actually, I found amateur radio. I originally discovered on the internet, and I didn't know a single radio ham before I got licensed. I studied, took some practice tests, and took the test. But at first, I was on 2-meter repeaters and learning so much from all the locals, and then as soon as I heard about this HF thing, I just had to have a part of it. So I had a 10-meter ground-mounted vertical in my backyard with ungalvanized steel wire, which quickly rusted away, and that is what lit the magic of ham radio for me. So, thank you again, Tim. This is the most amazing hobby in the world, and it's so much fun to be here.
That's great, Dave. Last question.
Last question. So Marty, do you think, well, actually, no, this one, do you think, is there any data that shows the percentage of youth that do CW contesting versus sideband contesting that you know?
That's a good question. I mean, the data is out there. I don't know if it's been analyzed, but certainly CQ Worldwide makes all of their logs public. There are certainly methods that one could analyze the groups of young people who are doing CW contesting and phone contesting. I would say anecdotally, there's also RBN data. There's lots of sources of who's on the air. But I'd say anecdotally, most all of the young people I know are more on CW or more active on CW or just as active on CW than as phone. I would say there are, in contesting, I think it shouldn't be a scary thing. You don't have to be doing CW. But I don't think there's a huge amount of people who just do phone.
And time for one more quick one.
Sure, Dave.
Do you have any friends who are now hams?
Yes, I actually there's a group of four of my friends from my school who saw the antennas on the back of my car, and I took them to a station one day, and they were hooked, and we did I did a technician class there. So I think if young people teaching other young people about amateur radio, if we can do that, that's one of the best ways to do it, and that's the best hobby in the world. I can't emphasize that.
Awesome work, Marty.
So Marty, thanks very much for sharing your story here today. It's been great having you, and I'm looking forward to seeing you soon. And of course, looking forward to Team Exuberance coming back to K3LR next May. So
thank you, Tim. So thank you so much for for letting me be here. It's a lot of fun.
And I want to thank all of our moderators, but in particular, the last 2 hours, Nathaniel and Dave. Thanks very much. And I want to welcome our new moderators. That would be George, K5TR, and Trey, N5KO, will be doing the moderating. And once again, I want to thank Ray Novak, N9JA, who has been a sponsor of Contest University since we started this thing over 14 years ago. So thank you again, Ray, and thanks very much for spending the day with us, Ray. And okay, so let's get into our next presentation. I want to tell you a little bit about our presenter here. This is Ed, W0YK. Got interested in CW and SSB contests in the early 70s. And today, CW and RTTY contesting dominate Ed's operating. He's holds the world single op record in the ARL Ready Roundup. And he's broken that record 8 times. And he's also had highest scores in the CQWPX RTTY, and he set the world record in the single op high power category in the 2010 CQ Worldwide RTTY. He's a contest manager for the NCJ North American RTTY Sprint. He's contest director for 2 CQ RTTY contests, and he co-sponsors the 10-meter RTTY contest, and he also led the contest committee that launched the worldwide Digi DX contest for FT4 and FT8. Ed was inducted into the CQ Contest Hall of Fame in May of 2014. This is his 13th year at Contest University, and so we welcome Ed Munns, W0YK, Digital Contesting Hints and Kinks. Go ahead, Ed.
Thank you, Tim, and to everybody behind this. It's been a tremendous project that you've pulled off as an audible to COVID-19. And welcome to everybody out there in Zoom land. This presentation, actually in the live CTU that was going to happen, we were going to do 3 presentations, 2 on RTTY and 1 on the new FT8 and FT4 digital contesting modes. And I've compressed it all down into about 40-45 minutes by just going through and taking some highlights of what I call tips or hints and kinks, different points, rather than trudging through all of the detail of these various modes. So let's get after it. First of all, let's take a look at AFSK and FSK. Those 2 terms, along with RTTY, are kind of used generically to talk about this mode. But in fact, these 2 terms have very specific meanings that are very important to understand. So just as a kind of review primer for most of us, you'll notice that the last letter in these mnemonics is K. That stands for keen, and that's talking about keen, the transmitter. Once the signal is on the air, there's no difference between AFSK and FSK, with some minor caveats to that. So here's what most setups look like today in comparison, with AFSK on the left here. And you can see that the computer is connected to the radio. Sound card is used for the audio, but you notice FSK has a slightly different wiring. And let's talk about AFSK first. The receive audio from the radio goes into the sound card, and then the software decodes that and prints it on the screen. In the opposite direction, sound is produced by the sound card and feeds into the audio input, the mic input of the radio, and that gets converted to RF signals that go out on the air. In the case of FSK, it's identical to CW keen. You have the same kind of keen interface that TV Bob showed in his presentation a couple hours ago for keying the FSK and push-to-talk lines directly if the radio has such an input. Just like all radios have a key input, if they also have an FSK input, then you can key that directly without using audio. So the sound card's not involved in transmission, but you just use a COM port today via USB to do the keying. The important thing to keep in mind, no matter how you use these terms, is that on the receive side, it's identical. So there's no difference on receive between the 2. Now there's one of several reasons why understanding this is important, and it gets into the dial frequency. Oftentimes in RTTY, you'll find that a manual spot is wrong. It'll be off by 1 or 2 kilohertz. And that's dependent upon what the local audio frequency is by the person doing AFS keying. So let's just start at the beginning and look at some definitions. In RTTY, the frequency that we use to communicate what frequency we're on between operators is the mark frequency. So as you know, there's 2 tones, a mark and a space tone. They're 170 hertz apart. And in the RF spectrum, independent of how the signals are generated, the higher frequency is the mark frequency, and that's the definition of what the quote-unquote RTTY frequency is. And so I just given an example here on 20 meters with 170 hertz shift. In radios that are being operated in the FSK mode, almost always the display, the dial on the radio displays the mark frequency. So that's pretty simple. You know, it's just like any other mode, and so you should be able to have spots that are unambiguous. Unfortunately, in AFSK, most radios display the suppressed carrier frequency, not the resultant RF mark frequency. And so depending on whether you're using upper or lower sideband, and if you're in AFSK, you could be, or you will be spotting a frequency that's off where you are, and the other person will have a little bit harder time finding you. So that's why some of the spots appear off when you look at it. So a few notes about receiving. You might think that with 170 hertz separation between the 2 RF frequencies that you could use a narrow filter like a 250 hertz CW filter, and that will work. But as you see here in this diagram on the top left here, the spectrum, the audio spectrum, is not flat. It's rolled off due to the characteristics of the filter. And what's better to use is a 500 hertz filter. And the reason for that is that all of our software decoders nowadays actually use most of that 500 hertz and even beyond that. But the biggest value of their algorithms is having signal data and noise data within a 500 hertz bandwidth. So when you roll that off with a narrower filter, you actually have more errors in the decoding. You have less reliable decoding. So it's best to open that up to 500 hertz. If you have really, really extreme QRM to where your IF is really getting hammered, sometimes going down a little bit narrower than 500 hertz will help because of that aberration. But frankly, even when I operate in DX locations with huge pileups and lots of QRM on the band, I very seldom go below 500 hertz. The decoders sort all that out really good. And then secondly, down here at the bottom, I was a big advocate of these 2-tone filters that are in all the ICOM radios, and I persuaded the K3 people 12 years ago when they were in the early days of the K3 to add one to the K3. And it turns out, for the same reason I described up here above, that actually deteriorates the copy of the signal in some borderline situations. So here's what a 500 hertz filter would look like. You can see the noise floor is flat across there. And the point here on this slide is to set your audio level, your receive audio level, as low as you can and still have just a tickle of noise at the bottom of the screen. What that does is maximize the dynamic range of your signal. So if you get a really loud signal, it doesn't saturate on the top there. One of the skills that I encourage people to develop, and it can be done in about 10 or 15 minutes, it's pretty easy, is to close your eyes and learn to tune by ear. Just learn, for whatever audio tones you're using, to be able to tune and get pretty close. And with just a few minutes of practice, most people can get within 10 or 20 hertz, which is enough for most decoders to capture and decode the signal. And then you can tweak it in with the RIT or the tuning as you wish, but you can get very close by ear, and that's a very handy skill to develop as you're tuning across the band. Next up is the topic of AFC. I personally don't like AFC. This is automatic frequency control, where the audio frequencies in the radio are dithered to 0 beat with the signal. So if you're running, for example, and somebody calls you off frequency, it will automatically tune them in. And that sounds pretty nifty, but I personally don't like it because I don't like things that are happening to my radio that I'm not in control of. And an example of this is that, say you're running and then you go off to search and pounce and you forget to turn off AFC. Now, when you get close to a running station, your receiver will capture it, but your transmitter is still back off frequency, and you'll be calling them off frequency. And that's the number one cause. 99% of all the off frequency callers have AFC turned on when they're doing search and pounce. So most of the decoders have a second function called net, N-E-T here, that is used in search and pounce. And if you turn that on, that will then move your transmit frequency to the receive frequency. But of course, this only works if you're transmitting with AFSK, right? Because if you're transmitting with FSK, you have fixed mark frequency through the radio, and so the frequency cannot be adjusted. Just some notes here on AFSK adjustment. This is a good checklist to go through if you're running AFSK, and I think it's all self-explanatory here. One of the reasons I prefer personally FSK is that I don't have to worry about this adjustment during the contest. You know, if I hit a knob inadvertently or change bands and something changes, I could either have too little output or too much and be in distortion. So let's talk a little bit about RTTY transmit bandwidth. This is very much a replay of the old CW click caper that we went through decades ago with a number of radios and had to be fixed. It's very much the same kind of thing. And to the extent that you have an unnecessarily wide transmit signal, it creates two problems. One is you're wasting a lot of power that's not going to be utilized on the other end for decoding. And secondly, you're creating unnecessary QRM on the band. So let's look at some signals. If you start in the top left here, this is MMTTY unfiltered. And by unfiltered, I mean there's a parameter in MMTTY for a tap filter. And if you turn that off, this is what the AFSK signal looks like on the other end. This is how it is in a band scope. This happens to be a flex. If you turn on that filter with the setting of 48 taps, you get a somewhat narrower filter. And if you select 512 taps, which is the maximum setting, you get a pretty nice filter there. And if you look at two-tone, which is another decoder I'll talk about in a minute, its AFSK doesn't have these different filter settings. It's already filtered, and you can see that it's about the same as the 512 tap filter, a little bit cleaner as you get further down. Two-tone also has a DOOK filter, or mode, I'm sorry, that actually has even narrower bandwidth, and although the skirts are a little bit higher here. So it's very important. Oh, and by the way, MMTTY comes default with the 48 tap filter on. So make sure you go in and change that to 512 taps to have a narrower transmitted signal. Now, if you look at the difference that the power amplifier IMD has, with 1 milliwatt, here's a 5-tap MMTTY filter. That same radio cranked up to 100 watts, you can see how the signal widens. And as comparison, the K3 is the only radio I know that has a built-in AFSK filter. They also have an FSK filter, which I'll talk about on the next slide, but this is for AFSK, can be enabled, and you can see that it's cleaner but about the same shape as what the MMTTY top filter is. And if you use both of those together, then you'll get the cascading effect and a little bit better filtering. Okay, for FSK, this top graph here you can see is quite a bit different than the ones that we saw previously with AFSK. And this is what every radio, with the exception of the K3 today, generates. And so if you're running 1.5 kilowatts with a FSK signal like this, it wipes out a number of channels on each side of you with QRM. Now, the K3 7 years ago in their firmware introduced an FSK filter, and every manufacturer could do this. That actually narrows that down so it's comparable to the AFSK filtering that we showed previously. So the K3, and you can't turn that on or off, it's just on all the time, actually puts out a very nice FSK signal. Okay, UOS, which is unshift on space, is a feature that was created a few decades ago for radio teletype operation. That's based on the premise that the spaces between words are most likely, in all probability of just kind of open text, of preceding a text character. And if you know about RTTY, there's 2 character sets, basically letters, and then a figures character set. And there's control characters that switch between them. And if one of those control characters gets knocked out by noise, the character set doesn't switch, and the person on the other end is decoding numbers from the code instead of letters, and so they get what looks like garbage on the screen. So this feature, most people use. A lot of software has it on by default, and so the recommendation is to turn on both receive and transmit UOS. So receive UOS automatically assumes, following a space, that the next character is going to be a letter character, so they set up for letter character set. A transmit UOS says that if that's not the case, if the first character after a space is a number, then they're going to actually transmit a figures character. And so that's what those 2 definitions mean. So for example, in MMTTY, on the main panel, there's a UOS button. You want to make sure that that's enabled. But you have to go into the option menu up here and go to the TX tab and actually enable the TX UOS. And so you want to do that. By the way, these different parameters I'm talking about in MMTTY, if you want to not have to set those every time you load MMTTY, every time you run it from what the defaults are, you can go into the user para.ina file and set these for all your profiles, so they'll always come up in that mode. So here's a basic RTTY QSO. I'm using CQWPX RTTY contest as an example, and basically, as I think most of us know, there's 4 basic phases in a QSO. Those are the first 4 lines here. So the black is the running station, and the orange is the search and pounce station. This 5th one is really the same as the first one, right? It's the CQ, or the offer to take more stations. So even though it's a thank you, it's also the CQ, and so it's really the same as the first. So there's 4 phases here. I've shown these 2 calls on these 2 messages as optional. You see a lot in RTTY that these calls are put in. People think that reduces ambiguity, but I found that it's no different than CW. We don't do that in CW very often, and it's really not needed. So those I claim are optional. Just a small list here of things to think about with your messages. Keep them short. RTTY comes from a legacy of long brag tapes and rag chewing, and sometimes that migrates into the messages, but keep them short. Do it just like you would on CW, with a couple of minor exceptions. So no extraneous info. Don't use 5NN. That makes sense on CW because it's a few less character links. But in RTTY, the character links are all the same, they're fixed. And so do 5NN, and that way, what we talked about earlier with the character and letter shift is not happening and lengthening out the transmission. One difference with RTTY is you always want to send a unique information like a serial number twice, because unlike CW, where we have lots of other audible clues to let us know whether possibly we copied it wrong or we're not quite sure, in RTTY you just can't tell. You can tell that the signal was transmitting, but you don't know whether you got a noise hit and got an error. So you want to get two, and if they're both the same, you can feel pretty confident that you got the right serial number. Use space, not hyphen, between you see in all of these messages. Some people use hyphens. I recommend to use space. I'll talk about that in a minute. Omit the DE. That's not seen very much now, but don't want to do that in RTTY. For one thing, it's the state abbreviation for Delaware and gets confusing sometimes. And then this is an example with WriteLog, but N1MM has their own set of special RTTY characters to start and end transmissions. So here's just an example of what that looks kind of blown up. In RTTY subbands, you can get online, and we have outlined where the various RTTY subbands are. Basically, they're between CW and phone on most bands. But the important thing is to be aware of a few spots that you want to avoid QRMing. Of course, the NCDXF beacons, but also there's a swath of a number of audio digital signals, mostly the FT modes nowadays, but PSK and JT modes and so forth, between, for example, on 20 meters, 1470 and 1483. So it's best just to stay out of there. Even if you don't hear any signals in there and you think the frequency is available, you'll probably get QRM'd and chased off. So it's just easier to avoid those signals or those subbands. Also, I should note that in contests, the RTTY subbands will extend quite a bit. They'll go clear down into the CW area and up higher than kind of the daily RTTY subbands. In fact, speaking of daily, it's very difficult to find a RTTY signal outside of a contest or some DXpeditions that are still doing RTTY. You almost have to go to a contest to find RTTY. So some considerations, I like to use a zero-based budgeting or thinking about RTTY to just say, what will we do in CW, and do that with RTTY, and only deviate from that for known reasons, substantial reasons like I talked about with the serial number. One of the traditions that I haven't been able to break in the RTTY domain is this adding a CQ at the end of a message. And so it's better just to fall in line and do that. Otherwise, people on the air will be more confused if you don't do that. But CQ messages end with CQ for the most part in RTTY, just by tradition, just by precedent. Set your headphone volume low. You don't need to have it high so that you can discern the tones, because I don't know any human beings that can detect it, can decode it anyway. All you want to be able to do is detect the presence or absence so that you can have your timing down for transmitting. Remember that key down transmission, it's 100% duty cycle. It's like taking your CW key and putting a brick on it like the old Alpha ads. And one of the things I would recommend avoiding is all the distractions that are tempting during RTTY. When people start with RTTY, they think, gee, there's not much to do, so I can watch TV or my email and so forth and so on. But it turns out there's lots of ways that you can occupy yourself and increase your contest scores without watching TV. So a few miscellaneous tips. We talk about upside down. This is where the letters and figures cases are reversed. And that can happen when either in your radio, you've got mark and space logic reversed, or you're on upper sideband, but you've set it up for, you set the configuration for in RTTY for upper sideband, or like I said, figures and letters. And one of the things, if you're not aware, on a keyboard, all of the numbers here across translate to the letters right below them, depending on whether you're in letters or figures case. So if you see something like TOO, most of us know that that's 599, but you can see on the keyboard here that's exactly what it is. T is below 5, and the O is below 9. And in most loggers, one of the things you can do is hold down the shift key when you click on a number like this, like say the serial number is this WPIR. Click on the W while you're holding the shift key down, and it will translate that and put the number into your exchange box. So that's good. Some things on the transmit side where you're copying perfectly, but people are not coming back to you. Again, you may be upside down, the same thing as before. You may be off frequency, like we described with the AFC discussion. And you may have your levels set incorrect, either too low or too high to where you're distorting. And you may have maybe in the wrong mode or have the wrong tones. You may have something wrong with your FSK interface. So a number of things that can affect transmit. Just like almost anything that we do in life, the more practice, the better. And there's lots of opportunities for that with RTTY. There's RTTY contests almost every other weekend on average. And every Thursday night, there's a 30-minute practice session that the NCCC hosts, so you can check out your system and keep up your operating skills. And as a number of presenters have already noted, even today, multi-ops are a great way to learn anything about contesting, including RTTY. Let's see, why isn't there we go. Okay, let's move on to sailboat racing. What's this all about? Well, I'm going to diverge just for a second here and talk about a phenomenon in sailboat racing, which is called slow down to win, and how it applies to call sign stacking. So just as a little primer for those of you that aren't haven't done sailboat racing, buoy racing, where there's 2 or 3 buoys set out on a body of water, and sailboats race around those buoys for a couple of laps, involve what's called mark rounding. So this is a buoy called a mark. And as boats are approaching this mark, you can see this is an example with just 2 boats that are neck to neck. But look at what happens. If you look at the geometry of this, the outside boat has to travel a lot further, and they wind up being behind. Even though they're sailing just as fast, everything else is equal, but because of the physical proximity of getting around this mark, they wind up behind. Well, what if there's 3 or 4 boats that are overlapped and pretty close? The outside boat is going to be way behind after they do this mark rounding. So one of the techniques, if you find yourself not able to get one of these positions on the inside, you find yourself on the outside in sailboat racing, is you just left off. You just slow down just a hair, and you fall in behind these boats and move over here so that you're traveling the same distance. Yes, you're behind this boat, but you stay behind them when you go around the mark. You don't wind up really behind them if you were 3rd or 4th out here. So that's the analogy that I like to think about, that I call slow down to win in call sign stacking. So if you want to stack call signs, and this is where you have more than one station calling you in a pileup, you need to be able to hang around long enough so that your decoder decodes 2 or more signals. And so it's important to discipline yourself to just skip a beat. I mean, literally a fraction of a second. And you'll get sometimes a couple of more calls in there. And as soon as you do that, you can hit transmit and start answering the first one. I like to answer everybody in the order that I decode them, because it keeps, I find that it keeps more order in the pilot. But whatever you do, go ahead and start transmitting. And then while the transmission's going out, you can collect those other call signs and put them in what's called your call sign stack, which is a memory that allows you to then roll into the next QSO. So just as a review, this is what a normal run QSO or a normal search and pounce QSO in any mode looks like. You have a CQ, a pileup, you send an exchange and you receive an exchange, and then you repeat it. And hopefully you repeat it really fast without any lost time. In call sign stacking, what you're able to do, here's an example where P49 X-ray calls CQ, 2 stations answer. P49X waits around long enough for a fraction of a second to get both calls. He calls the first one with an exchange, and then when with the exchange, and then when he comes back with the thank you, or when K3LR comes back with the thank you, P49X does not go back to a CQ. Instead, he thanks K3LR, and in the same message sends an exchange to K5ZD. So he's essentially skipped phases 1 and 2 and rolled right into this. Now, if you have enough call signs in your stack, you either get them from the initial key CQ or pileup, or you get them from tail enders, then you can just keep going like this and you instantaneously double your rate. So here's an example for tail ending. It's the same thing, except only K3LR was answered, but K5ZD came in during the QSO and dropped his call in once, just like you would on CW in a place that doesn't damage the current QSO. And then you can roll right into this call stacking routine that doubles the speed. So it's this is just a summary of what we just described there, and you can do that very efficiently with N1MM and with write log. Okay, multiple decoders. Why would you want to have more than one decoder? Well, because all decoders are not created equal, and by decoder, each of the decoders, both two-tone and MMTTY, have different profiles, that is, different algorithms that they use to decode the signal, and some are better in different types of band conditions, like QRM or fading or polar flutter. And so what you can do is set up multiple decoders, and sometimes one of them will copy when the others don't. And so if you happen to have the wrong one as your only decoder, you'll be having a lot of repeats. So just as a quick review, this is MMTTY. It's the first, it's kind of the granddaddy of all the decoders. It's been around a long time and is still very, very reliable and functional. A newer one that was introduced about a decade later is two-tone, and a lot of people claim that it's quote-unquote better. That's not been my personal experience. My personal experience in watching multiple decoders is that sometimes it's MMTTY that gets it, and sometimes it's two-tone. So I don't see a black and white preference for two-tone, so I use both. There's a third decoder that unfortunately is not well integrated into our loggers. It's pretty well integrated into N1MM. That's by Alex, that we've talked about several times today, the E3NEA, who wrote Skemmer and Morse Runner and all. And that's a very good decoder, and in some regards better than the other two, but as I said, not as well integrated, and so not used as often. So for multiple decoders, here's a simple example of using MMTTY and the DXP38, which is a hardware decoder, which people don't use much anymore. But this gives you two different decodings, and in 1% or less of your contacts in a contest, you may have one that decodes and the other one doesn't. Here's an example with using all MMTTY, but with 4 different profiles. I've listed a number of the profiles that come standard with MMTTY over here. And so you can set up 4 different windows, all looking at the same audio signal, and sometimes you'll have one of them will decode and the other ones won't. And so it just avoids a repeat cycle in your QSO sequence. Another neat way that you can use multiple decoders is if you have a second receiver, is to set up one of your decoders on that receiver, and you can use that for SO2V, which I'll talk about in a minute. But if you're not doing SO2V, just make your A and B VFOs the same, so both receivers are listening to the same frequency, and just put this decoder on a different profile. And so now you can have 4 profiles when you're just using one receiver, and you can go back to 3 profiles on the main receiver and 1 on the sub receiver when you're doing SO2V. So it's a way to quickly get between having an extra profile or an extra decoder. This is the typical setup that I usually use in contesting. These 4 red decoder windows are for the main receiver. The first one is MMTTY, These other three are three different decoding algorithms for two-tone. And then I have an MMTTY and a two-tone decoder on my subreceiver for SO2V. With multiple decoders, one of the things that I don't think I mentioned earlier is that I do is that I use low tones. You know, the standard default tones are up around 2 kilohertz, in fact, above 2 kilohertz. And that can get pretty fatiguing, that high tone, at least I find it, over the period of a contest. So I put my tones as low as I can get them, and I find it's a lot less fatiguing. So low frequency, low audio frequency tones, and low level on those tones. If you're doing SO2V, of course, you've only got 2 ears, and now you've got 2 VFOs, 2 QSO streams, conceivably. And if you're doing it with 2 radios, you've got 4. So that can get confusing to detect which transmission started on which radio. So what you can do is use low and high tones in each radio for the two receivers. So this is a little checklist on how to do SO2V. I won't go through it in detail today, but you can read it here. I think it's in fair enough detail on how to do that. And basically, the way I use this for the most part is I'll be running on one receiver and tuning the second receiver during the receive cycles for picking up multipliers and unworked stations up and down the band, and then interleaving the QSO phases between those two. SO2R is the same thing, of course, with 2 radios. And if you're good at juggling that, then you can try what I call SO4V, which is SO2V on 2 radios, and extending that. This is a good example of why you might not have time to read spy novels while you're doing RTTY contesting if you're doing SO4V and you've got lots of activity on the band. I personally like to use 2 different PCs and 2 different user interfaces for SO2R. So this is actually a pretty antiquated setup from a decade or so ago that just shows the 2 keyboards, 2 mice, in this case trackballs, and 2 displays. And this way I don't have to do any context switching. The context is physical, and I can use both of my hands on the keyboards. You know, in RTTY you don't do much typing if you set it up right. Those keyboards are really just special function keys, because when you hit a key, you can capture a highlighted call that's in a window, and you don't have to type calls in. This is a little process that I sometimes use for running SO2R in the Sprint, and so you can read through that and see if that can work for you, or you can get some ideas from it. So what about SONR? So this is basically a multi-op station that's run by a single op. And why would you do that? And how could it possibly ever make sense, since there's only 2 possibilities? You can either be transmitting or receiving. And so SO2R can interleave that. But how would you do it with 3 radios? Well, one example is you can dedicate a 3rd or a 4th radio to a given band. And a really good example of this is 10 meters, which except for very short times during the sunspot cycle is kind of iffy, and you don't know if it's in or out. And so, for example, one year when I was down in Aruba, there was a group in a couple of my friends in Galapagos. And so I just set this up on 10 meters. And when they were on 10 meters, I tuned to their run frequency. And while I was running on 15 and 20, I just glance over at my screen. And as soon as I started seeing call signs highlighted that I had not worked on 10 meters, as soon as the percentage of kind of new calls showed up based on SuperCheck Partial watching their run frequency, I jumped over there for a few minutes, grabbed some new calls at a high rate, and then went back to my other 2 bands. So that's one example, and I'm sure you can think of others. But if you have the space in the room, or you have the station you're using to be able to have multiple stations, that's a good use of a multi station for or by a single op. So here's a list of resources, websites, and discussion groups that have a lot of really great tutorials and information that you can get your questions answered with. Okay, let's move on to the FT modes. In the last 2 years, as I think all of us know, this has just exploded. Even if you're not, quote unquote, a digital guy, everyone's been affected by this. And I find more and more familiar CW advocate call signs on FT now and then, because that's about the only thing that's on the air sometimes these days. So there are three, right now, there are three major FT contests that are listed here. And the RTTY Roundup is actually the RTTY mode and FT are used together. And starting with next year's RTTY Roundup, like the 10-meter contest, you can either operate either mode or mixed, which is both modes. But in any case, you only work stations once per band. So whether you use FT4, FT8, or RTTY, just once per band. And then there's the new WW Digi contest that Tim mentioned. That's the last full weekend in August and kicks off the 4 weekends of worldwide each fall that was introduced last year. And that's FT8 and FT4 only. And then there's the FT Roundup, which is the first weekend in December. Unfortunately, it overlaps the 160-meter contest weekend as well. So subband choices, one of the things that is happening more and more, of course, with the FT modes is that all of the activity is in your receiver bandwidth. And most receivers have a bandwidth, audio bandwidth of 2.5 to say 4 kilohertz. And there are a number of times, even especially outside contests, where that gets very filled and it's hard to find a clear frequency to put your transmit frequency. And so what do? Well, the convention is that you just move up another bandwidth. And my recommendation is that everybody use even bandwidth. That is, you move up 2 kilohertz, because you don't know what the other person's bandwidth is. And so we sort of need a convention so that we're both on the same bandwidth. So an example is, let's say a station, say I'm listening with my 4 kilohertz bandwidth, and I hear a station up at 3.5 kilohertz. If my transmit frequency is down at 500 hertz, that station may not hear me if their suppressed carrier signal is 2 kilohertz above mine. So if we're not using the same suppressed carrier frequency, we could have that problem. If you want to work that station, it's advisable to move up and get within 2 kilohertz of them, move up to say, 2.5 kilohertz, and see if you can find a clear frequency to call them to make sure that you're in their passband. I recommend, and I think most people are doing this nowadays, is to freeze your TX frequency and always work split. So unlike the other modes where you call simplex in almost all the time, except in DXpeditions, in this mode, since you can see the entire bandwidth, you can see all the signals that are there, there's no reason to zero beat. In fact, there's a negative reason, because you create a pileup and create QRM on the other frequency that may disturb the decoding and delay the progress of the QSO. So the advice is to find a clear frequency, put your transmit there, and the way you lock it in on WSJTX, which is the primary software that most stations are using, is go and click this box here on the main screen. It says hold the TX frequency, and that will freeze that frequency. The other thing I recommend for decoding is go up here on the decode button and use deep. There's other modes such as fast, which decodes slightly faster in the cycle and gives you a little bit more time to see a call sign and to be able to select it. The problem with that, and I verified that with hundreds of hours of operating this mode, is that you get a lot less reliability on the decodes. If you do a deep decode, there's a lot more processing that's done, and I get far better reliability on the decodes, and I can decode weaker signals more reliably. So even in contest, I recommend using the deep decode. Now, what this requires, and we're seeing that a lot lately, is that you have a reasonably fast CPU, and that will help tremendously in that. There's another little thing here while I've got the screen up that says enable AP. AP stands for a priori, and what this is that in most, if you look at the messages down here, in most messages, the call signs of both stations are repeated throughout the messages. So once you've connected in the first message with somebody, you already know a priori what most of the message is. And so this is a function that's really clever by the WSJTX folks that automatically assumes those characters, those call signs in the next messages, and puts all of their processing power focused on the rest of the remaining bits, which is about the last third or 20% of the bits in that message, which gives you a much higher probability of decoding. The downside of this is that you get a higher percentage of false decodes. In fact, I've never seen a false decode except when I have AP enabled. It still doesn't happen very often, but you just need to be aware of that. It's pretty obvious if you get a pretty odd call sign that comes through.
5 minutes, Ed.
Okay, thank you. The other thing to be aware of in this mode is that you can be on even and odd cycles, and so if your rate is starting to drop off on one cycle, it's prudent to jump to the other cycle and to switch between those two. And if you're in a contest that allows both FT4 and FT8 modes, switch between those modes depending on rate, and just let the rate determine what you do. Don't assume that the intrinsic rate of FT4 being twice as fast as FT8 is going to be an advantage. And then for setting up for contests, for example, the WWDigi contest in the latest release of WSJTX, that's now a choice in the special operating activity, and that'll set you up for the correct messages. One of the main things that we've learned in the last 2 years of FT contesting is that there's a much higher rate of nils, on the order of 5% compared to 1 to 2% nils in RIDI or CW contests. And this is because for whatever reason, there's been a convention that's developed in everyday operating that even after a QSO is complete, that is both partners have sent their exchanges, both partners have sent a QSL message, one more QSL message a lot of people send. They send a 73 after this last QSL message. It's totally redundant. People think that that increases the probability that this contact is going to get logged, but it created just the opposite effect. It's created confusion because now the operators on both sides aren't quite sure if they don't receive this redundant message, whether the other person logged the QSO. And we believe that that's what's led to the much higher nil rate, is that the operators have a much lower percentage of the time where they agree that the QSO is good and they both log it. You can read about this on the internet offline about the old, back from the early 70s in the computer science world, the two generals problem or paradox, where you can QSL back and forth forever and ever and ever and never reach agreement, because you never know whether that last QSL made it through the noise spectrum to the other side. And so what we've settled on just in practice in ham radio over the years is that you do one QSL on each side, and then you just use the context of the QSO to decide whether you should go ahead and log the QSO. And that's what we need to start doing with the FT8 modes. So this is the recommendation. As soon as you receive an RR or any of these three messages, these are the three QSL messages that are commonly used. Different stations may use different ones. As soon as you receive that, log the QSO. As soon as you send that, log the QSO. And then look for a queue. If you send that, but your QSO partner resends his exchange, that's a clue that he didn't receive your QSL. So resend your QSL. I think I already talked about this. Even though FT4 is faster, I found in practice, it's most of the time actually slower because I have far more repeats due to it doesn't decode as deeply into the noise. So I find that FT8, even in contests, even though it's half the speed, is better for overall QSO rate. Here are another list of resources that you can consult for questions that you may have. So George, back to you.
Thank you very much, Ed. Another great resource is the files area of Contest University. If you scroll to the bottom, there is a contesting terminology document there, and it will be updated for 2020, but it's pretty current at 2019. It's done by Pat N9RV, and it will tell you about what nil means, and SO2V and SO2R, all of those things, the acronyms that are used in contesting are very well explained there by Pat. So go to the files area of Contest University. Thanks very much, Ed. And Trey, George, do we have some questions?
Shall I go first, George?
Sure.
Ed, could you please revisit your comments about dual peak RTTY filters? Is there ever a situation where the use of a dual peak filter is advantageous? How about the dual peak filter option in MMTTY?
Thanks, Trey. Yeah, so I will follow my sword and admit that I was a perpetrator of popularizing the dual peak filters or dual tone filters in radios, and as Trey said, in MMTTY about 10 years ago. And then the software developers pulled me aside and whispered in my ear that no, actually that makes the decoding worse. So even though it makes intuitive sense to us, especially as CW operators, to have narrower filters around each of those tones, they are not actually not helpful. The one in MMTTY may be helpful because it's embedded in the software, but the ones that are in the ICOM radios and in the K3 actually detract, because before the decoder ever gets the signal, it's been rolled off. The edges have been rolled off, so they don't have the harmonics and the skirts of the tones that are actually used in the decoding.
George, do you have a question for Ed?
Sure. There's going to be some questions about FSK and AFSK, and is there an advantage to one over the other? Why would you use one over the other?
Well, I didn't speak to this, but on my slide I said it's personal choice. I've been in uncountable arguments and debates and flame throwing about these two modes, and it's just like a lot of other things we can get into, like packet or not packet. Fundamentally, each of them, as I showed, if you have the proper transmitted signal on the air, it's hard to tell the difference between them. In other words, the RF signal that's ultimately transmitted is the same. So the only difference is what it is in your station. It's kind of like your choice of tones, you know, pitch for CW or tones you use for radio, what you want to listen to. I like FSK because it's like CW keying. It's set. I don't have to worry about one more adjustment in the heat of the battle during a contest. And I feel more confident that I can have a clean signal on the air. And I do use K3 radios with my FSK signals. On the other hand, AFSK doesn't require a keying interface. You can just use a common audio cable. And it's the same setup that you would use for FT8 or any of the other digital modes, which are audio in both directions, transmit and receive. So some people think that it's quote unquote simpler to use AFSK. Other people think that it's simpler to use FSK. And because there are so many wide FSK signals on the air, the AFSK advocates will use that as a strong reason for using AFSK, that you can get a cleaner signal. And that's true if you keep it properly adjusted.
Trey.
Ed, do you think that the FT8 and the FT modes are threatening the popularity of RTTY?
You know, I don't I haven't seen that yet. We haven't seen that in the data. If you look at some of the data that we've published in the last year on the RIDI roundup, that's a really good test of this, because as an operator, you have a choice to use either or both modes at different times during the contest. And what we saw when FT8 was first introduced 2 years ago into the RIDI roundup was that we had the same number of RIDI logs submitted as the previous several years, but we had an additional 900 FT logs. So it increased participation, but didn't detract from RIDI. Now, over the long term, you know, I don't know. People, I think, really enjoy going between the two modes, and they really appreciate having RIDI contests and FT contests. So I think for the foreseeable future, we're not going to see RIDI decline substantially. We certainly didn't see that in the last big RIDI contest, which was the WIPIX RIDI contest. We had over 3,000 logs, which is exactly what we've had the last 5 or 6 years. So I think for the time being, we just have the best of both worlds of having yet another mode and more activity.
George.
So several questions around FT8 and different frequencies in it. So if we're split, are we using double the bandwidth? Should we be split? And should you call the CQ station above or below its frequency? Things like that. Any thoughts on that?
Yeah, so the first thing I would say is always operate split. And by operating split, what I mean is find a clear frequency, lock your transmit frequency as I showed on one of those slides, and stay there, you know, until you think it's not clear anymore, and then move to another clear frequency. Basically, leave your transmit frequency in one place. To the second part of the question, you need to realize that you're looking at a window that's whatever your receive bandwidth is, you know, 2.5 to 4 kilohertz wide. Other stations have their receive bandwidth, and they may not be 0 beat with you. You may be able to copy him, but he may have his suppressed carrier up. So for example, I may be tuned to 14080 on FT4 with a 4 kilohertz audio bandwidth, and you might be you might have your radio up at 14082. You may be transmitting at 1 kilohertz audio frequency. That's 3 kilohertz in my bandwidth. And so I see you and I call you and I think, oh, this is great. But guess what? My audio frequency, my transmit frequency is down at 1 kilohertz in my bandwidth, which is 14081. That's 1 kilohertz below your receiver. It's below your low pass filter. So you're not going to hear me. And I can call forever and you'll never get me. So the recommendation is, the convention I'd like to see us all use is to pick an even frequency, like 14080, 14082, and so forth, and workstations basically in that 2 kilohertz. If you see somebody above 2 kilohertz and you want to work them, you'll increase the probability that you're in their pass band if you move your transmit frequency up to that 2 kilohertz pass band, either by moving your radio dial 2 kilohertz or moving your audio frequency up above 2 kilohertz.
Trey.
Ed, are tube amplifiers noticeably cleaner than solid state amplifiers on RIDI, similar to the way they are on SSB transmission with IMB products?
Yes, it's similar. It's the same thing. But on the air, I would say from a practical standpoint, that's in the noise. That issue is in the noise compared to FSK signals from non-K3 radios and AFSK signals that aren't properly filtered, which is primarily MMTTY that is either using the default filter or no filter at all. So that's the bigger problem in RIDI are the wide signals.
So George, this will be the last question.
Are there any multi-platform RIDI decoders if I'm not on Windows? Do you have suggestions? Where can I go?
Oh boy, there is a Coca modem that's fairly long well, it's a very good decoder, but it's not one that has been updated frequently. That's available on the Mac. and I know a few people that are using it, but it's not very much. So most people that I know, if they're running the Mac or other non-Windows operating systems, is for RIDI they use either an emulator or they get a PC machine to do that.
Do you have experience with FL Digi? That was mentioned.
I personally have not used FL Digi. I've used mainly the two decoders that I mentioned, MMTTY and two-tone, as well as the DXP38 hardware decoder.
Well, thanks very much, Ed. Great presentation, and the comments in the chat were just off the charts. So a great topic, and your depth of knowledge was fabulous on this. If you have a question that we didn't get to here today, feel free to go to Ed's QRZ.com page. His email address is there, and you can email Ed W0YK. And so now we go on to our next presentation, and this is optimizing your station for contest operations. Our speaker is Doug Grant, K1DG. He's been licensed since 1967, and he has #1 finishes in single op and single op assisted, multi-single, multi-two, and multi-multi categories. He has been a competitor in 6 WRTC events. He won a gold medal and 2 bronze medals. He is the past president of the Yankee Clipper Contest Club, past member and chairman of the ARRL Contest Advisory Committee, member of the CQ Worldwide Contest Committee. He's chaired the Dayton Hamvention Contest Forum for over 20 years. He is a director of Contest University, also a director of the Worldwide Radio Operators Foundation, and he was chairman of the WRTC 2014 Organizing Committee. And he is most recently the author of Amateur Radio Contesting for Beginners, which is published by the American Radio Relay League. Please welcome Doug Grant.
Okay. Hopefully you can hear me. I got a note that popped up on my screen saying my microphone was disabled. Tim, can you hear me out there in internet land?
Yes, I hear you well.
Excellent. Okay. So a lot of the presentations today have been very specific about receive antennas and different manufacturers of USB interfaces and stuff like that. I'm going to switch gears a little bit and take kind of a higher level view about optimizing your station for contest operations. Well, what do we mean by optimize? There are 2 definitions in the dictionary. One is to make as effective, perfect, or useful as possible, and the other is to make the best of. So we're going to talk about optimizing your station within some set of constraints, probably financial, but there are others. I'm going to assume that you're sitting there watching this webinar because you have a station and you want to start using it for contesting. You need to, first of all, determine what your goals are in contesting.
Doug.
Yeah.
Can you share your screen?
I thought I had. I did that. Oh, wait a minute. There's another button that says share. Screen sharing has failed to start. Please try again later. That's not a good thing, is it?
Corey.
I think he's just gonna have to try again. There's nothing disabled on this end. Try it again, Doug.
All right, let me try that one. That didn't work. Let's try that. Do you see my screen now?
No.
No. Well, I'm not quite sure where we go from here.
So the backup plan, Corey, would be to go to the website, grab Doug's slides, and share that screen, Corey.
I'm on it. Be there in 2 seconds.
Okay.
There you go, Doug. You broke it now.
Well,
hey Tim, I'm ready to go. If you want me to share it.
All right.
Oh yeah, Corey, Bill's got him ready to go.
Okay. So
It just says, say next slide or something, and I'll go for it.
Okay. So you should be on a slide that says you have a station, you want to use it for contesting. It's about the fourth one in.
Yep.
Okay. So we're going to talk about things you need to do with your station indoors and things you can do to your station outdoors to optimize it for contesting. Next slide, please. So first of all, determine your goals. What kind of contest do you prefer? Domestic, DX contest, WorldWorks World contest where you can work anything, or VHF contesting. What modes do you prefer? CW, sideband, RTTY, sort of all digi modes. These will sort of drive where you spend your money and where you make your investments in optimizing your station. Next slide. So what do you want to do? Do you want to do better than last year? Do you want to beat that guy across town that beat you last year? And I can tell you from experience in certain towns, that gets to be very hard. Do you want to win your section, state, call area, division, country, world? And you need to be realistic. Don't be unrealistic. For instance, occasionally I get an email from a guy that says, contesting looks like fun. What will it take for me to win the CQ Worldwide DX contest for the USA this year? By the way, I live in an HOA restricted community in Wisconsin, and I only have a trap dipole in the attic. That's sort of an unrealistic expectation. There will be a lot bigger stations in a lot better locations with a lot bigger antennas and more experienced operators who will probably prevent you from winning the CQ Worldwide DX contest. So you need to set realistic goals and then do a fair assessment of where you are. How much operating experience do you have? Are you a beginner? Is this your first contest? Have you done a few and you want to get better? Are you a real pro? And what is your station's real capability today? What do you have for antennas? What do you have for equipment? And are there some real limitations on possible improvements? Do you live in an apartment? Do you live in an HOA situation? Are you just geographically challenged one way or another? Next slide. So establish your budget and your timeline. The abbreviation TANSTAFEL is an old economics term which means there ain't no such thing as a free lunch. So improving your station capability is going to cost you some money, probably. The good news is that those improvements can be incremental over a period of months, seasons, years, however long you want to play the game. Improving your operating skill is something that costs nothing. It just costs time. And that's an important part. We'll talk about that in a little while. Next. So here's a quote I saw, I think, on Facebook, posted by W3LPL a few months ago. I just got a call from a guy who wants me to build a remote contest station. He wants to win the CQ Worldwide. His budget is $500,000. I sent him a contract. Not everybody has that kind of money to spend on a contest station. So for most people, that's unrealistic. Maine's getting too crowded anyway. So don't even think about building a station in Maine, remote or on site. Next. Things that you can improve indoors. Let's talk about equipment for a minute. Your transceiver, something relatively modern, 2010 vintage or later is fine. You need a radio with about 75 to 80 dB dynamic range for phone, 85 to 90 dB for CW. Rob Sherwood will probably expound on that a little bit more, but the fact is that there's so much stuff from other stations creating interference that if you have a lot more dynamic range on sideband, you don't get to use it anyway. So you don't need the latest and greatest radio. Right now, Ray Novak is squirming, saying, why am I sponsoring this thing anyway? But the fact is, an older radio can work. A radio designed for mobile use is probably inadequate. There are too many trade-offs to make it small. Choose one with a user interface you like. I happen to like radios with the pan adapter type screens on them, spectroscopes, and knobs in a certain place. So I seem to have gravitated to one particular manufacturer. But don't get hung up on buying the latest and greatest thing. And I know for a fact that the top USA score in the CQ Worldwide has been made several times using radios more than 20 years old and even older amplifiers. Next slide. Rob will also talk probably about optimizing radio performance. You can look in his last couple of years presentations, and he'll tell you things like, don't use the preamp except maybe on 10 meters because it doesn't really help. It just squashes your dynamic range and makes your high dynamic range radio not as good as it could be. Learn how to adjust your filters. On transmitting, use the speech processor so people can hear you, but don't turn it up to 11. No one will answer you if you have a distorted signal on phones. So make sure you listen to your monitors so you sound good. Learn how to use your Vox. Some people prefer foot switches, especially in multi-ops where there are operators who yell a lot. But if you're a single op, the Vox is there. Learn how to use it. There's a control called anti-Vox, and your manual will teach you how to use that. If you have a radio that has adjustable CW rise time, be a good neighbor and slow it down from the default a little bit. Chances are, if it's set to too fast, you'll be interfering with other stations on the band. Next slide. Other things you can do indoors to optimize your station. If you want to enter the high power category, the tube amplifiers are becoming available on the market cheap as guys upgrade to solid state on auto tune amplifiers. But I'll let you in on a secret. The 1500 watts that comes out from a used Alpha 76 are just as loud as the 1500 watts that come out of a KPA 1500. As someone pointed out, they might even be a little bit cleaner. But an old tube amp is just fine as long as you can still get tubes for it if you do something horrible and blow up a tube. You should have a computer capable of running the contest software, whatever one you like. It doesn't have to be the latest, greatest hot rod machine. You can use a pretty old machine and still be perfectly adequate. Most serious contesters are using headsets. Get a good, comfortable one. There are some that are sort of feel like vice grips when they're clamped on your head and they're too heavy. Get a nice lightweight one. Get a watt meter so you can see what's going on. I like, my personal preference is for the dual needle watt meters. That way, if I'm on the wrong antenna or something has happened outside, I can see that one of the needles that shouldn't be moving is, and something's wrong. If you need a tuner, that's fine. Remote antenna switch control is a good thing, so you don't have a whole bunch of coax switches on your desk or on your table in front of you. Next slide. Software, automation, and all that jazz. If you want to make contacts, don't get carried away with the software. You can really chase yourself down a rat hole. Things are a little bit better now that TV Bob has shared how all this stuff really works. But you can spend a lot of time messing with the software and the USB ports and all that stuff. And it doesn't help you make contacts if you're messing with that instead of getting on the air. My preference is to automate only the basics. You need CW sending, control of the radio's frequency, and maybe antenna and band switching is a good thing. A lot of logging programs have way too many features and distractions, so don't try to use all of them all at once. And whatever you do, never ever upgrade to the latest version of a contest program the day of the contest. The contest author doesn't want the phone call because he's busy setting up, and it's just a terrible thing to do. But the real message on software automation and all that jazz is spend more time on the air and less time configuring and debugging ports, uploading databases and all that. If you do need to upgrade all that stuff and update it all, do it a couple of days before the contest, make sure it all works before the contest starts. Next slide, please. Again, I apologize. It was working earlier today and it worked when we had our dry run last week, but it's failed today. Anyway, if you have a lot of stuff on your desk, start taking an inventory of things you didn't touch in the last contest you operated and kind of move that stuff around. And stuff that you had to reach over to reach, like an antenna switch or a keyer paddle that's on the wrong side of the desk. Move stuff around so that the things you really need are easy to reach. Everything else shouldn't be taking up any space on the desk. Lots of monitors and displays might impress visitors, but they probably won't help you make any more contacts. Next slide. So here's a very cool looking station, but it's not really very good for contesting. There's way too many screens, way too many distractions. I like the maps on the walls. Ergonomics, next slide, is an important thing. If you want to increase your butt in chair time, you should probably improve your chair. You don't have to spend a lot of money for a chair. You can go to a used office furniture store or one of the big box office stores. They run sales periodically when they get a special deal on secretarial chairs and gamer chairs. Those are two activities that are a lot like contesting. They involve operating a screen or looking at a screen, typing on a keyboard or a mouse or whatever, and sitting in a chair for long periods of time. I have one of each in my shack now. I have two operating positions in my new station here. One is a secretarial chair I bought for about $100 a few years ago. And then this year I bought the gamer chair. It's a lot bigger, a little bit more comfy. You also want to make sure your posture is correct. You don't want to be leaning forward. You don't want to be leaning backward, and you want the armrest in the right place. I operated a contest one year where my chair was at the wrong height. And after the contest, my shoulders were sore for 2 weeks. Next slide, ergonomics part 2. Here's the desk height as a function of operator height. If you're going to host a multi-op, you want to have an adjustable chair because not all operators are the same height. Again, arrange the equipment so you can easily reach the important stuff and stuff you don't touch very often, move those things away. So here's something that's important. How well do you actually know your station? How long does it take you to change bands? Try it. You should be able to change bands and be ready to start calling CQ in 5 seconds or less. If you have things a little bit automated, you can do it essentially instantaneously, and that's good. But when you try to change bands, if you find out that something takes a lot of time, like you have to get out of the chair, walk over across the room to change antennas on the patch panel that you put in, that's probably something that takes too much time, and you can probably automate it and make it go faster. If you have an amplifier that requires tuning, is everything clearly marked and intuitive? I don't use an auto-tune amplifier because I don't change bands that often. I find that being able to change the band switch on the amplifier, change the tune and load controls to the marks that I've already put on it on the index cards that I've taped on the front panel, doesn't take me more than about a second. And that's okay. If you have something that's intermittent in your station, and be honest, you all do, fix it now, because it will break during the contest, which is the worst time for anything to go intermittent. Next slide. So I made a comment a few minutes ago about how incremental improvements over time add up. It's sort of like compound interest. So I'm using N6 TV as an example because I had some embarrassing pictures of him when he was young and when he still had hair. So 1970, give or take, he was operating with one radio, an HW16, which maybe a few of you remember. Then by 1975, he had progressed to a Drake line and had some windows in the shack. Actually, it looks like it's the same curtains on the windows, doesn't it? Here's his station, next slide, in 2012. That's not Bob. That's K6NAA using Bob's station in the rookie roundup. And you can see by now, by 2012, that compound interest thing has worked for Bob. He's acquired quite a bit of new gear, and a lot of things are marked so that he can set the tuner for his 80-meter antenna and dial it up pretty quickly by having everything color-coded, which is a nice suggestion also. Next slide. Here's Bob's 2020 station. It's nice and compact. The radios are next to each other. He can reach everything he needs pretty quickly. When he sent me this picture, I yelled at him for having the monitor way over to the side, but he said it's okay. I always rearrange the windows so that the windows that I need, I can see more carefully, and I don't sit between the two radios. I sit in front of the keyboard. So trust me, it's okay. I'm comfortable with it. And if it works for him, that's what's important. So I'm going to go quickly through some pictures of contest stations that I've acquired over the years, because I found that people really like to look at the pictures of other people's stations to either say my station's better than that, or gee, I should do that with my station. So I'm going to just go through these quickly and make maybe one or two comments about some of them. Here's one where the radios are too far apart for doing SO2R. The paddle and the key are way too far away from the left radio. So if the guy has moved over to turn the dial, turn the RIT knob on the left-hand radio, he can't reach the paddle if he's going to send with it. If a slow guy calls, he can't reach that Casey key or up on the top right to be able to change the speed and slow down. It's also way too neat. This radio has too many speakers. Never use a speaker if you're operating a contest, aside from the fact that the room acoustics will make it hard for you to hear anybody. Your family probably won't want that either. That's on the slide that says too many speakers, not enough rotators. So I only see one rotator, and that's not enough. You got to have more antennas that rotate than that. Next slide. This guy has enough rotators. He probably has too many. I can't even count how many there are. There's 1, 2, 3, 4, 5, 6, 7, 8. I don't know what some of those other boxes are. They're probably rotator boxes too. So there are probably too many rotators at this station. So whoever it is should send me a couple of rotators. I need a couple. Next slide. Here's one of the exceptions that proves the rule. This station didn't have any rotators. This is the old HC8N location in Galapagos. They decided that rotators were too unreliable, so they would point one set of antennas at Europe and set another set of antennas towards the US. And everything else would just call off the back of the antennas, so they didn't really need any rotators. On the other hand, the chairs sucked. They're not very comfortable, especially if you're going to sit in them for more than an hour or two. And that little dinky keyboard was way too little and dinky, so a bigger keyboard is a good thing to have. The station's pretty nice, except I think the radios and the monitor are way too high. I like the radios down at desk height and the monitor not too high above them. Aside from that, let's see, how many rotators? 1, 2, 3, maybe 4. Yeah, that's not too bad. And it's a good sturdy desk to hold the amplifiers up high. It's a good thing to keep the amplifiers, the top of the amplifier unobstructed so the hot air can get out. No comments about hot air, please. Next slide. This guy has 4 radios. I think the bottom 2 are for HF and the top 2 are higher because they're for VHF. Or maybe I'm just seeing double, I'm not sure. This one's just way too neat. No contest station should look like this. You got to have a few papers scattered on the desk and a few checklists and a notepad for things that you observed that went wrong that you want to fix before the next contest. This one's got way too many manual switches. It's too easy to put switches in the wrong position, I think, in this station. But it's nice having the 2 radios. Antenna switching is over there on the left-hand side. That's good for a right-handed operator. This guy has his VHF stuff on the left and the SO2R HF station on the right. Also a nice station, nice layout, plenty of room on the desk for papers and other stuff. This guy's got big monitors. Maybe he's compensating, I don't know. Okay, so that's about all the stuff I want to talk about indoors. Outdoor improvements. This is where you'll get the biggest improvement in your hardware investment in your station. You have to improve your antenna system, and that includes everything from the antenna itself to the feed lines, connectors, and everything else. The optimum type and the height may be different for different types of contests in your location. There are lots of other talks about this in past CTUs about optimum height for antennas and things like that. But it's really the best bang for buck in station improvements. Next slide. So I can't take credit for this algorithm. Many years ago, K1JX was trying to figure out how much a dB improvement in signal resulted in an improvement in contest score. So he collected a lot of data, did a lot of analysis, and he came up with a rule of thumb that says that if you improve your signal by 1 dB, your contest score goes up 6%. So you can make your score go up by moving from low power to high power. Of course, it puts you in a different category. But we had a very good example of this. A few years ago, N1UR, who operated the CQ Worldwide for many years in the low power category, switched to the high power category. Same operator, same antennas, same QTH, he just plugged in amplifiers. And his score increased, normalized to the top high power scores by about 70%. Next slide, and it occurred both on sideband and on CW. And I went through the math, and the normalized score increase was about 75% for a 13 dB increase in power. And lo and behold, that comes out to pretty close to 6% per dB. So the rule that K1JX came up with about 20 years ago still seems to hold water. Next slide. So improving your antenna by 1 dB will improve your score in the same category. So rather than adding an amplifier, just add some dB with antennas. The first few dB of antenna improvement aren't very expensive. Let's take 15 meters as an example. A ground plane on lousy ground has a gain of about 0 dBi, but a 40-meter dipole used on 15 meters has a gain of about 2.8 dBi. It's got a few nulls in the pattern. It's got a few places where it's got big lobes. And it might cost you 50 bucks. That's about $18 per dB. If you put up a 2-element wire beam on 15 meters, that's not too hard to do. You get about 5 dBi gain. Might cost you 100 bucks. That's $20 per dB. Still not too much of a big investment. Next slide. When you get past the first 10 dB, every dB costs a lot. When you're going from dipoles and wire beams up to a 4-element beam, that's got a slope of about $200 per dB. But the curve flattens out when you get up above 10 dB gain. You can see that when you're going from a 6-element beam up to an 8-element beam, that cost is about $800 per dB, and that's just the cost of the antenna. Doesn't increase the, or doesn't include the cost of a bigger rotator and all the other stuff you have to do. Next slide. On the high bands, tower-mounted beams are very nice. There are lots of hidden costs. You need to get a rotator cable, mast, concrete, guy wires, and all that. There are lots of options for tower, guide, freestanding. It's well beyond the scope of this presentation to get into tower system design, but it does impact the budget. Buying a beam has a lot of hidden cost. And if you decide you're going to put it up safety first, there are some new videos that have just come out from DX Engineering on towers climbing safety. Contesting should not be a life-threatening sport. You should hire competent help, learn from them, and eventually learn how to do some of it yourself. Next slide. Antenna improvements on the low band can be hard because the antennas are just big, or they can be. If your starting point is an inverted V at 60 feet, which is typical starter antenna, it's got 1.6 dBi in free space gain, 6 dB over real ground, but it's all at a very high angle. If you move to a 2-element shorty beam and put it up at about 60 feet on a tower of some kind, that'll cost you about $1,000 plus the rotator, plus whatever support you put it on. It gives about 5 or 6 dBi gain in free space, 9 or 10 dB over real ground, and will change your life. Having a 40-meter beam is just an amazing thing. 4 dB for $1,000, $250 per dB for a 25% increase in score. That's okay. That's a big investment, and if you've never operated with a 40-meter beam, you'd be surprised how much different the band is. A vertical or sloper array is much cheaper, well within reach of most people, and you can pick up some gain and some directivity, and it doesn't cost very much. On 80 and 160 meters, if your starting point is an inverted V at 60 feet, consider a half sloper or a vertical array. Verticals need a lot of radials on the ground or elevated to make them work right. If you have an array of them, you need a phasing box, which you can build or you can buy. Adding a beverage or other type receiving antenna from Frank's excellent suggestions earlier this morning, that's a good thing. If a beverage antenna you can string out for less than 50 bucks, as Frank said, it's hard to make them not work, so they can be very effective. If you're in a location where your transmitted signal is pretty good, but you can't hear the guys that are calling you. Verticals generally work a lot better for working DX on 80 and 160 than low horizontal antennas. Another thing that people overlook, next slide, is improving your feed line. Let's assume that your starting point is a tri-bander up on a 60-foot tower and it's 140 feet from the shack and you've fed it with RG8X. Well, when 10 meters comes back, you've got a problem because 200 feet of RG8X has 4 dB of loss on 10 meters. That's like throwing away a lot of your power, both on receive and transmit. If you upgrade that to 200 feet of LMR 400 or equivalent, that's only got a loss of 1.6 dB. That's an $83 per dB improvement by picking up 2.4 dB for 200 bucks. That's equivalent to raising your power by almost double, and it helps on receive. If you can get your hands on some surplus 3/4 inch cable TV hardline, at 10 meters, it's only got a loss of 0.4 of a dB. And that'll give you, let's say, a 20% score increase for maybe for free, if you can get the cable for free. The W3LPL rule is one that I've used for a long time. Your feed line should have no more than 1 dB of loss on the band of interest. That's not too hard on 80 and 160. It's a little harder when you get up to 10 meters. And if you're mostly an HF operator, which I've always been, when you start doing things like 2-meter EME, you find out that feed lines really, really, really matter. Next slide. You should also test your antenna system periodically, well before the contest. In my experience, I've noticed that most contest station failures, including mine, arise from poorly installed or poor quality connectors. Learn to install them correctly, solder or crimp them with the right tool. A lot of stations are compromised by using mystery coax that they got at a flea market. Get an antenna analyzer, measure the loss before you use this mystery coax. Otherwise, you haven't really done yourself any favors. Next slide. A few words about location. It takes a Herculean effort and a lot of money to overcome location problems, whether it's geography or terrain. The right location can make all the difference, and I'll just say hilltop and coastal are good, valley and desert are bad. Well, maybe they're okay for sweepstakes if you live in West Texas or New Mexico or Arizona and you live in the desert there. If you live on a hilltop in the desert, that'd be great. And some people have discovered that that works pretty well. But it can take a lot of money to change your location issues. Next slide. If you come to the conclusion that your station is compromised for contesting and you kind of maxed it out because of your location, you've sort of got three options. You can move. That may be impractical if there are jobs involved or spouses or family or whatever. You can go guest op someplace good, or you can operate remote. Those are all viable options now. So I want to, on the next slide, please, I want to actually get to what's really the most important part of your contest station now. And I didn't want to set this up as a poll because I probably would have broken that on Zoom also. But let's talk about the most important part of your contest station. How many people out there think it's equipment? Next slide. Got to have one of these, right? Otherwise you can't operate a contest. Okay. Maybe you think it's antennas. I mean, I've been saying antennas are important. So how about an antenna system that looks like this one? Hopefully the slides are keeping pace. I mentioned location being important. How about a coastal Maine location here? Those hills you see off on the distance on the left, that's Europe. I think those are the Alps, actually. Well, actually, none of those is the most important part of your station. The most important part of your station is the operator. This is a character from from Saturday Night Live TV show here in the US that maybe some of you have watched. And they had a character on there called Stuart Smalley who would get on and give daily affirmations. And he would say, "I'm good enough, I'm smart enough, and doggone it, people just like me." Well, for contesters, you got to say, "I'm good enough, I'm loud enough, and people just want to work me." The operator is the most important part of the station. So next slide, how to improve the operator or your operating skill. The real secret is practice, and then practice some more. And I mean real, no kidding, butt in chair practice, not just clicking on cluster spots. Get on a lot of little contests. There are over 400 contests a year, more than one every weekend. Operate a lot of little contests, even if you only get on for a few hours, work a few guys. Operate between contests, even FTA, because the more time you spend in your chair, the more intuitive your understanding of your station is. You know where the controls are, you can reach them without looking. And you'll also learn about propagation. You'll learn things like 160 in the daytime is not a good place to try and work DX. 10 meters might actually be open sometimes when you think it's not. I know some contesters who when they're on a de-expedition in the Caribbean for a contest, leave one receiver set to the FT8 frequency on 10 meters on another desk. And every once in a while, they look over to see if there is a big spike showing up on the FT8 frequency, because that tells them the band is open. It's a good band opening indicator. And also, doing some FT8 between contests taught me an important lesson, which is that the band is open even when it's not open. And what I mean by that is, if you operate just CW or SSB, you'll come to the conclusion that certain bands close at certain times of day. For instance, when the sun comes up, 80 meters disappears, you can't work anybody. 40 meters goes out shortly after that. But it turns out the bands are still open. They don't really switch off. They just open a little bit less. And what that means is on FT8, you can still work guys, because even though you can't hear them audibly, there is still propagation happening. What that means if you had a bigger antenna, you might be able to work some of those guys on CW or sideband. The other thing you can do is work on your CW copying, your timing, calling people on phone, call sign recognition, knowledge of propagation. Those are all skills that lend themselves to learning and spending time. Next slide. Here's a game I like to play sometimes during the week. You can do it any day, any time of day when there's a band open. It's called Beat the Spots. And what you do is just tune through a band for 5 or 10 minutes, depending on how much activity there is, and write down all the calls you can copy, especially interesting DX calls. And after you've made a pass through the band, check the DX cluster or the reverse beacon network to see how many of those guys you found yourself and how many you missed. And over time, you'll find that you're picking up more and more of them and missing fewer and fewer of them. The skill of turning the big knob and finding stations is a real important one. And you also find that you'll learn how to move quickly through a band. If you happen to have a radio with a spectrum scope on it, you'll be able to see where signals are, move to them quickly, listen long enough to get the call sign, and then move on. These are important contesting skills. Next slide. Here's another way that's sort of non-obvious to improve your skills. Read the contest write-ups, and especially the line scores. A lot of the publishers don't publish the line scores anymore, except online. But what I learned a long time ago when I was first getting into the game was I read these contest write-ups and I see the same calls over and over and over again, and they sort of somehow work their way into my subconscious memory, which made me into kind of a human super check partial. During a contest, a guy will call you and you might hear only a couple of letters of the call, maybe 3 letters, maybe just a suffix, and you didn't hear the prefix, but you've seen that same suffix over and over and over again. So you might have a pretty good guess who it is. And even if you don't have the super check partial window up, you may be able to work a guy faster instead of having to ask him to repeat the whole call sign every time. You might be able to say something like, Charlie Whiskey Fox. Is that Kilo Charlie 1 Charlie Whiskey Fox? I've seen those in that call sign in the results a lot. Maybe that's who it is. And sure enough, that's him, except his call's NN1C now. So next slide. When it comes to improving your operator skills, there really aren't any shortcuts. You can't spend money and buy time. You know, the guy who wanted to spend $500,000 to win the CQ Worldwide from a remote station in Maine can't buy operator skill. You have to just put in the time. Now, a few years ago, it became very popular to refer to the 10,000-hour rule. A guy named Malcolm Gladwell wrote a book called Outliers, which was about people who were really, really good at things. Next slide. And he quoted some work done by a guy named K. Anders Ericsson at Florida State, who studied experts in fields, people who were at the elite level, chess grandmasters, the Beatles, Larry Bird, Bill Gates, CT1BOH. I'm kidding, he didn't really study CT1BOH, he probably doesn't know who he is. But he said to become the best at something, you need to put in 10,000 hours. And that equates to about 200 full-time, 48-hour single operators. So there are probably, 6 or 8 opportunities to do that in a year. So that means you would have to spend, oh my gosh, years and years and years to get that good. Well, if you want to be CT1 BOH, you have to spend that many years practicing. You can't just do it on the first time up. On the other hand, if you want to have fun at the game and become good at it, there's a guy named Josh Kaufman, and he has published a lot of articles and books and gave a terrific TED talk on YouTube called The First 20 Hours. Look it up, watch it. It's enlightening. His argument is that you don't need 10,000 hours. You need 20 hours of deliberate practice to become competent enough to recognize your mistakes and be able to self-correct. And his example was teaching himself how to play the ukulele. He wanted to do that. And when he first started looking at it, the sort of 10,000 hour equivalent was how many chords you can play on a ukulele, and there are thousands of them. Turns out you only need to know 4 chords to play 90% of the songs that you've ever heard. So he found out that he really only needed to learn 4 chords, and he learned them pretty well, and then he learned how to read the chords in music and actually play the thing. Next slide. Now I'm embarrassing one of the guys in the audience now. N4OC, Ed Gimbastani, who's the other admiral. A lot of people watching this have heard of K0DQ. He's the admiral. Ed is the other admiral, even though he outranked Scott when they were both active Navy. Anyway, the two admirals decided to take a trip to Aruba to operate the ARLDX contest about 10 years ago. It was Ed, N4OC's first contest in 30 years, and the first time he'd ever operated outside the US, and the first time he ever used computer logging. So I went back and I read the write-up, and Scott basically said, you know, he operated the first few hours and then handed it over to Ed. So a few hours into the ARL phone contest, operating from the Caribbean with a huge pileup of W's calling, he handed over the microphone and keyboard to a guy who hadn't operated a contest in 30 years and never used computer logging. But after about 20 hours of operating, he was running at 150 plus per hour and kind of got the hang of it. So you don't have to put in 10,000 hours. 20 hours is enough to really start having fun. Of course, the more you practice, the better you get. The better you get, the more fun you have. And if you're doing this for any other motivation other than having fun, you need a different hobby. Next slide. If you're going to put in all this time to and spend money to get into contesting, you need to have a supportive family. I won't tell you who this quote is from. It's from a very well-known contester who says, "There's nothing like having your wedding anniversary fall on the ARLDX CW weekend. Just ask my first wife." I once heard that a wise man marries his second wife first. I won't tell you where that attribution is from. You should have an understanding and supportive family, and you should reserve contest weekends well in advance. Make sure that they're clearly marked on the calendar. You should verify dates for scheduled events like concerts. There was one year that my wife came to me and said, "Hey, how would you like to go to this concert?" And it was in December, and I looked at it and said, yeah, I'd like to hear that group. Let's go to that concert, buy those tickets. And then I realized it was the Saturday night of the ARL 160 meter contest, which is a contest I happen to like a lot. So I had to only operate half of that contest weekend, and that was on me. That was my mistake. But balancing family, work, and hobby is key to having a happy life, not just having success in contests. So a few final thoughts here. Wow, it came in way under the time. I had way too many slides here. I thought I was never going to finish it in time, but let's give it a shot. Your contest station is a system. There are lots of pieces to this system. There's equipment, everything from your keyboard and mouse to your amplifier and the transceiver in the middle, and the USB interfaces, Bob. The antennas, the whole antenna system, that's a subsystem of your whole contest station system. Your location is a really, really important part of it. If you live in a valley, if you live surrounded by lots of other homes in a suburban neighborhood, all of whom have plasma TVs and Wi-Fi routers using unshielded twisted pair and cables that are 30 feet long and radiating very efficiently on 20 meters. If your location is compromised, then you need to do something about that, but that's obviously a part of your system. And the operator is a huge part of the system. if any one of these things is deficient, you need to work on improving it. And optimizing your station really requires equal attention to all pieces of the system. If any one of them is really bad, it's going to compromise the rest. And I see from time to time guys on their pages on QRZ.com, and they talk about how they've got a computer that's got 32 cores and runs at 9 billion gigahertz, and they've got a whole array of I don't know, 56-inch monitors, and they've got flex radios and 7851s, and outdoors in their suburban location, they've got a 43-foot vertical for an antenna. Nothing against 43-foot verticals, but if you're going to spend tens of thousands of dollars on all the stuff indoors, you should probably spend a few bucks on what's outdoors too. And you should probably spend less time bragging about it on QRZ.com and more time operating it. So next slide. This is a shameless plug. I had to put this in here. About 2 years ago, the ARL approached me and said, you know, Doug, we don't have a book about contesting. We've seen some of the stuff you've written. How would you like to write a book about contesting for beginners? And I decided that was probably a good thing to do. So I did it. And it just came out just after Christmas, around the beginning of this year. And for 20 bucks or 25 bucks, you can get it at the ARL website or on Amazon. And there's a lot of stuff in there. I've seen a few reviews, and the reviews were kind of interesting to me because I did write it for beginners, but I put it in a few other little tidbits here and there that guys who've been doing contesting for a little while may not know. Some of it where the history of certain things, how certain things evolved and stuff like that. And all the reviews picked up on that and said, hey, this isn't just a book for beginners. This is pretty good for intermediate contesters as well. So there's my shameless plug. Pick up the book. There really is a book to help you get started in contesting. And it covers everything from the history of contesting through digital contesting, VHF. There's a lot more expansion on that 6% per dB rule. And a lot of other stuff in there that, and a big expanded glossary of contest terms, so you'll know what all these weird acronyms mean, and they might make some sense. So there you go. I think I'm done. Yes, that's the last slide, and there you go.
All right, thank you, Doug. Great presentation. And I keep giving, I've bought 6 of those books now, Doug. I keep giving them away. Somebody will visit and say, hey, I want to get started in contesting. So I just hand them the book, and it is really, really good. And you did touch on a great resource. We just finished it up yesterday. If you go to YouTube and you Google DX Engineering and you go to the YouTube channel for DX Engineering, there's a 5-part video series on tower safety that a professional tower climber, professional tower safety expert, Tim Jellison, W3YQ, did, and it's getting good reviews, and you can watch those videos. And the hope is that we don't have any silent keys because of troubles on the tower. So Trey, let's start with you on questions for Doug. You're muted, Trey.
Can you hear me now? Doug.
Yes.
Do you have any experience with sit-stand desks?
With what?
Sit-stand desks, one where you can change the elevation of the
desk.
Oh, yeah. Well, my doctor uses one, and he seems to like it a lot. He's on his feet all day, and so he alternates around with the thing. I've never used one. I think it's probably a good idea because sitting in a chair for a long period of time is generally not a very healthy thing for you. I have been through every possible contortion of having good posture with my legs at right angles, the way that my knees at right angles where they're supposed to be, and feet flat on the floor or flat on a little platform underneath, to tucking one leg underneath me, to tucking the other leg underneath me, to standing up once every couple of hours when my legs start to cramp up a little. But if you like sit stand desks, go for it. If you can fit all the stuff you need on it, whatever works for you, whatever makes you comfortable, whatever keeps you operating the longest, that's what's going to improve your score.
George.
I'm not familiar with the term shorty beam. What does that mean? And what do you think about a 40-meter sloping dipole?
Shorty beam is a colloquial term. I'm not sure we put it in the glossary or not, but if you think about a 2-element full-size 40-meter beam, the elements are about 65 or 70 feet long, and that's pretty unwieldy, and you need a real serious rotator and tower to hold it. Many years ago, some of the manufacturers decided they wanted to make 40-meter beams and make them manageable size, so they made them shorter. Cushcraft had one, High Gain had one, I guess Mosley had one, and they generally are shortened so that the elements are only about 40 or 42 feet long, and they are made to be electrically longer by use of loading coils, capacity hats, linear loading rods, or whatever, so that the elements are only about 40 or so feet long. The boom is only about 18 feet long or 20 feet long, and you can turn them with a rotator that doesn't cost $1 million. Tail twister will turn them reasonably well if you're not in a very windy environment. If you are in a windy environment, you probably get about 8 or 10 years before you strip the gears and then have to send the tail twister back to get it fixed. As far as the other part of the question was sloping dipoles or sloping arrays on 40. A sloping dipole is a good antenna if you can't afford a beam. There's a thing in the ARL handbook of an array of sloping dipoles with 4 or 5 or 3 of them, however many you can get. And by using a little relay control box in the middle so that the unused ones all get tuned as reflectors, you actually get a little bit of gain. So that's a very good way of getting a gain antenna on 40 meters if you don't want to go to the expense of a beam and a rotator.
Quickly, Doug, could you tell us, I'd like to have you elaborate on your answer about the 40-meter sloping dipole. Would that be a good antenna also to use on 15?
I've never looked at using a sloping 40-meter dipole on 15. I'd have to think about that and fire up EasyNet before I would commit to an answer. If it's the only antenna you've got that you can use on 15 meters, it will work a lot better than the dummy load. So another good rule of thumb is that any antenna is better than no antenna.
I was just thinking in terms of maybe there might be a lot of radiation more off the end rather than off the side.
That would probably happen. That's why I didn't want to commit without looking at the lobes. You know, when you operate an antenna like that at 3 times its frequency, what happens is instead of a typical dipole pattern, you get a bunch of lobes, sort of a clover leaf pattern. And if one of those lobes happens to fall on a part of the world that you want to work, you may be very frustrated and find out that it's not a very good antenna for you. On the other hand, if you find out that one of the lobes is pointed right where you want to work, you may find that it's a very effective antenna, whether it's sloping or horizontal. There's a guy in the next town over from me here, K1AR, who uses an 80-meter dipole on most bands. And he discovered through trial and error that on 2015 and 10, it seems to have lobes towards Europe, but it's really got a giant lobe towards Brazil, and he's way louder than everybody. And when he's running Europe during a contest, he gets all these PYs calling him that don't call the guys with beams.
Okay, now for my actual question. You talked about building up 10,000 hours of experience operating 48-hour contests. Are there any off-the-air ways to build relevant experience? Any interesting software, for example, that could help you improve your operating chops?
Yeah, there are some pretty good simulators out there that that are kind of fun to play with. Now I'm going to be challenged to try and remember the names of them. Everyone's going to put it up in the comments anyway. VE3NEA has one called Morse Runner, I think is the one. That's a good one if it's the one I'm thinking of, where you can mess around with how many stations will call you at a time, how much noise is injected, so you learn how to copy noise, what the minimum starting speed is. So if you're just starting out, you set the speed low, turn the noise off. There's even a control, I think, on that program for lids, where guys will call you over and over and over again when you answer someone else. And if you answer a call sign, if you type the call sign wrong, the guy will call and correct you again. So it's very realistic. A long time ago, there was a thing called Dr. DX, which ran on a Commodore 64, which was probably the most realistic contest simulator I've ever heard. But I don't think the hardware is available. I thought someone was going to port that to Windows or whatever, but I don't know if that ever got done. But yeah, there's some great ones. Morse Runner. There's one if you want to become CW proficient. There's one called RUFZ, which just is short for the German word Rufzeichen, which is plural of call, it means call signs. And they actually use that in the high-speed telegraphy competitions where it sends call signs, and if you get it right, the next one is sent a little faster. And if you get that one right, the next one's sent a little faster. And if you screw it up, it backs the speed down. So you get a high speed and a percentage and so forth. So that's a real good one for increasing your CW speed, copying call signs.
George, what do you got?
Do you have any thoughts on a newbie setting up a station and focusing on a single band as opposed to before launching into multi-band, or would you do all band?
Well, that's a great question. Yeah, if there's a band that you think you want to get good at and practice on and get some experience, if you can't put up antennas for lots of different bands, then that's a good way to get started. There are a few caveats with that. I would not suggest starting on 10 meters at this part of the cycle. You may get very frustrated turning around during the week and not hear anybody. You may be frustrated turning around during the weekends and not hear anybody in most of the major contests. 15 is kind of marginal these days. So if you're going to pick a band to get started, 20 and 40 are probably good ones. 20 is a good daytime and during the summer, nighttime band. 40 is a good nighttime band. So those are two good things. And you can put up reasonably effective antennas without breaking the bank. So yeah, if you get started on one of those two bands and get used to the propagation there, that's a good way to get started.
Trey.
In your presentation, you talked about changing bands, and you mentioned something about color coding. Can you be more detailed about that?
Oh, sure. What some guys have done very effectively is if they've got lots of things that need to be adjusted, the tuning knobs on the amplifier, the band switch on the amplifier, I'm looking at my amplifier now, an antenna switch if there is one, you can just use sort of plain text and an index card and a Sharpie and write down that this knob set here is for 160 meters. Or you can color code everything so that when it's 2 o'clock in the morning and you're changing bands, all you need to do is dial everything to the red, and that's 160. When you go to change bands, make sure everything is set to yellow because that's 80, and go from there. So that's another alternative for marking up things if you're not fully automated.
All right, last question, George.
I live in a ground floor apartment. What are your suggestions on how I can get good at contesting? And I'm going to answer part of that. Related to that, how do I find the local multi-ops to operate with?
Get thee to a radio club. You'll probably find some guys in the radio club who have stations who would be willing to let you come on and operate if they talk about the fact that they're going to be on for a particular contest. Some of them may even have their station set up for remote, so you can sit in your basement apartment or ground floor apartment and work guys. It's a tough thing to do to try and set up a station if you live in a ground floor apartment. My brother-in-law in California lives in a 2-story townhouse and is just completely buried with 20/9 noise from everything around him. He tried an indoor loop, he tried an invisible wire outside, none of that stuff worked. So he operates remote. There's a station about 20 miles away from his house, and he does all his operating remote, and he loves it. But George, you had a comment about basement apartment operating or ground floor?
No, not really.
Oh.
All right. Well, Doug, thanks very much. Great presentation. And from the chat window there, they loved it. And so if you want to ask Doug, K1DG, further questions, you can go to his QRZ page, and his email address is there, and you can communicate with Doug. And Doug, continued success with book sales, and hope you stick around and do a few more books here and there. That's a great read and very, very helpful for the contest community. So time for a moderator change, speaking of multi-ops, and we say 73 to Trey and to George. Thank you very much. And we bring in 2 new moderators. And so this is Marty and N1C, and welcome to Bill, W9KKN, out in the West Coast, Northern California. And it's time for our next speaker. And Ward today is going to talk about grounding and bonding for contest stations, very important topic. It's Ward Silver, N0AX. And Ward has been an active contester since before his novice days in 1972. He has done several multi-ops from places like HC8N, KH6RS, K9CT, KL7RA, and W1AW. Ward is the founder of the World Radio Sport Team Championship, is a founder. He's one of the founders of the World Radio Sport Team Championships, which began in 1990. He was inducted into the CQ Contest Hall of Fame in 2015. In 2013, Ward was elected president of the YASME Foundation, which supports amateur radio activities around the world. Ward is the lead editor of the ARL Handbook, the Antenna Book, the ARL License Manuals, and is the author of the hugely popular Ham Radio for Dummies. Ward received the Bill Orr Technical Writing Award from the ARL twice, once in 2003 and once in 2017. Ward was awarded the Amateur of the Year Award at the Dayton Hamvention. He considers himself fortunate to have a few top finished plaques on the wall of the radio room, but the best part is participating in record-setting team efforts with friends from around the world. So please welcome Ward Silver. Ward?
Hi. Hello, everybody. Boy, that's a great bio. Who wrote that? I should pay you more. Okay. Let's see if the share screen works here. I've got this little funny hourglass thing here. Let's see. Share screen. Grounding and bonding. Share. Do you see it?
It's coming. There we go.
Okay, let's go with slideshow. And come on, slideshow. There we go. From the beginning. Okay. CTU presents Grounding and Bonding for Contest Stations. This talk started out as one column in QST some years ago, when it generated a huge amount of information and interest from the readers, and it became quickly apparent that this was a topic that a lot of people needed to know about. So here we go. Let's see. Goals of the session. We're going to talk about the difference between grounding and bonding, what they are, what they mean, so that you get a sense for what I'm talking about when I reference these things, and you'll be able to speak and communicate with other people and get things right. We're going to appreciate the different requirements for AC safety, lightning protection, RF management, and audio. The hams have a very wide set of requirements for this, much broader than most installations, so we have a lot of things to think about. I'm going to discuss issues and techniques for contest stations. This is not a cookbook talk. Basically, it's a toolbox talk. We talk about concepts, we talk about things that you can do and what the benefits are, and then it's your job to go home to your station and decide how to use the tools. There's also a list of comprehensive resources, and echoing what Doug said, this is a systems talk. We're going to talk about how your whole station is really a system, and if you approach grounding and bonding with a systems approach in mind, you can do the job once and have it work out for everything. So let's see how this goes. here's your background references. There's a lot of information about this in recent editions of the ARRL Handbook and Antenna Book. Since I'm the editor of both of them, I've been able to collect a lot of information and make sure that both of them say the same thing, which is always handy. But if you've got a recent edition, you have a bunch of information. In the handbook, it's in the safety chapter. In the antenna book, it's in building antenna systems. Another good reference for you is the NEC handbook. If you go look up the NEC, the National Electrical Code, it's actually a very small book. It's about this big, it's about that thick. And if you look at it, it's a bunch of fairly legalistic definitions. They're very exact, but they don't give you much of a information about how to do these things. The book you're looking for is the NEC handbook. You can see it's a rather large book, but you're only interested in a couple of the articles, meaning chapters in it. The handbook has all kinds of drawings and rationale and explanations for things, and it takes the NEC and it tells you how to actually do it. This is available at your library. Any recent edition will cover what you need to know. It'll typically cost about 30 or 40 bucks used, or you can go to the library and make copies of the 2 chapters you need. Another background reference is called Motorola R56. It's available online as a PDF. It's primarily for VHF and up communication sites, but you can look at what they're doing and decide what you can emulate with the resources available to you. Finally, lightning protection for the amateur station is a series of 3 QST articles. These are available to everyone, ARRL members or not, on the ARRL website. If you just look up lightning protection and Ron Block, you'll find these articles from 2002. Great reading. Power grounding, bonding, and audio for amateur radio, and the other document, RFI, ferrites, and common mode chokes for hams, were written by K9YC, Jim Brown. They're available for free on his website, along with a lot of other useful stuff. These 2 tutorials are very useful. They cover a lot of ground, give you a lot of information and background on what we're trying to accomplish here. Jim's contributed a lot to the hobby over the past few years, and he was one of the reviewers of my book. Ha, nice segue there. Here's the book. This is a little book. This is not a scary book. The idea is that there's so much information out there, but it was all in different places and different articles. How was a ham supposed to figure all this out? And so after a couple of columns generated more correspondence than anything else in 15 years, we decided to make a book out of it. It covers this entire set of requirements: AC safety for wiring practices, lightning protection, RF management. I had a very good set of reviewers, including the ARRL lab, Jim Brown, a couple of lightning experts, and Ron Block, and they kept me out of trouble. Everybody thinks I know so much about this, but it's really the deep experts that really helped me write a good book. There are a lot of examples for you to use. Like I said, it's not a cookbook because everybody's circumstances are somewhat different, but there are a lot of information that you can put to work. Okay, let's jump right in. What is ground anyway? It has different meanings. It can be a noun, a verb, or an adjective. Everybody uses the word, but they don't always mean the same thing. You can hear 2 people talking to each other about grounding and realize they're talking about wildly different things. It can be a thing, like an earth connection, or just your local reference potential. For example, airplanes have grounds, but I don't think any of them drag a chain to contact the earth. So they have their local reference potential up there in the airframe, and that's what we refer to as ground. It's also an action, meaning to connect to that reference potential. So I'm going to ground something. Or it's an adjective that tells you what type of a connection or conductor it is: ground conductors, ground systems. So you can say something like, I'm grounding the chassis to ground with a ground wire, and all of the uses of that word mean different things. So you have to be careful when you're talking about ground and what you're actually talking about. So there's a couple of myths in this. First of all, the earth is not a magic sink into which suddenly you connect something to the earth and the RF and the lightning and the AC safety currents and everything else, they just magically disappear, and the Earth is at some kind of magical 0 volts. It does not work like that. The Earth is a big pile of dirt and rock, and as such, it's not at the same potential at all frequencies and all currents and voltages. So you have to be intelligent about what you expect the Earth to do for you. There's also 3 common terms that I try not to use because they mean either an imprecise thing or so many different things. RF ground, everybody refers to that, but there is no such thing at all frequencies for RF ground. We'll get into why that is. You can have an RF ground as a local potential, local universal potential, but just at a few frequencies and just for a little bit of a distance. So you have to qualify RF ground. So I try to keep people from using that term. It means too many imprecise things. Ground loop is another one. The electricians will talk about ground loops because they want to control neutral and error currents. The audio guys talk about ground loops because they don't want magnetic fields picking up hum from power transformers and things. And RF guys talk about ground loops because of things getting picked up from signals. But you can't just get rid of ground loops very easy. If you go back and look at the back of your equipment, you'll find that there are hundreds of ground loops in there. Every place there are 2 cables between pieces of equipment, you have a loop. And so you can imagine how many a typical station such as those Doug showed in the previous talk, how many hundreds of loops there might be. So we're going to talk about how to minimize the impact of loops, but you're not going to get rid of them. Single point ground is a special term. It depends. And let's talk about that. The single point ground means, the word single means electrically small in terms of a wavelength. It means much less than 0.1 of a wavelength, 1/10 of a wavelength. Now at 60 hertz, the wavelength is 5 million meters. So electrically small means something about 500,000 meters. That's about from here to the East Coast. So something electrically small could be the size of a football stadium. But if you go up to 20 meters, what's the wavelength at 20 meters? 20 meters. So 1/10 of a wavelength at 20 meters is 2 meters. That's about 6 feet. And so your electrically small single point has to be something less than 6 feet. And it gets worse as you go up in frequency at VHF, UHF, microwave. We're talking about something in terms of millimeters. So single point means no transmission line effects, no voltage drop effects, all this kind of stuff. And to do that, it needs to be short electrically, small electrically. AC power and audio, let's drop back to that. AC power, single point grounds are intended to control neutral and ground currents by providing the correct path for them so they don't flow through equipment or signal cables. That's why you see grounds all tied to one point. That's so the neutral and error currents will all go back to the reference voltage for the AC power system. Audio is a problem because you have hum if you have a loop, and if you have a power transformer nearby and you put up a loop of audio cable, you'll hear a 60 hertz hum in there, or 50 hertz if you live outside the United States. If you hear a pure sine tone at 50 or 60 hertz, that's hum, and it's picked up by a magnetic field. The voltage that's induced in the loop is proportional to loop area. So if you can break the loop, you can break the pickup. And that's why audio and why audio guys are so concerned about ground loops. And that does matter to hams when you're talking about digital audio, which is going to go into a microphone connector, and you have a very small voltage. You want to make sure that you don't have a magnetic field inducing 60 hertz hum in your signal cables. Now at RF, the single point ground, because you make it small, it minimizes voltage differences from transmission line effects. if you have a quarter wavelength transmission line, some of you will remember from your license studies that even if it's a short circuit at the other end, quarter wavelength away, it's an open circuit because of transmission line effects. So by minimizing the electrical size of a grounding point, you minimize these effects so that all of the signals see essentially the same impedance and the same voltage. So that's what a single point ground is. It's an electrically small contact area in terms of wavelength to minimize voltage differences and minimize pickup from stray magnetic fields. Okay, let's talk about bonding. If you look up what the definition of bonding is, it's just a connection intended to keep 2 points at the same voltage. That's it. It doesn't have any meaning other than that. You're just trying to keep 2 points at the same voltage. And that's very important because when you keep them at the same voltage, everything goes up and down together. If there's any boaters out there, if you've ever experienced waves hitting a dock, all the boats go up and down together. That's why you have a floating dock, so that everything goes up and down together when you get a wave moving through. And it's the same thing with electricity. If you get a transient, you want everything to go up and down together. That prevents shock hazards from voltage differences between these 2 points. If this point goes up, and then this one goes up for a while, you've got a destructive voltage hazard between these 2 points. If you've got voltage between the 2 points, what happens? You've got current, and current causes the problem with voltage differences from RF pickup. Your RFI is caused by current and getting to where it should not be. And what drives the current is voltage differences. So if you can minimize the voltage differences by bonding your equipment together, you can limit the current that flows between the devices. So you bond things together to keep them at the same voltage. That prevents shock hazards from voltage differences caused by AC safety problems or from lightning or from RF from your signals. And it prevents current flow between the devices caused by the voltage differences. Bond them together, keep everything going up and down together. Okay, bonding sounds very expensive. Well, it's not. It's actually pretty easy. This is not an expensive or difficult thing to do, but you do have to think about it when you're putting your station together or when you're rewiring or adding some equipment. And it does require that you use the right connecting materials and the hardware. And the stuff's either in your shack right now, or it's down at the local big box hardware store. It's not rare or exotic, and you don't have to use special equipment to do it. When you bond your stuff together, that works in your favor for all these different requirements. You've got AC safety to worry about, you've got lightning protection to worry about, you've got RF management to worry about. Bonding things together works in the good direction for all three of those areas. Okay, for bonding to work, it has to be low impedance and it has to be short. Again, like a single point ground, it has to be electrically short at the frequencies of interest. If you're talking about 40 and 80 meters, something short can be maybe a few feet. If you're talking about 20 meters and up, then it has to be shorter still. If you're talking about 2 meters or microwaves, it has to be really, really short. But the important thing is for it to be low impedance. If you're talking about air currents or lightning protection, your bonding conductors have to be heavy enough to carry the expected current. For example, a short circuit in an AC typical household circuit might carry 100 or 200 amps for a second, maybe 1,000, just long enough to trip that breaker or blow the fuse. And if you're talking about lightning, even an indirect strike can cause hundreds to thousands of amps. So the conductor itself has to be heavy enough to carry this expected current for what it's going to do the job, or what it's expected to do the job for. And it also has to be mechanically sturdy enough to survive in the environment. If you read in your NEC handbook and your building codes, grounding conductors have to be very heavy and they have to be tied down. They have to be secured to the foundation if they are actually above ground. And why is that? Go to YouTube and look for videos of conductors being hit by lightning-sized current, and you'll see that the Coulomb force caused by the magnetic field of current flowing through the conductor will cause that conductor to thrash around. It can be hundreds of pounds per feet. So the idea of making a ground wire, it's not just going to sit there passively. If you're talking about lightning, it has to be very sturdy. And it also has to be, particularly if it's outside, heavy enough to withstand being dug up or run over with a car or something like that. Or maybe if you get the rototiller out and you forget where you put the ground wire and dig it up, it has to be heavy enough to stall the rototiller. Don't ask me how I know that. Okay, so you want your ground wires outside, particularly if they're buried, to be sturdy enough to withstand frost heaves and all that kind of stuff. So number 12 or bigger, and that's why the building codes will say number 6. For bonding, I guess you would have to use 007. Yes, right, gauge. Inside your station, it's not quite so severe. What you use is solid strap, 20 gauge or better, or heavy wire, number 14 or larger. This is a great thing to use. All that old Romex that you couldn't bear to throw out, because none of us throw anything out ever, and you know you're going to eventually use that 3-foot piece of Romex someday. Well, this is perfect. Strip off the jacket and use this heavy wire, heavy round wire, and solid strap are the perfect things to use for grounding and bonding. That's the standard in commercial and military service. Now, what about braid? Flat weave braid is okay if the equipment moves around. This is the, typically it's tinned, sometimes it's bare copper, big flat braid, you know, maybe 2 or 3, well, I wouldn't say 2 or 3 inches wide. It's about 1 inch wide, 1.5 inches wide. That will work if the equipment moves around or it vibrates, like in a mobile situation, or if you have a generator, or if you have to roll a rack around or something. But it's got to stay dry. If you use braid from old coax, the second you take it out of the jacket, it begins to deteriorate. The jacket is there to protect it from oxygen and water and corrosive chemicals. And the minute you take off the jacket, all those little wires, they start to loosen up. And so they don't make good contact anymore. They start to oxidize, water gets into them, and pretty soon you got something that looks like a grounding conductor. And if you use your DC voltmeter, maybe it looks okay. But at RF, it's a noisy, nasty thing. If you want to use old coax as a ground, leave it in the jacket, just strip off a pigtail at each end, waterproof it, put a terminal on it, and it's good. Only use braid if it's going to stay dry, and never get it wet. Don't let it get into a corrosive environment. A solid strap, like flashing strips or something, or heavy wire are the standard. Let's jump over to AC safety for a minute. Here's your typical power service for a residence. You have a utility transformer, better known as a pole pig. It'll have 3 wires coming out of it for the most part. One wire will possibly go down the pole to either a ground rod or what's called a butt wrap, where it is stuffed in the hole along with the pole. And then you'll have 2 service phases and 1 service neutral. So it's a center tap transformer, okay? Each side of the center tap goes to 120 volts. So you get 2 120 volt phases and 1 240 volts. That goes to your grounded service conductor. Let's see if this works. Here we go. Here's your neutral. If you take off the panel over your circuit breakers and look at the scary parts, you'll see 2 main disconnect transfer breakers, disconnect breakers here. These should be disconnected if you're going to use a transfer switch or a generator. And then you've got 2 buses. One's neutral and one is ground. The neutral is where all the white wires go. The ground is where all the bare or green wires go. And the ground is mounted directly on the metal enclosure of the surface box. In most service panels, there's an additional jumper that goes from the neutral to the ground bus. It's called the main bonding jumper. Okay, there are some circumstances where you do not want a main bonding jumper and you do not want neutral connected to the grounding electrode here, which is a ground rod outside the residence. There are specific rules about that, particularly for garages and outbuildings. And a lot of our stations are in garages and outbuildings. So be very careful about that. That has a major bearing on electrocution and shock hazards. That's what's inside your AC service panel. Okay, if you're going to do grounding for AC safety, and everything's going to be grounded for AC safety, it has several names depending on where you are in the country and how old your electrician is. It can be called equipment ground, third wire ground, or green wire ground. Usually equipment ground or protective equipment ground is the name that you'll hear today in building codes and standards. Okay, you want to keep your ground connections low resistance. They don't care so much about inductance. They do care about resistance for AC safety. The only thing that these grounding conductors are for, there's two reasons and two reasons only. One is to provide a path back to the AC common point for fault currents. That's the neutral bus. And that's where the short circuit current and leakage current go. If there's a fault out there and there's a power to, say, chassis short for something, you want enough current to flow to trip your protective component, whether that's a breaker or a fuse. And so the conductor has to handle all of that current. The other problem is leakage current when there's capacitance or degrading insulation between the power and the ground. And you want the leakage current to go to the AC common point, not to you. Okay, so the other purpose is to stabilize the AC power system voltage during faults or transients such as lightning. Now, each individual particular ground at a power pole or outside your house, it's not that superb, but there are so many of them in parallel that ties the power system to the earth, and that keeps the power system voltage relatively stable if lightning hits the lines, and if there was no ground connection, your power system voltage would go through the roof. But since you've got all these ground connections out there, it helps keep everything more or less at a safe level. So that's the only reason you've got AC safety grounding out there. If you don't know what you're doing, and all of us, I think, can maybe run a branch circuit, or for advanced studies, we can do a three-way switch, or various things. Get a how-to reference. There are so many different types of devices today. There's some with special circuit breakers. What's the difference between ground fault or arc fault? All these different things. Get a reference like this one. Here is your Black & Decker Complete Guide to Wiring. This is about 20 bucks. It's available online. It's available at all the big box stores. It's a great reference. First of all, we kind of know what we're doing for simple things, but once you get to an advanced setup and you're not real sure what all the colors mean, you're not sure what goes to what, get a reference. Specifically follow the rules for subpanels and outbuildings that I talked about before, where we are liable to have installed special services for our stations. After you're all done, hire a pro electrician to do the work or inspect your work. They can spot stuff that's a fire hazard or a shock hazard really fast and will help keep you out of trouble. Remember that your local code is the law. It's not there to make your life difficult. It's there to extend your life and keep your house from burning down. So, these things, they're kind of cumbersome at times. And why do they do it that way? It's because not doing it that way wasn't safe or effective. So anyway, get a reference, or you can hire somebody to do it for you. Okay, let's jump over to lightning protection. Lightning is important to hams for obvious reasons. We have these big things outside we call antennas, but They seem very attractive to lightning at times. Lightning's coming from thousands and thousands of feet up in the air, and basically it's a charge rebalancing between the atmosphere and the Earth. It is developed by friction and other processes, and basically you wind up with megavolt differences between the atmosphere and the Earth. So lightning is going to go where it wants to go, and you can't really steer it. You're just in the last few feet. You're in the last tiny little bit of its journey. So it's pretty well already decided where it's going to go. But you can help Mr. Lightning make good decisions on its way. And you can do that by helping Mr. Lightning do what it wants. So let's understand what it wants. Mr. Lightning wants a heavy, low impedance path to the Earth. It wants to dissipate that charge. It wants to get the charge back to the Earth and dissipate it into the Earth to equalize that voltage. Okay, so let's give it some. Okay, heavy, low impedance Earth paths. These paths should be outside your residence or your station. Don't make it easy for lightning to go through your station on the way to the Earth. Why do that? You want Mr. Lightning to go to the Earth outside your residence and not through your equipment. When you're talking about these paths for AC safety grounding, we talked about low resistance. For lightning protection, we talk about inductance being more important. Inductance times the rate of current change is what develops the voltage. And lightning changes fast, and it changes a lot. You can get thousands of amps per microsecond of current change in a typical lightning strike. And everything has inductance. Every straight piece of wire, a number 12 piece of wire, 1 foot long, has 30 nanohenries of inductance. Even straight wire has inductance. So it doesn't take very many 30 nanohenries of inductance when you're talking about kiloamps per microsecond to start to develop hundreds or thousands of volts, even in a short piece or across a short piece of wire. So the inductance is very important. That means wide straight paths. Number 12 wire, we talked about, well, it's 343 nanohenries. It's not 30. So it doesn't take very many pieces of number 12 wire to create a lot of inductance. So you want short, wide paths for your lightning protection. And you want to bond all of your Earth connections together. If you go to a typical house, you'll find a ground rod outside the electrical panel. That's required by building code. And there'll either be 1 or 2 connected by a heavy wire like a number 6 or number 8 or even number 4. And that's outside in the Earth. Okay, terrific. That's the AC safety ground electrode. All right. And then here comes the telephone person, and she installs your telephone service box, and her process says you got to put in a ground rod and connect the service box ground to that. So she does that. And then here comes the cable TV guy, and the cable TV guy comes and he puts in your service, and his process says install a ground rod. And so he does that, and he installs that and connects it to the cable TV service connector. And then you go up on your roof and you put up an antenna for FM or CB or whatever, and you follow the NEC rules. And the NEC rules say number 8 wire down to a dedicated ground rod for that antenna. So you put all these things together, 4 different ground rods. What are the ground rods connected to each other by? Well, they're connected by dirt, okay? And dirt is not a particularly good conductor. If you took your voltmeter or an AC resistance meter and you measured the resistance between these ground rods and they were a few feet or 10 feet apart even, you might measure 10, 25, 50, 100 ohms, something like that. And so let's think about that. If you've got a lightning strike and you've got lightning flowing through 10, 25, 50, or 100 ohms of dirt. How many voltages do you think that's going to generate? Like thousands and thousands of volts. And that's why you get these stories where I was just sitting in my living room and there was a thunderstorm and there was a lightning strike, and all of a sudden this big green arc jumped from my TV to my telephone, and now nothing in the house works. Okay, the problem is that the ground connections were not bonded together. They were only connected with dirt, which is high resistance. So what you do is you create a perimeter ground by bonding all of the ground rods together, and use your number 6, your number 8, whatever you got. I think the typical code specifies number 6, and that's what I use. You use the clamps that you can buy down at the hardware store. I got on the internet and I ordered a roll of number 6 copper, and so I've got it around and I use it for everything. And it's cheaper than going to the big box store and buying it by the foot, I'll tell you. So you ground all of your ground rods to the earth, and then you bond them together. And when you bond them all together, that creates a perimeter ground, and it's all of the dirt connections are now in parallel. So you've got a big, solid, heavy, direct, low impedance path to the earth. That's what Mr. Lightning wants. Okay, so we want the ground paths to go around your station. Here's an example. Outside, you've got an antenna system. You got a tri-bander on a tower. It comes, feed lines come to your house. You've made this nice little entry panel for them with its own ground rod outside the house. Then that goes inside to your radios down here. And your radios are plugged in through a power supply to your AC service through a branch circuit. And here's your AC service entrance. I don't know what it is, but it seems like it's federal law that the shack always has to be as far as possible from the AC service entry of the house. So anyway, you've got, here's your radios, your branch circuit, your AC service entrance, and it's got a ground rod over here. Okay, well, Mr. Lightning comes down. Maybe he doesn't hit your antenna directly or your tower, but it hits something nearby. At any rate, you have this big current surge going up and down your tower, and it flows on your feed lines, and it comes over here to the little panel, and it says, oh, yum, ground rod. Bunch of me is going to go this way, but it also says, oh, yum, there's a bunch of feed lines that go into this equipment, and then this nice big path to the service entry and another ground rod over here. So I'm going to divide just like current always divides according to the impedance of each path. And some of it's going to go to the ground rod, but a lot of it's going to go this way too. So that's what damages radios, consumer equipment, everything from frying pans to Cray computers get zorked by the lightning. So this is the problem. You gave lightning a path through your house, through the AC service entrance to another ground rod. Okay, well, this is better. Here's the same situation, but now we've got ground rods all over the place, 8 to 10 to 12 feet apart, all bonded together with heavy wire. Yes. And we've got our entrance panel. It's connected to a ground rod. The service entrance is connected to a ground rod. AC hits the power lines. Happens all the time. Okay, so here we go. It goes through the power lines. It goes through the transformer. You got a big transient coming into your house, and it goes to that ground rod, but it also says, this is a really good ground. I've got a lot of ground conductor here. I've got them all in parallel at low impedance. Most of the lightning energy is going to go here, not here. Okay, so by creating this big perimeter ground outside, you help Mr. Lightning make the good decision to go to the earth outside your shack, outside your residence. How about tower grounding? How do you do that? Okay, so we're looking down on typical Roan 25, 45, whatever. This drawing has been in the handbook and the antenna book for a long time. Each tower leg gets a ground rod, and then the ground rods are all connected with a ring of wire right here, and that bonds them together, and basically that takes care of a good electrode for your tower. If you really want to get into the grounding, extend the connection between the tower and the ground rod as a buried radial wire, heavy wire, number 2, number 4, whatever, 30 feet or more long, one on each of the legs. And that really gives you a big area so that charge can flow out into the earth. And the cellular telephone guys will tell you with their monopoles that the radial stuff, radial wires, buried radial wires are very good ways to dissipate that charge without it getting into the equipment. You also want to bond your feed lines to the tower. Remember that we talked about inductance. Your tower has inductance too. And when you hit a tower with a big pulse of lightning, you can have as much as 100,000 volts between the top and the bottom of maybe just a 50 or 60-foot tower. Hang on a minute. Got a cat that wants to turn around there. Okay, I don't know too many feed lines that have a jacket rating of 100,000 volts. Do you? So let me get rid of, hang on a second, cat infestation. There we go. That's Miss Electra. Okay, so you want to bond your feed lines to the tower so there's no destructive voltage between the jacket and the tower leg. So there's no arcing between the two. So about every 50, 60 feet, what you want to do is get a bracket or a grounding kit, and you want to connect the shield of your coax to the tower leg. And that keeps them at the same voltage. You can have a lot of voltage if you don't do that. Yes, it's kind of a pain in the neck and you have to put on more connectors and waterproof them and all that stuff, but it's not as much of a pain in the neck as having lightning compromise your feed lines. Another thing you can do is if you've got an insulated base tower, this is one of my towers, this part is buried in the ground, this part is not. And so what I did was create a spark gap. It's just like a spark plug. I used 2 heavy pieces of scrap number 2, my bronze ground connectors, ground clamps with a stainless steel shim in the middle. I just put them close together like that so that they're not so close that they touch, but not so far apart that I get a lot of voltage across them. And then when the voltage builds up from a lightning strike, it jumps across and clamps the voltage at a very low value until the current is down below a threshold. Spark gaps can also be made out of a piece of pipe and just bend it so it's close to the base of the tower. So you can do this a lot of ways. It doesn't have to be expensive. And so you create this single point ground panel where your feed lines come in. Basically, you've got a sheet of metal and you mount all of your protective devices on here. This is a protected line duplex outlet. We'll get into that in a minute. And that's connected to your perimeter ground system. And your inside the station RF ground plane is connected with a big conductor to the lightning protection ground also. Also, when you do this kind of a thing, make sure all your unprotected cables out here are kept away from your protected cables, or else Mr. Lightning will be happy to jump between them and ignore all of your fancy protective devices. It looks nicer to bundle them all together, but that defeats its purpose. Here's some examples of what we're looking at. Here's a protected line duplex outlet. You can get these online. Polyphaser has a really nice one. Here's a typical telco or data line protector. Here's the standard Polyphaser antenna lightning arresters that you can buy and screw on your cables, both sides of those. They've got gas discharge tubes in them. Also, if you do buy these lightning antenna well, they're either called lightning arresters or antenna protectors. There are kinds that are DC coupled through them, and you need to use those if you're sending power out to your preamps or something like that. Other types have a capacitor inside of them, and they cause the gas discharge tube to break down more quickly so that you have better protection, but that capacitor will block AC or DC power. Okay, here's a typical single point ground panel. This is out at the base of my tower. It's inside a surplus fiberglass electrical box. You can see an MFJ antenna switch here. And you can see the big ground wire down here. This is number 6. It goes outside. And then all of the rotator control lines are connected with these little glass things. They're gas discharge tubes. They're connected to the piece of flashing. And that's my single point ground, and it's connected to ground here. By the way, you can save yourself a lot of money for long rotator control cable runs by using 10 conductor number 18 irrigation wire. You wind up with pairing two wires to make one wire for your solenoid circuit. So you've got 2 wires here, 2 wires here, and then 6 more are left for motor and ground, and that works for most CDE ham type rotators or tail twisters. Anyway, save you some money. It's rated for direct burial. Here's another single point ground panel. I got in my barn a nice big panel. Here comes the hard line from the station. Here comes there goes the hard line to the towers. Here's my big ground connector. It goes right to the ground rod right in the barn. Here's some more irrigation cable that I use for the rotators. These have all since been added gas discharge tubes. You can see my antenna protectors that I got from DX Engineering. They're all mounted on a big piece of angle. Underneath these little brass guys here is where the gas discharge tube lives, and each of the hard lines is protected with multiple antenna protectors like this. Here's K4RO's single point ground panel. Kirk lives on a hill in the Nashville area, and every time a thunderstorm came through, he was losing some equipment and he got tired of it. So he bought a big piece of aluminum. He mounted it in his garage. His shack is right up here, right above the floor. And he mounted everything that had to do with antenna switching on that panel. Filters, switches, controllers, everything. And in the several years since he's done that, here's his ground rod. He hasn't lost one piece of equipment. He just bonded it all together on this panel. It's all grounded. It all goes up and down together. Here's in my station. I have most of my big antenna switching stuff, and the amplifiers are all in a rack. And they are all bonded to that rack with heavy ground wires. Here you can see one in the back. And in the back, I have panels for power switching. You can see the big heavy ground wire here. And I have 2 stations, one over here and one over here. And they're bonded to this single point ground with heavy duty ground wires. And then one more goes outside to the perimeter ground a few feet away.
4 minutes.
Okay, when you read the lightning protection article, you will see protected zones here. And this is, we're talking exactly about the same thing, this sort of a perimeter type of ground, and every line that crosses that perimeter has to be protected. Download the articles and read them. Inside your shack, you want to bond everything together so it all goes up and down. You've seen this drawing in the handbook many times. Everything needs to be connected to this bonding bus or a ground surface, and then that's connected to your single point ground panel. You also have to realize that everything in your station is an antenna, every bit of it. You're in the near field from all of your antennas at HF. Dipoles out in the backyard, you're probably less than a wavelength away from those antennas. So everything in your station is going to pick up RF. So forget about an RF ground. Concentrate instead on bonding. Bond everything together so it all goes up and down together. Your connections have to be electrically short. It keeps everything at the same voltage so that current does not flow between your pieces of equipment. Contest stations have a big problem because they typically have high RF field strength, and that requires extra attention to bonding. So create a common reference plane or bus under or behind your equipment and bond everything to it. By doing this, you eliminate hotspots. You don't have this, on 15 meters, I can't touch the microphone because it burns. It reduces RFI caused by common mode current flowing between pieces of equipment. No voltage between equipment, no current. It also reduces sensitivity to physical configuration. It means you don't have to move things around to operate on certain bands. And it also minimizes audio buzz and hum, which causes a lot of problems both on phone and on the digital mode. So you tie everything to this common planar bus with short coiled cables and a heavy direct connection to your single point ground panel. If you look down on the top of a typical station, you can see all these cables connecting all of your equipment together. Keep the cables together, run them along your ground connection, keep them short. Always use shielded cables and short straps or wires. This minimizes the loop area. So you minimize the loop area, you minimize the voltage. Here's a typical example. This is in my station. You can see the metal. I just put a sheet of flashing underneath the radios. Here's the computer up here. All of my cables are short as I could get them. And they're coiled up if they're too long, and they lay right on that ground plane. That helps minimize voltage differences that cause current. You can see the ground connection between my radio and the bus right here, just a piece of copper pipe, and that's bolted to the metal surface. And here goes my ground wire that goes to the rack, which is the single point for my station ground. This is a color picture. Oh boy. I can have my two radios. I've got filters. They sit on this shiny piece of aluminum flashing. I've got a grounding bus in the back that you can see, and you can see the ground wire over here. Okay, when you do this as a system, one system rules them all. All currents flow on all wires. Your AC safety, your lightning protection, your RF, they all flow on all the wires. So make sure the wires are short, low impedance, and direct. A single solid ground system made of short, heavy direct connections. It covers you everything from 60 hertz all the way up into RF. So you don't have to do this 3 times or 4 times. You do it once, you do it right, it will save you time and a lot of energy. Here's a schematic. All of this is covered on the PDF slides that you can download, but here's your schematic, shows the perimeter ground, the bonding of the connectors together, single point ground panel, and your ham radio equipment. Bond it all together and save yourself a lot of trouble. Here's your additional resources. These are the people that developed all these standards. The National Fire Protection Association, they do the National Electrical Code. International Association of Electrical Inspectors has a lot of good information on there. You can also find electrical inspectors in your area if you need to have one come over and take a look. Mike Holt Enterprises is a training site for electricians. It has tons of really good tutorials because I know we do more than just wire our shacks. Great place to find out how to do stuff. Polyphaser, even though they've been bought by another company, they have a lot of white papers and tutorials on lightning protection, including some specifically for ham stations, and the Lightning Protection Institute. I wonder what they're about. So papers and tutorials on lightning protection techniques for civilians like us. Here's the big standards. If you really want to get into it, here's the FAA document. Here's your IEEE standard, and here's the military 419. And these two talk a lot about, these two, I'll try that again. These two are the ones that focus on HF. Okay, here's your books and online material. Like I said, these are all in the PDF slides. The ARRL Technical Information Service is a wealth of information. Look at the electrical safety page, the grounding page, and the lightning protection page. Tons of good stuff in there. And WHAI lives on a mountain in Georgia with a 300-foot tower. Do you think he knows about lightning? He knows a lot about lightning. So go to Tom's page and look around, and he's got more stuff. And are we done yet? Yes, we're done. And I think we're done right on time, and I can get some questions.
Yes, yes, we'll take some questions. Bill, what do you have?
I'll take a drink.
Okay, well, so I have one question that's come up a couple different times. And the question is, should I bond a laptop with the rest of the equipment in my station? Especially, you know, laptops are kind of hard to ground because they're usually not metallic chassis.
Yeah, laptops are kind of a problem. They're designed not to be grounded. And I would say if you don't have a problem, don't. But if you're integrating your laptop into your station with a lot of USB connections, with a big external monitor connection, that sort of stuff, see if you can find a point on the connectors that's connected to the power supply ground in your laptop. And that's typically at the mounting screws for video connectors. But even that's even becoming less common now because we're using HDMI and USB. So if you can find a contact, then go ahead and tie it into your ground system. But if not, use it as it was intended to be used, and that's all you can do.
Marty, do you have a question for Ward?
Yes. So a lot of people in the chat have been asking different permutations of this question, which is essentially Bruce KN8U asks, what would you recommend for grounding on the 4th floor shack in a concrete building? Or how do I get as much grounding as possible? We've also seen permutations with my shack is in the basement, my shack is on the 2nd floor.
Yep.
Etc.
You make yourself a metal closet and you go get inside it whenever the thunder comes. No, basically tie everything together, okay? And I talk about this a little bit in the book. If you're reasonably close to ground, then bring all of your antennas to an external ground panel or box, ground them there, and then run cables up or down into your station, whether it's on a upper floor or a lower floor. If you're talking about 3 floors, 4 floors, whatever, the building steel is a good ground connection for you, but bring the antenna cables to the ground point outside somewhere. And if you can't get access to the building steel, if you're more than 10 or 20 feet from the ground, I think you're best off disconnecting when there's any kind of lightning around. When you're operating and there's no lightning and you're trying to minimize RFI and stuff, the key is to tie everything together. Use that ground plane, use the bonding bus, and tie it all together so everything goes up and down together and you're not exciting one part of your station differently than another part.
Bill, another question for Ward.
Yeah, sure. So we had somebody ask if they connect the station RF ground to the house wiring ground, is that going to induce RF into the house?
No. No, it will not. The RF will get into the house anyway. Okay, you got your antenna in the backyard. It doesn't know the difference between an AC circuit and a ground connection that goes out to a ground rod. It's all the same. Everything is an antenna, and the more you don't want it to be an antenna, the better it will work as an antenna. So tie them all together, treat them all as one system. All of your grounds should be bonded and tied together, and that's basically the only way to attack it.
Okay, Marty.
Joe K0NEB asks, are shorter 3-foot ground rods okay, or are 8-foot ground rods needed? I'll also wrap into this another question I see, which is, my station is in rock. I can barely drive a ground rod into the ground. What should I do? And I'll wrap a third question in, which is, people are asking about using grounding plates. I'm not familiar with those.
Right. Okay. You can get away with short ground rods if you're having trouble driving them into the earth. Most of the benefit of the ground rod, it comes in the top half of it. So if you have 8-foot ground rods, most of the good effect will come from the top 4 feet. But you need to drive in the 8-footers if at all possible. First of all, that's typical code, and it's code for a good reason. It gives you enough surface area to really do the job. If you can't drive them in because of rocks or whatever, there are, go get the NEC handbook. They will show you different ways of trenching. You can lay a ground rod in a trench and bond to that, or you can drive it in an angle. If you live in rock, talk to your local electricians and see what technique and equipment they use. They've solved this problem thousands of times. Let them do it for you. And then the final, what was the last question, Marty?
Oh, about using grounding plates.
Grounding plates. Yeah, that works okay. Again, talk to your local electricians. Sometimes homes are using UFER, UFER, UFER grounds, or slab grounds. Those are for AC safety. Concrete is really pretty conductive, and but they aren't that effective at RF. What the grounding plate does for you at RF is create a big capacitor to the ground, and you can get some current to go through it that way. I don't know if it's that effective for lightning protection, though, where you have a wide spectrum high current.
So Bill, let's make this the final question for Ward.
Bill, you're muted.
You are right, I am muted. So what about grounding rods beats from a tower that's 300 feet away from the house? I mean, do you have to tie that to your ground system?
Okay, the military standard says up to 200 feet, you must bond the tower ground to the station ground. More other standards say 50 feet. The problem is once you get beyond 50 or 75 feet, you get such a large amount of inductance that the wire is no longer very effective. It does not hurt anything, particularly at AC safety, to do the bonding, and if you have it buried in the ground, you've got yet another ground wire part of your electrode. But I would not expect a 300-foot wire to be electrically short enough to cause the tower and the station to be in close contact as far as RF goes.
Well, thank you very much, Ward. Great presentation. Lots of clapping going on around the world right now. Over 2,200 here and almost 400 on YouTube. So,
oh my gosh.
Thanks very much.
Copper prices go up. Yeah.
Did a great
okay.
job.
Thanks, folks.
I did want to point out to our viewers that the radio that ICOM America and Ray N9JA has donated, the IC 7610, that drawing will be held after the conclusion of the Hall of Fame. You have to be present on Zoom at that time, and you have to be able to raise your hand and make noise so we know you're there. And then Corey's going to do a verification check on it, and you have to live in the United States. So I want to make sure that everyone knows that. These sessions are all being recorded, and Terry will post up on the Contest University website here in the next week or two. So you can tell your friends about that. And Terry's already got the presentations up there. She will move the presentations to the files folder so that you'll have all the years worth of presentations in the same spot. Our next presentation is Contest and DX Performance, a complex subject today, great receiver performance with transmitter limitations. Our presenter professor is Rob Sherwood, NC0B. He began his ham radio career in 1961 in Cincinnati, Ohio. He graduated college in 1969 with a degree in physics, moved to Denver, worked as an engineer at KOA on 50,000 watt AM and FM transmitters. In 1974, he founded Sherwood Engineering and began modifying Drake R4Cs for hams all over the world. He now has on his website transceivers tested for performance, over 100 of them. He has given many forums at the Dayton Hamvention and also in Visalia, lots of places around the United States. 13 years ago, he started to build his dream contest station on 10 acres just east of Fort Collins, Colorado. And that has made it possible to further evaluate some of the transceivers that he has performance data on his website. He has 6 towers up there, and he's on all HF bands all the way up through 70 centimeters in the UHF area. Most recently, he's on the 630 meter band with a transverter from Australia, and he has worked 32 states, and also his best DX on 475 kilohertz is over 8,000 miles between Colorado and Australia. Please welcome Rob Sherwood, NC0B. Rob?
Well, I see you start the video. Is that the
Yeah,
CI?
go ahead and share the screen.
Okay. All right. Thank you, Tim. All right. So as Tim said, it's a complex subject today. Lots of things a little bit different from the past. I'll be talking about receiver performance as before in other years, but a little more emphasis on transmitters. We have amazing receivers today, but the progress on transmitters has been limited at best. So what I don't want you to do is just focus on a few transceivers. I started testing receivers in 1976, and I must say today our choices are amazing. But there's new challenges, and so let's look at them. So sensitivity has been around forever and is really a non-issue. I do get Colorado also seems to have grow light problems. Well, what are they growing? Well, you know, they're growing pot. And none of those grow light, so they use a kilowatt of light bulbs to grow their product, and none of them meet FCC specs. And unfortunately, there's no one paying attention to that. So lots of sources of noise. Well, the other main performance value, dynamic range, and that's what my website's sorted by, close-in dynamic range. And we'd all like to have the magic 100 dB radio. Now, if we back up like 20 years ago, there was no such thing. And now it's really not that uncommon. But it isn't required all the time. Doug Grant mentioned that, the W8JI, and I have pretty much on sideband, you can deal with a 70 dB radio, and on CW about an 80 dB radio. Well, you know, that's all we had for like 20 years. The up conversions radios came out, and close in, they were limited, wide space, not so much. So we don't have to have that magic radio. Well, what is dynamic range and how was it defined? And it goes clear back to 1975 in QST and Ham Radio Magazine. So the concept was to feed in two equal strength, well-isolated signals from a generator. And as we increase the level of those two test signals, eventually the third order product starts showing up above the noise floor of the receiver. So that was the definition, that we would tune in the third order product and it would peak up 3 dB on our audio voltmeter. And that meant that distortion product equaled the noise floor. So that was the definition. We'd measured the noise floor. We now have the distortion product equal the noise floor. And that is dynamic range, regardless of whether we're talking about the spacing. So as an example, if the preamp was off and the noise floor of the receiver was, let's say, minus 128 dBm, and the two test signals happen to be minus 28 dBm, well, the difference between those two numbers are the 100 dB, or maybe they're 90 dB, or maybe they're less. So that's how we define dynamic range. We don't have to wonder where those intermod products are. It's just math. Whatever the test spacing is, originally it was only 20 kilohertz, but that did not approximate a CW pileup at all. So whatever that spacing is, we're testing 20 kilohertz, 5 kilohertz, 2 kilohertz. We know exactly where the intermod product will be. It'll be that spacing above the high frequency test signal, and that same spacing below the low frequency test signals down to the hertz if we have our generators exactly on frequency. We do have to be careful we're not tuning in a spur or something, and I got bit by that one time. So you just have, that's an easy thing to figure out in the lab. So what is the state of the art on receiver dynamic range today? Well, we've got lots of choices. If we look at the 6 major OEMs, those are in alphabetical order. Every one of them offers at least one transceiver that has receiver dynamic range 95 dB or better. So we can, whatever our favorite brand is or whatever the case, how we choose a product, you can choose a high performance transceiver today. The other issue is phase noise. And back some years ago, once everything started being synthesized, synthesizers were pretty darn poor. And when I was testing the receivers back then, I would list either the third order dynamic range value in my table, or I'd list it and say phase noise limited. Well, eventually the league decided to come up with a term, reciprocal mixing dynamic range, so that we've got two dynamic range types. We've got the phase noise limited, or we've got the third order limited. So here's a graphic. It kind of explains why it's an issue. So the little bullet shaped graphic there on the left, that's our weak signal we're trying to copy. And just a few kilohertz away, let's say, is a really strong signal, and let's make it a perfect signal. Of course, that doesn't exist, but let's pretend like it did. Well, every radio either has a local oscillator or it's got a clock. If it's a modern direct sampling radio, it's got a clock. Well, every LO or every clock has some amount of noise. But what happens is any noise on that oscillator or clock gets mixed with that perfect signal that's really strong nearby the weak signal, and it puts a modulation sidebands, and that can cover up the weak signal we want to receive. Now, this little graphic I got off the web, it implies that the noise may fall off very rapidly. In some cases it does, but in other cases, a transceiver might have a very flat noise spectra, and it might have bad phase noise of 100 kilohertz away. So let's say we're on field day and we got a CW station and a sideband station. Well, that noise can actually cover a good hunk of the band. So it just depends on the individual transceiver, whether that phase noise causes a problem just close in or maybe far away. So the devil's really in the details when you look at reviews. So we need to be careful and read the fine print. So reciprocal mixing dynamic range was defined and explained by Bob Ellison, who does all the laboratory reports in QST. And he wrote up two sidebars that are very helpful if you want to get on the web and look at those issues, April 2012 or May 2016. It explains it in detail. And it was really common for really about 20 years that reciprocal mixing dynamic range dominated over the third order dynamic range. And probably the most glaring case of this was the FTDX 3000. I actually ended up testing it and publishing the data before it got reviewed in QST a few months later. And I listed it at 82 dB because I picked the worst case. Either it was the third order product or it was the reciprocal mixing product. But the advertisement said it was 106. I don't know where that number came from, but then if we read the QST review, it said the dynamic range was 100 dB. But the caveat was, in this case, because the phase noise was so poor, they made the measurement with a very narrow filter, maybe 3 hertz, maybe 1 hertz, and we probably don't use 1 hertz filter very often on the air. But if you read the fine print, the data was really there under the reciprocal mixing dynamic range of 82. Well, that was the same number that I published, 82 dB. So you look at the numbers, whether whichever one is the lowest, the lower number is the one that really dominates. Now, for quite a while, because products had improved so much, the synthesizers got better. The clocks were great. So if you had a direct sampling radio, it was kind of hard to screw that up. If you had a decent oscillator, well, then you were home free. But just this recent review of a relatively inexpensive radio in March of this year, I guess you pronounce it Zygu, but the G90 transceiver had the same issue as the Yaesu, but not as quite a great extent. So the dynamic range measured with the narrow filter was 91 dB, but the reciprocal mixing was 84. So look at the lower number, that's the one that matters. Also, whenever Bob publishes a sidebar, read it carefully because there's going to be more information in there on how the radio really works. So in this case, this one G90 transceiver had mediocre keying sidebands. Now, what's that mean? That's key clicks. It said the SSB IMD splitter performance was poor and the transmitted phase noise was poor. And transmitted phase noise is a big deal in some environments when there's transmitters nearby, like field day. And he said, don't use an amp with it. So that's kind of telling. So read the details, read the compare the two measurements and look at the Bob Allison sidebars. So today we really have two basic types of transceivers, the super het, whether it's a hybrid or not, and the hybrid really means a direct sampling band scope and waterfall, and we have the direct sampling, of course, and they both work really well. If you looked at what people used at WRTC, I think all the types are out there, all the brands. So in most cases, it doesn't really matter whether you pick the direct sampling or the hybrid, but there are cases where the super het with the roofing filters really make a difference in the blocking, or in the case of a direct sampling receiver, the ADC overload. So you just have to see what type of an RF environment are we in. Now, one advantage of the direct sampling radios, they all have a band scope, and I find it very useful for many things, certainly including contesting. So what is the possible concerns for a direct sampling radio? Well, field day, as I mentioned, we've got, assuming it's multiple transmitters, and particularly multiple transmitters on the same band, we've got CW, sideband, and now FT8. So you may have 3 transmitters on the same band. And that's going to be tough unless your antennas are extremely well isolated. W3LPL has information for a W3AO on how to set your antennas up for field day, for instance. They've got, you really want to maximize that isolation. I've had a couple phone calls and emails in the last just few weeks where a guy says, I want to buy a new rig and I've got another ham 2 blocks away. So now that is really a tough environment. It's approaching your field day environment. Well, now the direct sampling radios don't have a roofing filter. So they'll have an LC filter, of course. And in this case, here's an example, the ICOM 7300 or the 7610. It's got a 1/2 octave filter. That's a common bandwidth for a lot of transceivers. So it's going to cover 11 megahertz to about 15 megahertz. There's going to be commercial stations below 20 meters, commercial stations above. And of course, if you got that ham 2 blocks away, it's going to be quite a signal into your receiver. So in, let's say, in a limited number of cases, the super het with the roofing filter does have an advantage. Of course, the 7851 is an example of that, along with the 2 newer ones, the TS890S and the FTDX 101D. But I would say 99% of the time, we luckily don't have to deal with someone that close. So what features are desirable today? Now, the first 2 are CW oriented. Well, even if you don't run full QSK, you probably want really clean semi break-in. I like to hear between words. I don't really need to hear between dits. And a matter of fact, when we tested several transceivers here in Colorado, very few can actually hear between dits at 20 words a minute or faster. But when you're making a call to someone who's calling CQ contest, and then you hear someone else calling and they come back to the other station, you can quit transmitting, you hit your escape key or whatever. So it's really nice to at least have semi break-in. The audio peak filter on CW, I consider a big deal because we listen to signals for hours and hours, 20 hours, 40 hours, and the noise is really fatiguing. So if we can just take the edge off the noise with the audio peak filter, we don't really have to narrow it down to like 100 hertz. You can, but the audio peak filter helps from a fatigue standpoint for sure. And the band scope and waterfall for contesting, multipliers, watch the pileup. It's a de-expedition, where's a hole. So a lot of benefit there from the band scope. We want an efficient user interface. We don't want to be fumbling around to make some sort of a simple change. We certainly need a rock solid connection to our logging program. And at least for me, if I'm running a computer operated radio, I want a tuning knob as a minimum. There's DJ console, the Flex has a tuning knob, so tuning knobs I like. So now let's look at some numbers that appear in QST or on my website. So do you absolutely need the best numbers? And I say no, and I think Doug Grant mentioned that today. You can optimize whatever you have to perform the best in a tough environment. Now, if we're just rag chewing on 40 meters, everybody's 20/9, it doesn't matter. But we're in that contest and we're trying to work zone 40 or that other multiplier that you've been looking for 20 hours. Let's make our transceiver work as best possible. So here's the top 18 specific transceivers off my website. It's sorted by close in, 2 kc dynamic range in a 500 hertz bandwidth. Be clear, this is the first 18 specific models because there's multiple listings for some transceivers. For instance, the K3 came out in 2008, and then the K3S came out. At one point, I was comparing a Flexon 6700 to a K3S, and I did it on 10 meters. So that listing is there. The direct sampling radios, there's more variation in dynamic range measurements and performance in the direct sampling radios from sample to sample, from chip to chip, than there were with the more legacy radios. Now, not night and day difference, but several dB. So there's second samples for quite a few of the direct sampling radios. So I didn't want to take those out of the equation. So this is just the top 18 specific transceivers. Now you can work DX and contests with any of these. You should be perfectly happy with that. And then you just have to decide, where do I want to place my my bet on which transceiver to pick. And the price range is amazing. $1,000 or less for a new price, up to $12,000 or more. And the used market's been heavily affected by when the ICOM 7300 shipped. So the used market is a bargain now today. Of these 18 transceivers, I've run 12 of them in contests and sometimes multiple contests. Just an example, N2IC runs a pair of TS590s. I think currently one's an S and one's an SG. So you can see that the operator has a major effect, and antennas and location, things like that. The transceiver is important, but you don't have to have this one at the top at 110 dB. So here's the elephant in the room. Where will the K4 fit in this table? Well, we don't know yet. It hasn't shipped, but we do know the architecture, and I've confirmed that with Wayne Burdick. The basic Elecraft K4 will be much like an ICOM 7610. It'll be direct sampling. It'll have 2 receivers. The K4 HD with the superhet module and the roofing filters will be much like the Yaesu FTDX 101D or the 101MP. Now the K4 HD will only have 4 roofing filters, 2 per receiver. It'll have 2 receivers. So instead of having up to 10 filters in a K3 or K3S, you'll have 4, 2 per receiver, 1 for sideband, 1 for CW, which is totally adequate. I think we kind of went overboard on needing 5 roofing filters. So we don't even have to worry about that with the K4. As I mentioned, it's a bargain today, whether you're buying a 7300 at just $899. I think the price went up $100 in the last week, but still a bargain. Or the used market, you can get a 590S on QTH.com for $600. And of course, older technology even cheaper. I happen to prefer a radio with a built-in band scope, but there's all sorts of solutions for that. The LP pan's been out a long time. The SDR dongles you can hook up to many transceivers can give you a scope out that feed in the sound card on your computer. So there's lots of ways to get a band scope, and what does it offer? Well, here's an example of 10 meters, the ARRL contest in December 2018. Now, of course, the sunspots have been really poor the last couple of years. So I've spent a lot of time working really weak CW signals, but here we are, Saturday afternoon. There's over 20 stations in a 10 kc bandwidth. So we've got a lot of signals to pick off. And in this case, I was using the TS890S. I really like the way the waterfall works on that transceiver, because you can tune the receiver and it doesn't slew, it just slides the waterfall left or right. So let's look at a few things that are pointed out on this screen besides all the stations that were actually on there in 10 meters. I've got the audio peak filter on. Look at the lower right-hand corner, the arrow pointing to that. And I've got the preamp on. So let's talk about how do we optimize operation of our transceiver? When do we need the preamp? I think Doug Grant mentioned that. Well, let's turn the preamp off and let's have a dummy load hooked up to your transceiver one way or another, the second R antenna port or an RX port, or maybe you just got an alpha delta antenna switch so you can switch to a dummy load. And so we'll tune to a dead spot in the band and we'll have the preamp off and we'll just listen to the amount of band noise and then switch to your antenna. And if the band noise goes up 6 to 10 dB, we don't need a preamp. But if it only went up 3 dB or less, at 3 dB, that means the receiver is contributing half the noise and the band noise is half the noise. Well, we don't want half the noise to be coming from our radio. So we'd really like to know, okay, do we need the preamp on? So if we turn the preamp on and it goes up 10 dB, we've got it nailed. The receiver would be producing less than 1/2 dB of the total noise. I'd say 6 dB is kind of the minimum. So if you have the preamp off and it goes up 6 or 8 dB, keep the preamp off. And in an urban environment, that may not be unusual, although it's certainly less noise on 10 meters than on 40 in a typical urban environment. So what we're paying attention to is net gain. As on this 10-meter slide, and I'll have a 160-meter slide in a moment to talk about the other equation about attenuators, but let's use common sense. Like, do we need a preamp on 40 meters in the daytime? Pretty unlikely. At night, I can't imagine it, unless we're using a beverage or something like that. So on 15 meters and above, 12 meters, just for working DX or a DXpedition, the preamp may be useful in a quiet location, but if you're in an urban location, maybe not. So you do that antenna noise gain test. Dummy load versus the antenna, noise goes up a lot, don't need a preamp. If it hardly goes up at all, need the preamp. Don't do crazy things like having the preamp on 40 meters at night. So what else can the band scope show? Well, of course, we're looking for multipliers or a clear frequency or a DX, but it also shows what's happening in the way of QRM. If the QRM is in our passband, and we've got these wonderful digital filters today, very sharp skirts, adjustable bandwidth, easy. But if we've got splatter in the passband from sideband, we've got key clicks in the passband on sideband, or we've got transmit composite noise, well then our fancy DSP doesn't help in that case. So here's the 160-meter screenshot, also December 2018. This was in the early evening on Friday. Well, there we certainly have plenty of QRM. Again, 10 kc bandwidth, over 30 stations. So there's several things to look at here. First off, if you look over there on the left, it says key clicks 5x. Look how wide that signal is on the band scope, and then look at the waterfall. Now jump over to the right where I just say clean. There's a signal that's within 2 or 3 dB of the one that's wide. Look how narrow that is. On the band scope it's narrow, on the waterfall it's massively narrow. I think the one that's wide is like at least 5 times as wide. So those key clicks are terrible. It may be you're trying to work if there, you can see there's a signal popping up there to the left of his main signal, but the key clicks are right there competing. So be a good neighbor. You don't really want to have your signal look like the one on the left. I do have the audio peak filter on up there in the middle, just above where it says spectrum scope for the same reason. Now let's look at the attenuator on the left. It's at 12 dB. This is 160 meters. Transceivers are designed for 10 meters and now of course 6 meters. There's about a 30 dB or more difference between band noise generally on 10 meters versus band noise on 160. The receivers are all more than adequate on 10 meters and 6 meters. So we've got sensitivity to burn. So again, instead of worrying about whether the preamp goes on or not, what should we do with our attenuators? So again, tune to a dead spot in the band. And if we go from no attenuation to, let's say it has 6, 12, and 18 dB options. punch in the 6 dB. Does the noise in our headphones go down? If it doesn't go down at all, we know that band noise is running the AGC. There's no reason to do that. So now we say, okay, didn't go down, let's punch in 12 dB. In that case, well, maybe it went down a little bit, and that may be a good starting point. I really prefer to have the AGC threshold to be above band noise. That way, between stations, they don't transmit for a minute. You don't have band noise being as loud as the weakest station you can hear. I did a comparison a few years ago between the 7300 and the TS990. Well, the 7300 only has one attenuator, 20 dB. So what did I do? I put the Kenwood on 18 dB and the ICOM on 20. I'm going to run the whole contest on 160 with that much attenuation. Now that was more than I'd run before. I usually ran 12, but this was running 18 or 20. I did have to turn the volume up occasionally for a weaker station, but I'd say 95% of the time, the signals were above the AGC threshold and the band noise was almost out of the picture. I'd be tuning between stations. I could hardly hear the band noise and it was so less tiring. So contest fatigue is a big deal to me. And the noise is a major factor of that. So in this case, we not only help out from the standpoint of reducing noise, but we've maximized the dynamic range of the receiver because on the low bands, we've just got sensitivity to burn. So use that attenuator on the low bands. And if you need the preamp on the upper bands, be sure it really helps. So we talked about key clicks with that one graphic. Well, this is the case, as Doug mentioned, that you can pick terrible rise times with modern transceivers. They almost all let you pick 1 millisecond or 2 milliseconds up to 6 or maybe 8 or 10 on a few, but most of them go from like 1 to 6. Well, slow it down. The difference between your keying sidebands, the key clicks between 1 millisecond and 6 milliseconds is astounding. Look at the difference there. This is a spectrum analyzer catching DITs run at 30 words a minute, key down, and at 1 kc offset, you would hope you could work a weak station 1 kc away from a strong station. The key clicks are 25 dB worse at 1 millisecond than at 6. So just set it at 6 and leave it alone. The Aldercraft doesn't even let you adjust it. They just pick a good number. I think maybe it's 5, but so I wish that the OEMs didn't let you pick a crazy number. It should at least pop up and say, turn on key clicks, be a bad operator, but I don't think they'll ever say that. So how wide is your sideband signal? Well, believe it or not, the typical sideband signal is about 10 kcs wide or more at 60 dB down. We say, well, what's 60 dB down? We're trying to copy an S3 signal and a few kilohertz away, 3 to 5 kilohertz away, there's a station S9 plus 30. Well, if your S meter is calibrated properly, that's 60 dB. So many times the sideband signal will have splatter products that are on top of the S3 signal. So here's an example of this. I was actually talking to K0KA. Now he's kind of a hi-fi sideband guy, so he picks a bandwidth over 4 kilohertz. I wouldn't do that. I'd pick, 2.7 or whatever. But look at that waterfall for the pure signal Apache transmission. Look at it straight up and down. There's no wings on the signal. But then you look down the band 14 kilohertz and look at that signal. It says wide signal. The splatter is that total bandwidth is like 3 times what his regular transmit bandwidth is that we're trying to listen to. So this is pretty amazing what pure signal can do. And this is pre-distortion. And at the moment, it's only available from one OEM. So let's look at transmitters, distortion products on sideband the old way. We've seen them in QST for decades. This is the cleanest transmitter I've ever owned. It may be out of production, but they're Collins 32S3. So the way we measure this with a spectrum analyzer, we put one cursor on one of the 2 tones that are equal tones. That's called the carrier in this case, dBc, dB below the carrier. And then we put the other cursor on whichever distortion product we want to measure, 3rd, 5th, 7th. So in this case, it shows on the 3rd order, it's down 36 dB, and the 5th order is down 47. But even more important than just the numbers there, this is a span of plus or minus 20 kilohertz. And you can see the distortion products are like 80 dB down way before we get to the edge of the screen. Here's the second cleanest transmitter I've ever owned, and that was a TS990S with a 50 volt PA. Now the third order was only 2 dB worse, but look at the distortion products that admittedly are 80 dB down go clear to the edge of the screen. So that's quite a difference compared to the Collins. And then here's a K3. And as you can see in this case, it's 27 dBc or 33 PEP, which I'll explain in a minute. But in this case, they're still going strong before we get to the edge of the screen. So here's where it's a prime example of why the dynamic range of the receiver on sideband isn't an issue at all. We're 4 kcs away, where that big vertical arrow is, from the transmitting station, and the distortion products are only down 45 dB. But the dynamic range of the transceiver, in this case the TS590S, which was one of those 18, is 92 dB. So 92 dB receiver dynamic range, distortion products 45 dB. You can see the receiver is not a limit whatsoever. So what is the limit today? Receivers are just amazing. The improvement in the last 10 plus years is astounding. Transmitter cleanliness, no, hasn't improved except for Apache Pure Signal, and Pure Signal written by Warren NR0V, Warren Pratt. So the types of undesirable signals that are on the air close by are IMD splatter, key clicks, and transmitted broadband noise that I mentioned really can be a problem in field day, or if you've got a ham really close by. Hopefully you read my article in November 2019 QST. I really commend the League for publishing the article. It's time to clean up our transmitters. The receivers are now tremendous, but there really hasn't been much in the way of improvements, and in some cases they've gotten worse. In the same issue as my article, there was a review of the expert 1.5 KFA, and the normal PEP measurement of the third order product was minus 28 dB. But they also tested it with this Apache running pure signal, and it improved to minus 47, a 19 dB improvement in splatter, just like you saw there with the K0 KA versus the splatter signal. So 19 dB improvement is not minimal. So the types of noise that the article discusses are IMD noise, splatter, key click noise, or transmitted broadband noise. And we would hope not to have any of those. So this is a case where maybe competition will help improve things. I did get quite a few emails commenting on the article. I didn't hear anything from any OEM. So it's really down to the hams to say, do we really want to improve our signals? Let's not have crazy rise times on CW, and can we improve our transmitted signal for sideband? Right now, Apache is the only one that has the pre-distortion. Elecraft says when the K4 comes out, they will eventually have pre-distortion. And the pre-distortion, maybe it's down the road a year, I don't know, but you can also put your linear amplifier in the pre-distortion loop. Almost all the newer amplifiers that have come out in the last few years have a sampler output right on the amplifier itself. But if you have an older amplifier, this is no problem. You just add a sampler to the output of your SB220 or something like that, and it feeds back into the transceiver. Flex has talked about pre-distortion for a long time. It apparently is low in their list of things to do, but just think, if Apache has it now, Elecraft says they'll have it in the future, and if Flex comes along eventually, that will mean 3 of the 6 OEMs could have extremely clean transmit signals, particularly including the LD MOS amplifiers, which are now pretty much the way they all work. I guess the question is, do the hams care whether their signal is wide or not? I know some contesters like to be wide, but that's really not the way to do it. We're supposed to be good neighbors. So solid state amps are not so linear, which is kind of disappointing. the ARRL published a compendium of amplifiers in 1997, and every one of these tube amplifiers, the third order product was down 40 to 50 dB. Now the typical is 30. The Elecraft KPA 1500 is minus 30 on 20 meters. The Power Genius XL, minus 30 on 20 meters, a little bit worse on 10 and 6. That SPE Expert that was in the November issue was minus 28 without the pre-distortion. So you can see that's pretty much the way the LD MOS amplifiers work. And that's can be significantly worse than some of the transceivers. It'll be, at least 6 dB better than that. So the linear amplifiers can make things worse now as we've gotten away from tube amps that you have to tune. Some of them are out of tune, but most of them not. And then the solid state, of course, you just change bands and off you go. For the ARRL March DX contest this year, I just worked 15 meters, just a single band effort. It's really quiet out here where I am. I used to Fort Collins, and I've got decent antennas. And it was really an eye-opener because the signal noise is so much better than like on 40 meters that there were a lot of splattering signals. And some of them so bad, the transceivers couldn't be that bad. So I think the ones that were just awful, they're overdriving their linear amplifiers. I'm using the word linear in that case kind of as a joke. We really should be monitoring our signals. I use a scope all the time. You can get band scopes. You can use a standard Tektronix or whatever scope with a sampler to pick off your signal. And so I run it all the time. I really want to know what's happening. So don't be a slave to one number. And we saw 18 transceivers that you could be perfectly happy with. There's a great product from all 6 of the major OEMs. So pick your personal desire for performance. You want 90, you want 100, whatever number you say, okay, I want that. And then we need to look at the whole picture. Examples, good ergonomics. The radio should be easy to use. It should be reliable. If it breaks all the time, that's no good. If it's going to break, it's going to break in the middle of a contest. Factory service, really important. How many of us want to work on a microscopic surface mount capacitor? So factory service is key. And we want clean audio. Now, I've talked about contest fatigue. On receive, I don't want distortion or hum or buzz or anything like that in receive. And so I get tired when there's anything makes it worse. It's just coming out of the receiver. It doesn't need to be there. The transmit signal should be clean too. But it also, one thing's important is equalization. Bob Heil talks about this all the time. We don't want to sound muffled. I mean, sometimes I'm on the air and I can't even copy the guy's call because he's almost talking like he has his hand in front of his face. So we need to have typically roll off the bass, bring up the treble. Depends on the spectrum of the microphone, but between the microphones, passband, and the EQ built in most rigs today, we can get a nice crisp signal that has good sibilance. Sibilance is how that intelligibility really works. Well, since majority of us are in an urban environment, noise reduction and noise blanking are really important, and there's quite a variation in that. So that's maybe a really key point on which rig you buy and how's the noise blanking and noise reduction. Of course, we really probably want a spectrum display, and almost everything today has updates of the firmware. And if we go clear back some years ago, just like a Pro 3, I used to own that, it was what it was. But now the newer models of everyone, you put in an SD card or however the update occurs on your radio, we get bug fixes, new features. Matter of fact, if you go clear back to the ICOM 7800 or 7700, new features came along with just sticking in a memory card and updated the firmware. So this is great. We want that, and we would hope that the OEMs keep putting out bug fixes and updates over time. One thing that may not think about a lot is what is the total cost of ownership? So sometimes an expensive radio can also be expensive to fix. So we need to look at how much is it going to cost me to keep this radio for 10 years?
5 minutes, Rob.
Very good. So how can we improve reception? Well, better antenna. Of course, Doug talked about this. Frank talked about this. Directivity is really important. I'm out here in the middle of the country. I got QRM coming from the East Coast and the West Coast. For my monoband Yagis, it's the rejection off the back and the side is more important to me than the gain, which is 4 or 5 dB. Consider an RX antenna or maybe different polarization. maybe it's an antenna for another band. You've got a vertical on 160, you've got an 80-meter dipole. Sometimes it helps to listen on the other antenna. There's noise canceling devices. MFJ makes one. There may be other brands. You've got a little antenna that just picks up the local noise and you can null it out. I know the Apache can do that just with the 2 receivers. Maybe the Flex can too. So sometimes you don't even need an accessory. I'd say a 3-element Yagi at 40 feet will do wonders compared to a vertical like the 14-foot vertical or even the 43-foot vertical or a G5 RV. Directivity is really helpful. You don't have to go quite as far as I did. Here I go off the deep end, and there's my place out here in the country. There's 6 towers, there's 9 HF Yagis. So some of us kind of push it to the max, but it was fun doing that. Remember, there's all sorts of information from past contest universities. There's a link there. Also, I sometimes do some quick comparisons between a couple of radios. Usually when I'm in a contest, I'm comparing 2 radios at the same time. And some of that information is published by DJ0IP, Rick. There's a link, or you can just do a Google search. And there we have it. Rob at nc0b.com if you have a question. Tim?
Yes, thank you, Rob. Great presentation. And is it 12 or 13 years you've been doing Contest University now?
It's one less than however many contest universities there have been.
Well, there's 14, so that's 13. And thanks very much for all you do. You really exemplify giving back to this hobby by running all those tests and sharing. Love the way you share. You just share so much of what you know, and amateur radio is better for it. Bill, what do you have for a question for Rob?
Yeah, sure. So we have a few questions along the lines of some of these features in like modern 7610s like Digicel, or the FTDX 5000 has IPO 1 and 2. How does that help with close transmitters?
Actually, I didn't follow the question. I'm sorry.
So does the Digicel filter in the ICOM 7610 help with
Oh, the DigiSelect. Okay.
Yeah.
It helps on particularly out of ham band signals, like on 40 meters. If you're on the low end of 40 meters CW and there's broadcast stations above 7,200, you've got about a 10 dB reduction. So in Europe, that's probably a big deal. But if you go up to 20 meters, signals within 20 meters, the attenuation at most might be 3 dB. So I'd say it's mostly out of ham band. Of course, on 160, it's going to be more, but we're probably squeezed in 60 to 80 kilohertz on 160. So again, the difference won't be night and day, but it's if you're in Europe, I think you'd have the DigiSelect on all the time. Out here in the middle of Colorado, I don't need it.
So Rob, on the Yaesu FTDX 5000, Bill was asking about the IPO settings.
IPO means no preamp. So it's kind of a funny way to list it. So yeah, that just means no preamp or preamp 1 or preamp 2. It's kind of confusing.
Okay, Marty, do you have a question?
Sure. So there was a couple comments for people who didn't know about Apache predistortion correction, and people also wanted to know if they were doing that and they were using an amplifier that didn't have a tap for a low-level signal reference, how they would build that themselves.
Well, it just needs to be an attenuator of about 50 dB. W3LPL published in QST, and maybe it's in the handbook, a way to make a sampler. So I would say just send me an email, rob@nc0b.com, and I'll connect you with to Tom. But it doesn't have to be complicated. You just need to reduce the signal about 50 or 60 dB, and you can put it on the output of any amplifier that you have that works. So you don't have to have a modern amplifier to do that.
Great, thanks, Rob. Bill, another question for Rob.
Yeah, sure. So what do you think a good reasonable minimum number for transmit system level third order IMD is? And that's including like a radio and an amplifier.
Well, we know from a reality standpoint that 35 PEP is about as good as most are. In the case of the TS990S, it actually was about 39, but then others are barely make 30. So most things are kind of in the 30 plus dB range if you're not running your knobs at 11. In some cases with like the FTDX 5000, if you run any ALC at all, it's going to degrade the splatter product. So in some cases, ALC can mess it up. But just think, if we could all improve our signal by 20 dB with pre-distortion, wouldn't that be fantastic?
Marty, what do you have for Rob?
Sure. So actually, this kind of, you started to get at it in the last question, but somebody asked, I know some people talk about using ALC with amplifiers and some people don't. Should I be using ALC with my amplifier?
I think in some cases with the solid state it's kind of required. I think with the Icon PW1, for instance, it is. Some of the alpha amplifiers that I have don't even have an ALC port, and then some do, but I never use it with a tube amp. I think you should follow the OEM's recommendations on the solid state, but I'll tune up the amplifier key down. I have my scope. I set it for like just a little over 6 divisions, and then I go back to sideband, back off the gain because the peaks are always higher, and I just watch it on the scope. But ALC on a tube amp, I think, is totally needless.
And Bill, if you could maybe get closer to your mic, your audio level is a little low. That'll do it. Bill, how about another question for Rob?
So we don't have a lot of questions here, but any comment on the new Sun SDR products?
I unfortunately had a problem when I tried to use the MB1. Is that what you're talking about?
Yeah, MB1, MB2.
The question didn't specify.
Okay. I had it here 2 or 3 years ago, and it was very difficult to set up. And maybe it was a learning curve as far as the product. The unit never could get the serial port to talk to N1MM. They ended up using a remote connection to the rig and the amplifier. No, my computer, and they did some Ethernet method to make it talk to N1MM. That finally worked, but then I couldn't consistently key any amplifier, either the ACOM or the alpha, and I tried different ports. And then one day before the contest, I went to dinner. Everything was working as much as it could. I came back from dinner and it broke. So I never got to use it on the air. So I don't, and this goes back like 3 years. So you'd have to ask someone else that's used it since then. But it was a frustration on the MB1 in my case, very early on.
Marty, what do you have for Rob?
Yep, we're wrapping up as far as questions here. Somebody asked if you had used the SDR Play receivers. Are they useful as a second receiver?
I haven't, but some of my friends in the Boulder area, my Boulder Amateur Radio Club where I belong to, have them. I consider more useful for a band scope. I mean, they don't have room for much of any kind of front end filtering, so I just would look at them as an adjunct. I don't see much of a reason why, with whether your receiver has, like the 7610 has 2 receivers, or the Kenwood 890S has 1 receiver and an XIT. I don't see quite why we'd want to do that, but again, I haven't used them personally. The numbers are pretty decent, and certainly as a band scope, they're fantastic.
Thank you.
Anything else, Bill or Marty?
There's some questions about using diversity receive and if that's beneficial. If you want to talk to that.
I've definitely heard some comments, and I think Frank talked about that with the antennas far enough apart. Of course, he was talking about mostly 160. They have to be quite far apart. I think he said 500 or 600 feet. I played with it with the K3, and I played with it with the ICOM 7610. In that case, with the 7610, I had 2 20-meter Yagis that were 200 feet apart. Maybe that's adequate. Sometimes they'll say, well, one should be a vertical and one should be a horizontal if you're on the lower frequencies. I'll have to defer to people who've done it more often. I found it was an interesting way to listen to the station, but it also had this funny swirling sound. The audio sometimes would kind of swirl around the room. So to me, that was a little disconcerting, but possibly with a different antenna setup, it might make a big difference. So I'll have to defer to the people that really spent time doing it. I've only done it with the 2 different radios.
Bill, do you have anything else for Rob?
I do not. I think that concludes our questions.
Okay, Rob, thanks again. And it was great hearing you. here, and we will look forward to seeing you next year in Dayton, Xenia.
We'll all look forward to that for sure. Thanks, Tim.
Okay, 73. So a little some housekeeping here. Still a lot of confusion in the chat room on what's going to happen as we roll along. We have one more presentation, and then formal presentation, and then we have the CQ Contest Hall of Fame, which is a great presentation that K3ZJ is heading up, and we'll learn who the latest inductees are into the Contest Hall of Fame. At the conclusion of the Hall of Fame, those attending from the 50 United States, those who were online at that time on Zoom, not on YouTube, on Zoom, will be eligible to win the ICOM IC7610 transceiver that was donated by Ray Novak and ICOM America. And once again, thanks to ICOM America for everything they've done over the years to help Contest University, as well as thanks to the YASME Foundation, thanks to the Northern California DX Foundation, and thanks to Terry, Kate, MNJ, Jerry, K1SO, and everybody associated with Contest University, the professors that work so hard to put together these events, and to Corey, W3CDG, who has been the wizard behind all of the smooth operating here today. This event has gone very well. So I'm going to go through Frank's bio here again. The next presentation is something that Frank said that he had, and I thought it would be very interesting to share with all of you online. This is 60 years of competitive contesting. This is the W3LPL story. And Frank, W3LPL, started in 1959 at a field day. He was 12 years old in Rhode Island. And soon afterwards, he built a small contest station on 1/10 of an acre, very small lot. He has gone on, he was in the Air Force. He was second lieutenant, and his assignment was in the Washington, D.C. area. And Corey, if you could mute everybody but me, that would be good. And he got to meet PVRC member W3GN, and then went on to meet his multi mentor W4BVV. Although most of us know Frank as a multi host and great operator, he actually won several 4 CQ Worldwide CW single ops and 4 ARRL CW DX contest single ops in the middle 70s. And he also went to PJ9JT, which is we know now is very close to, well, is PJ2T in 1974. And so 43 years ago, W3LPL started in multi, and they won their first one in 1982, the ARRL Phone DX contest. And that was the same year that Jim Lawson, W2PV, became Silent Key. There are other things about the W3LPL team, and I'm sure that Frank is going to put those into his presentation. He was inducted into the CQ Contest Hall of Fame in 1999. He has been a stellar regular presenter, sometimes presenting 3 and 4 papers at Contest University over the years. He retired 9 years ago as a chief engineer at General Dynamics Corporation after a 45-year career in electronics and system engineering. Please welcome Frank Donovan, W3LPL.
Thank you, Tim. Can you hear me?
Yes, we can hear you. Go ahead, share your screen.
Okay, well, let's get this on the road here. Okay, that should do it. Okay, so we're going back to the coast of Ireland here. This was taken a few years ago on the Irish Sea. And it was a nice, bright, sunny day. And 5 minutes later, my wife and I were running indoors to get out of the heavy rain. This is a snapshot of a quadcopter video that Tim, K3LR, and W8WWV took 4 years ago. And little did I know, a few days later, something would happen that you're going to learn about halfway through this presentation.
You want to hit slideshow and go full screen, Frank?
Yeah, sorry about that. There we go. Okay, thanks, Tim. So there it is. I'll just briefly mention what this is. So you can learn all about this station on my QRZ.com page. What you're looking at here is 4 200-foot towers. 3 out of the 4 were installed when the station was built in 1986, and the 4th one replaced one that fell a couple of days after Tim's visit. No relationship between the two events, I'm sure. And 3 rotating towers that were installed about 20 years ago. So Tim mentioned that I started in 1959, but it's really not true. I started in 1922. What? He said. But it's true. I grew up in a multifamily home. The home was built by my great-grandparents in about 1918. And my grandparents were married and moved into the 3rd floor of that home in 1921. My grandfather was still a teenager. And in 1922, this thing that probably had at least as much effect as the internet did on our generations happened in 1922, and that was AM radio. And it burst on the scene. One of the reasons it burst on the scene was this vacuum tube you see in the lower left-hand corner. It's the RCA UV200. It was the first mass-produced vacuum tube that was available to the general public for an affordable price. It was $5. So my grandfather, as a teenager, recognized there was a business opportunity in the explosive growth of AM radio once AM radio appeared in our town, Providence, Rhode Island. And he started building these one-tube radios for some of his relatives and close friends. He could build these radios much, much less expensively than the AM radios that you could buy off the shelf then. The AM off-the-shelf radios were over $100, and he could sell these one-tube radios that were completely adequate for about $25. So along comes young Frank Donovan at age 7, and my grandfather decides, hey, let's see if we could enjoy building these radios again. So he pulled out a lot of these 1922 components that he had saved, never knowing what he would ever do with them. And my grandfather and I started building one-tube radios, just like he did when he was a teenager. And we also built crystal radios. We didn't use the cat's whisker crystals that would have been used way back then. We used 1N34, so we cheated a little bit. And we used the UV200. And we tried, we experimented with other manufacturers' tubes from that era that he had stored away, and we had a good old time. The only components we used that were not bought in 1922 were the batteries. But apart from that, everything was from that era. And a part of a one-tube radio in that day is something probably only a handful of the audience has ever heard of, something called a grid link. And in that diagram, it's R1. And that's how the bias on the tube was developed, was just literally from the grid current that leaked off the tube, and the value of that set the voltage on the grid. Okay, so my grandfather's experience was AM radio. So all of the one-tube radios we built together were all, although they were probably capable of operating the shortwave bands, that wasn't his experience, and all we did was AM stuff. It was a lot of fun. But he realized that, gee, maybe I should move a little further than just AM radio. And when I was 10 years old, actually 9 years old, so it was a couple of years later, he arranged with our TV repairman to purchase a Holocrafters S38D. That's what you see in the middle of the photograph here. It was about a 1954 era radio. It was produced from about 54 to 58, so it was kind of in mid-production when my grandfather bought this for me. And of course, my experience was AM, so I did AM SWL stuff with this nifty radio. But then I discovered, hey, if I tuned up in these shortwave bands, and shortwave radios in those days had names of all these cities all around the world, and that's what all that small writing is there. So I decided to look around, and I found HCJB from Ecuador and Radio Moscow everywhere, and even Radio Australia, and they all said they would like to send a QSL card. So I went off to the post office and bought 3-cent postcards, sent them off. This was also 1957, and that was the peak of Sunspot Cycle 19. And in the course of doing my shortwave SWLing, I discovered neighboring hams. And the two US QSL cards shown here are two of the DXers in the same city, Providence, Rhode Island, where I grew up. And these guys were on 10 meters. It was the most interesting to listen to. They'd be up. Of course, the calibration on the S38D wasn't good enough to tell exactly where you were listening on 10 meters, but they'd be calling a CQDX, tuning below 28,500, tuning below 28,500 for DX. This is W1 Whiskey Kilowatt Ocean. And they'd be answering these guys, and I could hear a few of them from all over the world. So, boy, that really piqued my interest. I had to learn about this, so I went off and bought a call book to figure out where did these guys live, because they never said. So I went off to our local radio wholesaler, which had a small business and image radio, and bought the call book for $4, and discovered where these fellows lived and some of the other hams in Providence. And I got on my bicycle and I went around and visited these hams. And that's how I kind of got in ham radio, was by discovering the local DXers, and the other people that were very active on 10 meters were mostly mobile people. The kind of stuff we have on like 2-meter FM today was on 10-meter AM in those days. Okay, so after meeting these hams, it became apparent to get licensed, of course, you had to know the code, and you didn't just go out and buy a program and put it on your computer then. You went to mail order and with this company called Amico and purchased a code course. And you didn't use a code practice oscillator, you used a buzzer made by E.F. Johnson, and the telegraph key there is also made by Amico. So this is how you did it, and you kind of went to work and started learning. But it didn't end there. There was a very popular column in Popular Electronics magazine by W9EGQ, Herb Breyer, who was absolutely a gift to everyone who ever wanted to be a novice. I have no idea how many people became novice hams as a result of Herb Breyer's column, but there were many of them, including me. So if you can look at these Popular Electronics magazines online, they're all published there. And if you go to the 1958 issue, you'll find my name in Providence, Rhode Island, listed as desiring to get help getting my novice license. Well, by then, my code speed was already pretty good, but I didn't know anything about this radio theory stuff. And 3 hams replied to my request for help, 3 hams in the local community. One was W1AWE, who lived on the other side of the city, but his workplace was just a couple of blocks from my home. So he called and asked that I come visit him at his workplace. And he had a stack of about 2 feet high of QST magazines, which he gave me. And I'll tell you, I've read every single word in every one of those magazines. And turns out Norm was a 20-meter CW DXer ever since the middle 1920s. So he told me a bit about that. I didn't know anything about CW DXing. Knew a little about 10-meter DXing from listening to the local guys. So that seemed good, but he wasn't particularly interested in coaching a 12-year-old boy. And then another fellow that replied was K1AAI. He was a college student. And I visited him. He was about 2 blocks from my home, and looked at his station. It was a Heathkit station, AT1, and whatever the Heathkit receiver was of that era. But he was heading off to college. But he said he would call another local ham that lived a block or so away, who turned out to be my Elmer. That was W1WJY Frank Heiss, who was about 70 years old when he met me. And he invited me into his home, and then I would, once a week, my parents would drop me off at his home, and I'd spend a couple hours there. He very quickly figured out that I could receive Morse very well, probably perhaps better than him from all that practice. But I didn't know anything about radio electronics other than what I'd learned from my grandfather. So a couple of months later, he said, well, you've kind of come to the end here of what I can really teach you and what you need to know. And then your next task now is to get licensed. And he suggested that I go off to a radio club. And boy, was this ever a breakthrough for my life. And the advice I consistently give to anyone who wants to get involved in contesting is find yourself a radio club. Will this ever change your experience? And it certainly did for me as a 12-year-old. So I was taken to this club in about April of '59, took my novice license exam 6 weeks later, probably. And field day came along. So this 12-year-old was invited to come, and my parents said, sure, go ahead. So they let me go with this group of men, ages anywhere from 16 to 70. And I spent the weekend with them. Now, this couldn't happen in 2020. It's just, there's no parents who would ever allow this. But in 1959, this was okay. So the tent you see there is an Army tent that we used for the CW station. The CW station was a Viking 2 and an NC303. The sideband station was amazing. I had no idea what this sideband stuff was all about. I had heard these signals on my S38D that couldn't be copied, couldn't be listened to. And there was this brand new Collins KWM1 transceiver that the sideband crew was using. And they were making contacts all over the world with this KWM1 with a 20-meter quad that was only about 30 feet high, a 2-element quad. Now, this KWM1 was a revolutionary change in our hobby, a progenitor of things to come. It's a high-performance transceiver, operated only on 20 through 10 meters, and it was just something amazing to see. I spent, although my interest was CW, this sideband transceiver was so interesting to me that I spent most of my time, I think, with the sideband operators. And they were making all these DX QSOs. So I'll just mention well, we'll go on to the next slide. This is the location where the field day was held. This is the clubhouse. It's still very much in use today. W1OP, the Providence Radio Association. They just had their 100th anniversary last year. That big log periodic array was not there when I first joined the club. The one and only antenna at this club was a high gain 14 AVQ vertical. It's a little 12-foot high or so vertical on the roof of their clubhouse. And that was it, nothing else. The field day was held in the woods that you see here. This is, as you can see from the view here, this is quite a location. It's one of the highest hilltops in Providence. And the view to the north and the northeast, the east and the southeast is incredible. It's an amazing location to Europe. This hill is very flat on the top, so it's just a very average location to the west. But to the other directions, it's truly remarkable. So this is the home where I grew up. My grandparents lived on the 3rd floor. We lived on the 1st floor. And when it became apparent I was going to get involved in ham radio, my grandfather built a big ham shack for me in the basement. I never acquired enough equipment to fill that ham shack. but it was absolutely ideal. So there's my first call sign, KN1LPL, that went through early 1960, and then K1LPL after, I guess the license arrived in March of 1960. This house was in a very dense urban environment. We had 1/10 of an acre of land. That was much more than any of the nearby houses. They typically had half of that or less. So it was a tiny space. I never had anything but wire antennas. But you know, I didn't know that I couldn't succeed from this location. And I think if someone had told me I couldn't succeed, I wouldn't have accepted it. It's a good thing. So my first contest after that field day, in which I was an observer, I wasn't licensed. My first contest was the 1960 Novice Roundup. So that was February 1960. I operated for 33 hours over 15 days. It made 48 QSOs. Pretty good, I thought, until I saw the results and saw that another ham had made 148 QSOs in Rhode Island in about the same period of time. But the nature of this contest was kind of interesting. A very high percentage of the participants were schools, were students. Ham radio was heavily dominated by teenagers back then. And most of the activity was after school, so kind of around 4 or 5 o'clock in the afternoon. So my little Amico AC1 transmitter on the right there, which probably on a good day put out 5 watts, is what I used, and made 48 QSOs, which I was very proud of. The receiver there was a Holocraft's S108, which replaced my S38D on Christmas Day 1959, and my Amico key that I had used for code practice. Okay, well, that wasn't a suitable station for a general class licensee, so did a little arm twisting with my father, and he purchased for me from a local ham a Harvey Wells TBS 50C transmitter. That's a 1949 transmitter. On a good day, it put out 25 watts, and a rather chirpy CW signal, but it had a VFO, so that was a big step up from crystal control. So my first contest as a general class licensee was the April 1960 CD party. For the old timers here will remember the CD parties as the place where contesters really learned their skills of running and searching for multipliers and that kind of thing. Well, I was only on for 2 hours and made 19 QSOs. The very first QSO, this is his current QSO, his current QSL. I didn't have an old one, but my first QSO was with W3WJD, SIG. Everybody knows him as N3RS. He's been very, very active for almost all of the years since before 1960 until today. And then my next QSO was kind of an interesting one, W3GQF, Johns Hopkins University here in Baltimore. And the two operators turned out to be W3LPL multi-multi operators. Who would have thought that could have ever happened? The person who made that QSO was W3WZL, who is now a silent key, Dick Chambers. And the other operator who wasn't there during this particular CD party, but he operated many, many contests from W3GQF, CD parties especially, was Roll Anders, K3GJD, who is now K3RA and has operated well over 100 multi-multi operations for my station since we started doing that many years ago. So, so let's take a look. My first sweepstakes. That was 1960. So I'm getting a little bit better. That was 38 hours of operation over 2 weekends. Sweepstakes was a 2-weekend contest in that period. And it was both CW and sideband, but you had to pick your mode. You couldn't operate both. So you either entered the CW and entered that score, or if you wanted to do sideband also, you could, but it'd have to be a separate score. They ran, I simultaneously. And CW was far more popular than phone in that period. So I did a little better. I'm starting to get a little bit competitive, but boy, it sure took a whole lot of hours to do that. I just want to mention a few of the QSL cards that I received from this sweepstakes. These are some of the legendary hams from the earliest days of contesting. W3BES, who was later W3GM, one of the long-standing members of the Frankfurt Radio Club. Two of the giants of the Potomac Valley Radio Club, W3GRF, Len Schertok, who was one of the founders, and then one of the hams that he recruited into PVRC immediately afterwards, Vic Clark, W4KFC, who became an ARRL president. These two folks really became my mentors in contesting after I moved to Washington, D.C. And the other giant of the time that I worked was W9IOP, Larry Lacashman. W3GRF was mostly a DX contester, but he was very loyal to PVRC and participated in essentially every sweepstakes that I'm aware of. W3BES, later W3GM, had won single up high power several sweepstakes before World War II. And W4KFC and W3GRF operated not only sweepstakes, but in DX contests. And Vic had won 6 sweepstakes contests post-World War II, single up high power USA, and many more DX contests during that same rough period of time. And W3GRF was mostly a DX contester and won. And he and W4KFC were the legendary competitors. If you look at who won which contest during that period from the 50s to the 60s, it was typically one of those two guys. And occasionally someone else would sneak in, but not very often. And there's one other QSL card here of a W3LPL multi operator, and that's on the right side, K1 Hotel Tango Victor, who just retired from multi contesting recently. But he was a 160 operator at my station for many years. So what did we use for computers? Well, this is what we used. Operating aid number 6. 2-sided sheet of paper, and we scribble the call signs in there, and sometimes you work so many of these things that the call signs wouldn't even fit in the boxes. So that's how we did things back then. Well, in 1962, I won my first contest. It was the New England QSO party. And I did it through a little bit of trickery. It was perfectly legitimate. In 1962, the kind of local activity we have on 2-meter repeaters, or we used to have until recent years, was on 10-meter AM. And there were 10-meter AM nets all over New England. So what I did in this contest is I worked everybody I could that was active in the contest, and then in the evening, and I knew where all these nets were, and I went around to these nets and worked all of them too. And that resulted in that plaque. And there was an addition to my station, and that was a very popular 150-watt homebrew amplifier made out of surplus TV or leftover TV set electronic parts, and that's shown in the lower right-hand corner. A very common way for hams to homebrew equipment back in this period was to take apart old TV sets and use the parts. This little amplifier used a pair of 1625s, probably 75 watts out on a good day. So I'm finally learning to be competitive. Electronic keyers were just beginning to be popular around this time. So I built a keyer it was in QST, a K2POO keyer, all vacuum tubes, and bought this paddle, which turned out to be a legendary paddle, the W8FYO paddle. Really fantastic. I still use it. And that sweepstakes in 1962 was my first sweepstakes with a 100K score. And to this day, a 100K score is kind of the threshold at which you achieve some degree of competency in sweepstakes. So I did that, but it took 2 weekends, 40 hours over two weekends to make 720 QSOs. Well, along comes 1964, and I'm a high school senior. And for DX contests, I entered them, but almost exclusively just to add to my DX contests or DXCC totals. And that's how I approached this contest too. I really didn't have much capability to run anyway with 100 watts and wires. So I was a DXer, and I went off and worked some of these stations you see here. Many of the prefixes here don't exist today, like VP7 or KR6, KC6BK, KZ5, of course, is no longer a U.S. territory, and VP2KR, VS1LP. None of these exist today. But these were real juicy multipliers, and I probably spent a lot of time in pileups waiting to work these people, but I did. And then amazingly, after the results were published, I wound up first place USA, low power. Mainly because there was no serious competitor. You never know in a contest how the outcome is going to be, and this is one of the most classic cases where a very basic station of somebody who wasn't really a serious competitor winds up number one. You never know what you can't achieve or what you might accidentally achieve. And this wasn't the last time this happened. And what did a log look like back then? The CWDX contest had quotas. You were only allowed to work 6 QSOs in each DXCC country. So you can see in this log that this was published in QST that year in the rules. In this example, you had worked as many Gs as you were allowed to work for points. That was the end. And this is what the log looked like. It was ordered by country. And this continued until 1966 when the quota system was abolished. There were no quotas for phone. And I use phone for a reason, because almost all the activity through the mid-60s was AM, and trying to work large numbers of DX contest QSOs on AM was an extremely difficult task. So no reason for quotas. It was self-limiting. Okay, so now comes along 1968. I'm getting ready to graduate from college, and I've got some time to get serious about contesting again. And myself and K1JYN, who none of you have heard of, but he's now K6LL. I don't think anybody listening has not heard of Dave, K6LL. We join up and see if we can do really well in field day. We were able to get this old Federal Communications Commission signals intelligence monitoring site from World War II. The telephone poles were still there. You can see them in the photograph from the 1940s. So the Providence Radio Association went to this site for 1 year only. They had been there a couple of times in the 1950s. We went back there, and you can see the result. First place in 4A. A little more than 2,000 QSOs, and we used pretty good equipment from that period. Collins S-Line that I had just bought, 75A4 and C303, a couple of Holocrafters HT32s, and it was quite a memorable event. The state of Rhode Island owned that old FCC site, and shortly after this field day, it was sold at auction. And my recollection is that it auctioned for only about $20,000. If only we had some money to do that. But it wouldn't have mattered, because my draft notice came shortly after that field day. And off I went to the Air Force. So first field day from Maryland was 1970. K1JYN came down with his fiance, who you see on the right-hand side there, and my wife of less than 1 year is on the left, and there's the generator we used and some of the equipment we used. We did this mostly just to have fun. So we went into the 2B category with kilowatt power and made almost 2,400 QSOs. We had a good time, and both of us are still married to the same women, so I guess they enjoyed it too. They never expected that this photograph would appear in QST. Dave and I kind of suspected that it would, and we were right. So this slide is slightly different from what's online, and I will correct it. My memory was a little bit foggy. My first sweepstakes sideband contest from Maryland was in 1969 from a small apartment on Fort Meade. And this contest made a big difference. Not so much because of the score, but because there were so many complaints by the other officers that lived in that apartment complex that I was relieved of my obligation to live on base. The base commander said, "This radio operation of this apartment must stop, and I'm going to allow you to leave the base if you need to." And I said, "Sir, give me the letter that gives me the approval to get off this base, and I will be gone." And by April of 1970, I no longer lived on the base. They were happy to get rid of me, and then the story continues from there. So we built a second house on that same property in 1974, and I had been dabbling in DX contests and decided to try something that no one had tried in a serious way at that point, and that was to use a pair of S-lines and a configuration that today we call single operator 2 radio. I had been getting a little more competitive in DX contests up until that point, but this made me a whole lot more competitive. And over a period of 4 years, I was able to finish first place in the CQ Worldwide CW DX contest and the ARRL CW DX contests 8 times out of 10 attempts. And that was with this SO2R setup and a couple of homebrew amplifiers, one of which you see there, 3-1000. So as we got to the end of this, I'm an engineer at heart, and I couldn't think of anything really significant that I could do technically to advance my competitiveness. And by then, other people had kind of figured out how to do this SO2R thing. So my advantage was declining. So I decided to try something different. And here's what I tried. This young ham, WA2LQZ, came down from college to join me. We all know this young fellow as John K1AR, and a few other local hams got together, and we placed in the top 10. 2,500 QSOs. This was a 2-weekend contest. 2-weekend DX contest continued through 1978. So can you imagine? This is a phone contest. No, you can't imagine. The second weekend of the ARRL phone contest was excruciating pain because you had worked almost everybody that was active in the contest. Now, obviously, stations like W7RM and W2PV found more, but stations like mine could not. And again, some of the call signs you see here are some of the giants of multi contesting back in the 1970s. Rush Drake, W7RM, W2PV, who passed away a few years after this. W1RR, who was W1CMH, who was a neighbor of mine in Providence. W3AU, PVRC multi-station, and W4BVV, who was one of my colleagues at work. K3WW, who is still very active today, of course. I don't have a QSL card for W6PAA, but Ken is still very active today as N6RO. W3BES, who was W3GM at that time, and one of my PVRC mentors, W3FA, who at the time was, or who I don't have a card from, but was W3MCG before that. And W4BVV put me up to this. Blame him for this mess for the last 43 years. So unexpected things happen. So now we're in one weekend contests. The 2 weekend nonsense is done. ARRL sideband contest, very competitive, as you can see from the scores, but a big surprise happened, and it played right into our hands. There weren't very many stations with 10-meter antennas way over 100 feet high. And I had installed one the year before this at 140 feet. And we had the most incredible JA openings on both Friday and Saturday night. And we were set up with 2 radios on each band back then. And I remember the fellow who was running JAs late into the night. I listened on the other receiver and I said, you know, there's nobody on 10 meters other than JAs calling you. Other than that, the band is dead. But there's this pile up of JAs, and the same thing happened the second night. And that's how we wound up winning this thing. Totally unexpected. We never, ever thought we would win a multi contest this early in the game. And we won one more from this location, a CW contest in 1985. And this is what the station looked like back then. Where are the computers? Well, there's just paper, no computers. So you see S-lines, which were still very popular back then in the 80s. TS-830 on the far left, that's K3RV. And there's a C line over there on 160 meters on the right. And the other operator there on the right is Walt W3FG, who bought that house from me. And unfortunately, Walt is now a silent key. Okay, so it was very apparent that if I wanted to keep into this multi game, that doing it from the little 2-acre lot in Crownsville was going to require a great deal of luck to win any contests. So my wife and I decided that it was time to move on, and she wanted a nicer house, and I didn't really care a lot about that, but I wanted a lot of towers. So we found a very nice piece of land on what was then quite a rural area west of Baltimore, Maryland, and I applied for a building permit. And I immediately got this letter back from the building department, said that this is not allowed. We cannot issue you a permit for 7 towers in Howard County. And I thought, wow, I've already owned this piece of land. I've already got a contract to build a house, and now I can't have towers. But turns out the county executive in Howard County was a ham. And I knew him. And I called him on the phone and I told him what had happened. And he said, well, I can't tell you what I can do or whether I can be successful. But he said, let me work on it. And a month later, this building permit arrived in the mail. And we got started putting the towers up. I never asked him what he did. But whatever he did prevailed over his building inspection department. But that wasn't the end. One of my neighbors, who still lives here, wasn't so happy about what he saw. And the newspaper wrote this article. It was actually a very even-handed article. They interviewed the complainant and they interviewed me. And this is the tower that we will talk about in the next couple of slides. The one that met its end a couple of days after Tim's last visit. So this is what contest stations look like in 1995. Computers are getting on the scene. That's a TS-950 on the left and a TS-850 on the right. This is the 15-meter station, two radios, 1 amplifier. And this is what my station looked like then. And you can, pretty much the same as it is today. The antennas are a lot different. That red and white tower on the left came from the naval radio station NSS near Annapolis, Maryland. And the tower nearest the house on the right, the big tall one, is the 200-foot tower that fell down a couple of days after Tim's visit. And the tower on the left, the 40-meter tower, got twisted by that tornado, but it did not fail. And it's been repaired. So my mentor, W4BVV, says, you know, you do a lot better with some receiving antennas. So a piece of land near my home was sold, and the new buyer was another engineer who worked at the same agency where I worked. And I talked to him about it, and I told him about this receiving antennas I wanted to put up. And he said, are those beverage antennas you want to put up? And I kind of stood back and I said, absolutely, that's what I want to do. And he said, well, you're very free to use 4 acres of my land, but you can only use it during the fall and the winter. And I need to have you restore the land to the way it was in April. And I said, sure, I'll do that. So we put up this big array, and Beverages are fantastic receiving antennas, and this array worked really well and improved our performance on especially 160 and 80. Well, K3RA was an operator that year on 20, and he thought, well, one of the problems with the 2 radio setup that I had right through 1995 was that the second radio really couldn't do much of anything while the other radio was transmitting. You could go around and knock off multipliers that were spotted on the 2-meter FM spotting network, but you couldn't do much more than that because you couldn't hear. And he took one of the cables from one of these from the Northeast Beverage and connected it to the other receiver on 20 meters. And son of a gun, he could hear quite well on 20 meters when we were transmitting. So that became a theme of improvement in the station, was taking advantage of his discovery and getting to be able to do that on every band. Probably the most difficult thing to ever achieve in HF contesting is to win 4 DX contests in the same season. 4 big ones: CQ Worldwide, Sideband, CW, ARRL, CW, and Sideband. And you pick your category, single up or single band or whatever. Trying to achieve this in one season is extremely difficult. It requires a good deal of luck. Propagation has to be in your favor. And N2AA at K2GL station was the first one to do this in 1982. I'm not sure if anyone did this in a category other than multi-multi. N2AA was the first to do it. There was a period of time during the 80s when some of the big stations were no longer as competitive as they once were, and we were able to do that in 4 different seasons during the 80s and 90s. And then our friend K3LR showed up and showed us how to do it again. And Tim has won this extremely difficult category of competition on 3 different seasons. So those are the QSL cards from the 3 stations that have achieved this in the multi-multi category. This is a look at my station pretty much as it looks today, the only difference being that those old CRT monitors are gone, but the rest of the station is pretty much the same. The room is fairly large, and we have 2 radios on each band. Typically today, FTDX 5000s and K3s. 2013 comes along, and by this time, W8JI and W5ZN and others have been talking about these 8-circle arrays. And I looked at that 4 acres and decided, you know, I could probably do that too. So we put up this new array of 160 meter and 80 meter 8 circles in that 4 acre field that my neighbor loans me every year. And also left 3 beverages in place to the northeast, west, and south. And this is a look from the top of the 200-foot 40-meter tower. Ignore the tower you see in the photograph. What you're seeing back there was snow on the ground, so you can kind of see 1,000 feet away where all those receiving antennas are out in that field. And the tall antennas are 24-foot umbrella verticals for the 8-circle array.
Well, Frank, we got 5 minutes.
Okay, and I'm just about done. Thank you, John. So Tim goes home after photographing my station, Tim and W8 WWV with their quadcopter. A couple days later, I go off to a dental appointment. And as on the way home, I'm listening to the radio, and it's this tornado warning, not watch, warning. And 5 minutes after I got home, the tornado hit. Phyllis and I got into the center of our house. I didn't hear anything happen. A few minutes later, the tornado was going, and I went out and looked, and this is what I saw. And I always thought that if I lost the tower, the four of the towers are 200 feet high, and they're only 135 feet apart. And I always thought that if one of these towers fell, that everything would come down like dominoes. But thankfully, this thing folded and twisted in just the right way that it missed every guy wire. Well, back to the building permit department, and there's the building permit for the replacement tower. And 6 weeks later, it's finished. And there it is, August 2016. This tower was given to me by N3RR. Thank you very much, Bill. And this is the last slide. These are just some of my mentors, and I'll just mention a little bit about them. W1AWE was that ham that answered, the first one to answer that Popular Electronics 1958 request for help. And he gave me that 2-foot-high stack of QSTs, and I absorbed every single word in every one of those magazines. W1DKR, Bill Grella, came to our 1960 field day, and we had no idea what we were doing. And Bill rescued us, and we had a good field day, not especially successful, but without Bill, it would have been a disaster. But that helped us very much to prepare for the next one. W1GS, who at the time was K1HZN, is a lifelong friend of mine. I first met him at that field day in 1959, where I was just an observer. And he's been, he was especially a mentor in those early years when I knew nothing about contesting. And we contested together at the Providence Radio Association Clubhouse. W1BIL, Gene Petit, was a DXer. He operated contests a little bit, but he wasn't a contester, but he was a very serious DXer. And he was very technically oriented, and he got me my first job at the TV station in town. And I worked there during my college years. W3GN on the right, longtime PVRC member. He's now a silent key. When I took my first job as a second lieutenant, it turned out he was my boss. Totally accidental. He was on vacation when I interviewed for the job. He had never recognized my name. But then when he came back to work, one of my colleagues at work mentioned to him that, you know, this guy that just came in, this lieutenant, he's a ham. And soon enough, Larry came down and talked to me, and it turned out we knew each other very well from CD parties and sweepstakes. W3GRF is a legend in PVRC, one of the founding members, and a legend in the contesting world, a member of the CQ Contest Hall of Fame. W4BVV worked with me, a colleague, in my first job, and he was my mentor in DX contesting. He was also the fellow that convinced me that I should try to beat W3GRF in the ARRL-CW DX contest in 1971. I wasn't so sure about that, but he was sure that I could win, and I did. W3MCG was another PVRC member. W3FA was his call at that time. And he lived close to me, and we spent a great deal of time together. And of course, everybody knows W3ZZ. I don't need to say another word about that. And that's the end, John. So over to you. Back to Ireland.
All right, very good. We thought let me get this tilted a little bit. We thought it might be kind of fun here in the last few minutes, Frank, to have one of your former operators kind of moderate the questions. And it's frankly a huge honor for me, as much as guys like W1AWE and W1GS and the like were mentors to you, I don't think I'd be on this phone call if it were not for you, Frank. And for those of you who don't know, Frank and I spent a lot of time at 100 feet, probably more time at 100 feet than on the ground in some of the early building days of his station. So Frank, thanks for that. One other note I would say is that when I came down there to operate your first multi-multi, something I've never told you, but K3LR actually dispatched me to investigate the station and report back to him. So there was a little bit behind the scenes there that you never knew about. Anyway, let's do some questions here. Maybe start with Marty, if you could fire one away.
Sure. Let's see what we have here. One person asked, Frank, how much legacy gear do you still have, and do you use any legacy gear on the air?
Yeah, hi, Marty, and thanks for that question. Well, I still use legacy gear, but not in contests, of course, with one exception. Those W8 FYO paddles are still used, including the one that I bought when I was 15 years old. But I still have legacy gear. I have a 75A4, but not the one that I owned back then, but it is very much the same. And I have a Viking Valiant, which is identical to, but not the same as the one we had at my college station. And I just purchased an HQ 129X, which is identical to, but not the same one, as one of the ones owned by my mentor. And I still have an Amico AC1, which is identical to the one that I built as an 11-year-old. So I don't compete with those, Marty, but they're still very much there.
That's great. How about you, Bill? What do you have first up?
Sure. So, Frank, if something happened, other than your tower falling over, what would you, and you had to rebuild today, what would you do differently?
Oh, I don't think I would do a lot differently. This station was built very much like Tim's station to be a multi-multi station. So you get there in kind of a roundabout way. And of course, the game is changing a little bit now with remote operation. So I think if you were to build a station from scratch today in 2020, you might build it in Maine and remote it. But that, as Tim and I have discussed, that has its own challenges that have to be dealt with successfully. But I carefully selected the location to be somewhere where people would be willing to commute to, and it had to be something I could afford at the time, so that was the right choice. Land has gotten insanely ridiculous high price here now. You couldn't afford to do what I've done here now without spending millions. But no, I don't think I would do a lot different. And the evolution and the continuous improvement has been a great deal of fun. Continuous improvement not only for the station equipment, but also the operating team. And that never ends. My very good friend K3LR makes this fun, because without another serious competitor, this wouldn't be anywhere near as much fun. And both of us are finding ways to advance the state of the game. And it makes it a great deal of fun. But I wouldn't change anything.
Very good, thank you.
And I can tell you that Frank's enthusiasm today is no different than when we first met back in the 70s. I remember contacting Frank and driving to his house for the first time, and I went around the curve and I saw that big 40-meter beam up in the sky, and I said, this guy talks to aliens. It was just the most amazing thing for a young college kid to see. And it was really the beginning of something marvelous. Marty, you got a question?
Sure. Somebody asked, how does someone get involved with a first-class multi-multi like Frank's?
Yeah, that's a really good question. I guess the best I can do is tell you how we do it, and I think it's probably different depending upon the level of competitiveness of the multi-multi, the maturity of the crew that's already there, and probably other factors too. in the case of my station, you get to come here by invitation. And all of the members of the team are always looking for the next generation of people who can add to the team. About the only exception to that is occasionally we'll have a visitor from overseas who might inquire as to whether they can join the team, and myself and some of the other team members will make a decision as to whether we extend the invitation or not. So the best way to get invited to a competitive multi-multi is to perform well in contesting, and the invitation will come.
That's great. Bill, do you have a question for Frank?
Yes, I do. And this is one that a few of us are wondering, I think, here. So what sort of wife acceptance factor issues have you had to deal with over the years, and how did you overcome them?
I'm sorry, I missed the part of what sort of issues? I'm sorry.
Wife acceptance issues, XYL approvals.
Oh boy, Phyllis is very gracious. She was enthusiastic when we built this home. She knew why I wanted to come here, and she knew why she wanted to come here. She got a nice home, and I got the opportunity to build these 7 gigantic towers. And I don't contest every weekend. Neither does Tim, I will notice. So there's balance in our lives, and of course there's always stress. In any honest relationship, there's always stress. But she lets me do my thing, and she has a good time too, and that works.
Yep, and I saw that firsthand, and that's absolutely the case. Hey, Marty, what do you have?
Yeah, Jose CT1BOH says, great performance, Frank. Why W3LPL and K3LR are not yet on the real-time scoreboards?
Well, that's a good question. I don't have any intent to do it. We operate contests in a particular way, and maybe I'm just old, but I don't have any intent to change. And only K3LR can answer his side of that.
I think it might be the same answer. Hey, Bill, what do you have for us?
So how do you ensure your towers in gear?
Well, that's a good question, right? Because that tower fell down. My insurance company is USAA. They've been my insurance company for 50 years. And that tower fell down, and there was no dispute. That tower, my towers are just accessory structures to my primary residence. And when the tower fell down, there was a 5-minute negotiation as to what I would accept, and they made an offer, and I said that's fair, and I signed it, and off we went.
Okay, do we have we got time here for one more question? Either of you have one for Frank?
Sure. One AC6ZM asked, what diagnostic equipment should I invest in for my contest station? I assume he's talking about test equipment.
Test equipment. Well, yeah, that's a really good question. And I don't think anybody has ever asked me that question before. That's a very good one. There's something in engineering called proof of performance. And I was in the broadcast industry for a little while. And we used to do that pretty regularly. We earned money off of our facilities, and the FCC also required that we do that. So I was familiar with it, and you have to be ahead of whatever problems are going to occur in the station. So we have, or I should say I have, the other members of the team don't participate in that, but I keep records on my computer of things like the VSWR curves on all my antennas, down below, photographic images of time domain reflectometer returns from all the feed lines, and a whole variety of things like that. And during the course of a year, I go through all of those things for everything in the station that's critical to its performance. And you always find something that you didn't anticipate. Maybe some water has gotten into a connector, and the time domain reflectometer will indicate that, and on and on. So it's kind of one aspect of the maintenance of the station that you just keep ahead of. And my favorite time domain reflectometer now is a handheld one, but there's a whole variety of those. The first one I used was an old late 1960s era rack mount Hewlett Packard one. But my favorite instrument is the time domain reflectometer because it can detect more subtle problems. And today's handheld mostly is what I use. VSWR and impedance measuring devices are also indispensable in my station. So those are the primary things I use. Antennas are the big thing that if something goes wrong, it's very difficult to repair it without some advance notice. So I try to keep ahead of all of that stuff. Most of the stuff in the shack is easier. Okay, so I guess that's probably the last question. Thanks, everybody.
That's it, Frank. Fantastic job. And I think we can all agree that based on your presentation today, you're off to a good start. So
thank you, John.
And he's
thank
just
you
25.
all. And let me turn it to Tim. Thanks for the privilege of doing this, Timmy. Back to you.
Yeah, great. Thanks, John. And thank you again, Frank. And thanks for your friendship over the years. I wouldn't be, this station wouldn't be here if it wasn't for your inspiration and the mentoring and the guidance and your willingness to answer questions over and over and over throughout the years. And I really appreciate your dedication to the Contest University project. It is something that you have embraced with vigor. And I appreciate that. And the thousands of students that have watched you today and have watched you over the years, it's just been a tremendous give back to this hobby that we love so much. So thank you again, Frank.
Thanks, Tim. It's been my pleasure.
Okay, and Marty and Bill, the moderation job will be a little easier as we go through the Hall of Fame ceremony, but please stick around to make sure everything goes well on chat. Just a housekeeping reminder that we will be giving away an IC 7610 at the end of the Hall of Fame ceremony. You have to live in the United States, in the 50 United States, and you have to be on Zoom at the end of the Hall of Fame ceremony. So those are the rules for that. And let's see, Dave, K3ZJ, are you on? There you are. Go ahead and bring your video up, and the floor is yours. Dave, K3ZJ. And Dave, you're going to need to unmute as well.
Okay, do you hear me now?
Yes.
Okay, now if I can get the, I had my video on and it disappeared here.
Yeah, you did a screen share. Stop.
Let's see.
You need to stop the screen share down on the bottom.
Okay. How's that?
There we go.
Okay, there we go. Thank you. I hope all of our presenters are on, but somebody who's organized this would know, I guess. Thank you for having us do this, Tim. And thanks for all the presenters today. It's been a lot of great information given out. I do want to mention that there's been so many good ideas that all of you can implement them in just 2 weeks in the CQ Worldwide WPX CW contest. And this is a very rare year for those of you in the United States because the WPX CW is not on Memorial Day weekend, but rather the weekend after. So you can enjoy some family time and put into action some of the ideas you've heard today. This year, CQ Magazine is celebrating its 75th year. It began publishing after World War II, and then in 1948, it started the CQ Worldwide Contest. And the magazine has had contesting at its core since then. The CQ Contest Hall of Fame was established by CQ Magazine in 1986 to recognize those participants who contribute to contesting above and beyond. Those elected for this honor have contributed to contesting in ways, in addition to being active and operating in contests, it's about earning the respect of their fellow contesters and giving back to the sport. Past inductees have written software and created websites for contesting purposes. They brought new people into the hobby and mentored contesters from within the new hobbyists. They've written articles and made presentations sharing their experience and knowledge. They volunteered to do the hard and thankless tasks such as organize and judge competitive entries. They've acted in leadership roles in clubs and organizations. In short, they've made things happen, and we as contesters have all benefited from their contributions. This year, we are honored to induct 3 new members into the Contest Hall of Fame. The first is Jeff Howard, W0CG PJ2DX, but I think most contesters know him as the ham behind Papa Japan 2 Tango. And here to introduce Jeff is CQDX Hall of Famer Jerry WB9Z. Jerry?
Is a moderator going to bring me up?
There you go. Jerry's here somewhere.
Okay, I'm in there. Hey, first of all, I just want to say what a great contest university. Thanks to Tim and Terry and all of the professors and the moderators, Ray Novak, for everything he does. So we had a great time. I can safely say that I have attended every one of these, all 14 of them. So I first met our new Contest Hall of Fame member, Jeff Howard, W0CG, also known as PJ2DX, on the island of Curacao back in 2002. Right away, I could see why the Caribbean Contesting Consortium was so successful. More than a little, it was all due to Jeff's skill and endless energy. He could troubleshoot and fix an amplifier. He could sit and run a CW contest at 200 plus contacts an hour and follow an NFL football game on TV at the same time. Then he'd be out the back door to unclog and work on the septic tank. Soon after that, you'd see him climbing up the rock face behind the house to fix a beverage. After that, you'd catch him working on the hot water heater, and after that, you'd see him talking to a newly arrived operator, making him feel welcome and comfortable. He seemed to be able to do everything and be everywhere, keep a smile on his face, find a way to get along with everyone, solve problems on the fly, and keep everything happening smoothly. Jeff could also climb towers, doing the maintenance, and including the tedious job of scraping and painting. He was one of the hardest working men I have ever met. Jeff is an excellent ambassador. He's been a lifetime legal resident, he became a lifetime legal resident of Curacao back in 2003, and he actively hosts island operators and their families at the QTH, offering them contesting opportunities, and he has earned the respect and affection of many of the local islanders in the nearby village. In the late 1990s, Jeff had a clear vision of how to structure a contest club based in the Caribbean, including a novel business model, operating details, the politics involved, and the keys to the long-term stability. He executed on that vision, and 20 years later, PJ2T is still going strong. In real life, Jeff is an experienced instrument flight instructor and scuba diver. He served in the Air Force for 30 years. He worked on projects ranging from the Arctic to the jungles of Central America, and he retired as a colonel. He's also a licensed professional engineer. He holds a PhD, and he's a full professor still teaching part-time in his retirement. Imagine that. He has a lot of accomplishments under his belt and a thick wad of academic credentials. Yet, he is the last person who would tell you that. He prefers to be the dirty, sweaty guy that works in the background to keep everything in order at signal point. He's quiet and humble and always focused on calling out everyone else's accomplishments and not his own. All of us have logged many, many PJ2T contacts over these last 20 years, and they have made some 2 million contacts. Yes, 2 million contacts. And from that shack on Curacao, I am extremely glad that the contest community has seen fit to recognize and thank Jeff for all of that. It is my honor to introduce my good friend, Dr. Jeff Howard, W0CG, and PJ2DX.
Thanks, Jerry. And Dave, you need to start up my video. And there we go. And, you know, it's really, really dangerous to try and tell a joke in an online format. You can't read the room. You can't feel the mood. It's tough to get the timing right. In fact, I'll show you why you shouldn't try to be funny online. We all know November Victor 9 Lima, Val. Val's running a winter contest, and Jerry's out at a customer site, and she texts Jerry in a panic, "My windows are frozen." Oh, there she is. "Yeah, honey, my windows are frozen." And Jerry texts back, he says, "Pour warm water over them and tap the edges gently with a hammer." And a minute goes by and Val texts back and she says, "Computer's really messed up now." Or N50T explains that there are 3 kinds of people in the world: those who can count and those who can't. Or K3LR asks, why is abbreviation such a long word? So see, there's your object lesson in bad online humor. And where is TV Bob when I need him? My name is on this recognition, but the real credit belongs to others. John Thompson, W1BIH, PJ9JT. In 1970, he established the house that PJ2T now occupies. He saw the tremendous propagation conditions from there and had a house built solely for contesting. We signed Papa John to Thompson for him. So I stand on his shoulders. I took over that house from John in the year 2000, and since then our club has sustained operations for 20 years. Last November, we logged the 1 millionth logbook of the world contest QSO, and I'm sure we have another million or so outside of the contest. We've won all the majors at least once, some of them year after year, and a special thank you to Trey and Dave for standing down HC8N so that we'd finally have a chance at a plaque. Appreciate that. Everything we've accomplished owes to the 61 present and past members of the CCT club group. They have dug dirt for cables and radials and shed blood in the cactus patches and endured the heat and risked their lives climbing towers, beaten down the mosquitoes, written checks, donated equipment, and maybe worst of all, missed a lot of Thanksgiving holidays with their families. I stand on their shoulders. It's dangerous to name anyone without naming everyone, but I have to try. I'll pick on Jerry since he's here. Jerry was very active with us for years, and we owe him a huge thanks for all of his generosity then. And then he discovered the expeditions, and we haven't seen so much of him since. But I tell you, every time I even breathe a hint that we may need something for the item, about 3 days later, there's a loud thud outside my front door. It's a FedEx box from Jerry, and he won't take a dime. I also thank the 2 longest standing members of this group that we started, Keith, Whiskey Alpha 9 Sierra, who's been with me continuously since 1998, and Bill Smith, W9 Victor Alpha since 99. You all know Bill from W9 DXCC. Also, I want to read into the record a huge thanks to the guys that helped me start this when I had the insane vision of a contest club overseas in 99 and 2000. Doug K4 Lima Tango, who wrote the very first PJ2T dues check, Jim W0 November Bravo, Noel W9 Echo Fox Lima Silent Key, Bob N8NR, and Steve N8BJQ. Together, we got this thing off the ground. No one person could have done it. What we've done is fairly unique. We've sustained a large DX station for 20 years, and none of this is easy. And I'll say no more about that, except to say that you probably wouldn't believe the challenges that come up and the obstacles that need to be overcome so that at 0-100Z we can get on and start giving all those 599s. I could tell you horror stories for days. You know, in our lives, we're all part of overlapping meshes of professional affiliations, fraternal affiliations, families, employer organizations, religious groups, educational disciplines. We are all concurrently part of many different tribes. But since I was 13, it's all of you I've respected most. All of you who've mattered more to me than any other group of peers, the giants of our hobby who have seemed nearly godlike to me for decades. This radio community, and specifically the contesters, are the kindest, smartest, even K1AR, most generous-hearted and generous-spirited, fun people I've ever known. There's no other group of peers I respect more. There's no other group of peers from whom I'd be, more honored to receive this recognition. And I'm not embarrassed to tell you that when word of this came down, the tears and the lump in my throat came up, and I had trouble talking for a few minutes. To see my call sign on this list of people that I respect so highly is overwhelming. The cliche is, I can die now, but in this case, I really feel that this means that much to me. Most of us, we start in this game fascinated with the technology. And then as the years pass by, we evolve to where our next love is competition and pursuit of excellence. And then eventually we mature into realization that we are here for the people, for the love of being part of this world-spanning community of friends and colleagues, wonderful people with this great shared passion. I love you all, and it's okay nowadays for men to say that. I would be honored to be counted as one of your friends. I appreciate this enormously. Thank you. 7388 and 599 from PJ2T. Dave, over to you.
Thank you, Jeff. Very moving comments. Our second honoree became a silent key in 2012. He was a personal friend of mine, and in fact, I even met my future wife at a New Year's Eve party at his home. Gene Zimmerman, W3ZZ, was well known in both VHF and HF contesting circles. To speak about Gene's accomplishments this evening is Tom Valenti, K3AJ. Tom?
Thank you, Dave. It's an honor to speak on behalf of Gene's many friends in the Potomac Valley Radio Club, the Grid Pirates, and in the larger amateur radio community. Gene was a giant in our hobby, and specifically in the realm of contesting. We are grateful for the well-deserved honor of Gene's induction into the CQ Contest Hall of Fame. Gene was a passionate operator and organizer of many competitive multi contest entries at some legendary stations. Gene was active on every contest band from 160 meters through 10 gigahertz. Gene's leadership of the W4 BVV CQ Worldwide and ARL DX contest multi teams back in the 60s and 70s resulted in 4 USA winning scores. Many will remember his booming nasal voice penetrating the pileups. In the early 1990s, Gene played a leadership role in the creation of a new competitive multi-operator VHF contest team, the Delmarva VHF and Microwave Society, also known as the Grid Pirates Contest Group, operating as K8GP. Gene's many off-air contributions to contesting included his service as a member of the ARRL Contest Advisory Committee, a member of the CQ Contest Advisory Committee, director of the CQ Worldwide VHF contest, editor of QSD's The World Above 50 Megahertz column, and the editor of CQ Contest magazine VHF contesting column. As for many of us, Gene's interest in radio began with shortwave listening. Gene was first licensed in 1956 as KN1ANV at the age of 16. Gene became interested in weak signal VHF early in his ham career via his friendship with Paul, W1HAD. Gene said that openings on VHF are few and far between and extremely exciting when they happen. He said in an interview for QST, "I guess I don't like things that are easy, so I chose to do VHF." After he moved to the Washington, D.C. area, he became involved in HF contesting in a serious way, particularly with PVRC legends Len Chertok, W3GRF, and Tom Peruzzi, W4BVV. Gene returned to weak signal VHF in 1981 and built a competitive VHF-UHF station with capability up through 10 gigahertz. Gene earned VUCC on 6 bands from 50 megahertz through 1296, as well as DXCC, worked all states and worked all continents on 6 meters. In VHF and up contests, Gene scored in the top 10 nationally several times from his home station in a densely crowded suburban neighborhood, and won the multi-unlimited category 4 times with the Grid Pirates. Gene was a member of the Delmarva VHF and Microwave Society, the Grid Pirates contest group. He was a past president of the Potomac Valley Radio Club and an honorary member of the Connecticut Wireless Association. He was a life member of ARRL. Less known to many of you may be Gene's career outside of amateur radio. Gene entered Yale University as a freshman at age 16, and following his graduation from Yale, earned his PhD in microbiology from the University of Maryland in 1968. He began his professional career at the National Institutes of Health, NIH, where he developed his interest in virology research. In 1976, he joined the NIH Grants Associate Program and later became an NIH Scientific Review Administrator, where he evaluated research proposals to provide funds for research in immunology. To those who knew him, Gene was also a legendary storyteller and commentator on all things relating to amateur radio, contesting, and nearly anything else. CQ Contest Hall of Fame member Fred Lawn, K3ZO, tells us, Gene developed a reputation as a great talker, but he was also a careful and sympathetic listener. He had a special quality of treating everyone he met as somebody who was worth knowing and deserving of respect, no matter their station in life. And he made it a point to discuss something that his interlocutors were really interested in. In that way, he endeared himself to everybody with whom he came in contact. Even today in PVRC meetings all around the DC Baltimore metro area, there is no former PVRCer who is mentioned in conversation anywhere near as often as Gene. Another CQ Contest Hall of Fame member and QST editor author Ward, N0AX, offered this observation in Gene's ARRL obituary. Amateur radio has had its share of characters, but none were more colorful or more widely respected than Dr. Gene Zimmerman, W3ZZ, a man who in one breath could identify the source of the world's greatest hot dogs, explain once-in-a-lifetime propagation, and recount the history of contesting and contesters. We will all miss Gene's presence greatly, and it is a sad day for us all to learn of his passing. I can only add that today, it is a happy day to have Gene Zimmerman, W3ZZ, recognized by his peers with membership in the CQ Contest Hall of Fame. Thank you, in 73.
Thank you, Tom. Very well put. Our third honoree this evening is Bill Myers, K1GQ. And to introduce Bill, here's Bob, WA1Z.
Thank you very much, Dave. Good day, everyone. Congratulations, Jeff, and it's wonderful to see Gene recognized for the tremendous contributions he's given to the hobby over the years. I'm incredibly honored to be here tonight and tell you a little bit about my friend, Bill Myers, K1GQ. One of my favorite stories about Bill comes from Bud, W3RU, who is one of Bill's oldest friends in the hobby. In early 1975, Bill was living in Hawaii, and he invited Bud to visit him after a business trip Bud was on in San Diego. Now, this coincided with the ARRL DXCW contest, which back in those days, as Frank had mentioned earlier, was held over 2 weekends. Bill insisted that Bud come out and operate the second weekend of the contest from Bill's QTH, which was no more than a quarter-acre parcel of land in downtown Kahului on the island of Maui. Now, this was a time when Bill had a fantastic run from this particular QTH, where he finished third, second, and first in the world in CQ Worldwide and ARL DX contests, both modes, despite the fact that he claims he only does code. It was a phenomenal operating achievement from the middle of the Pacific, and Bill repeated it several times over about a 4 or 5 year period in the early 70s. Now, Bill had operated the first weekend of that contest, and as you might expect, was on his way to doing quite well in it. But there was his good friend Bud from his early East Coast days, who had never had a chance to operate on the DX side of a pileup before. Bud says he didn't fully appreciate until the results came out later that year that his visit had likely cost Bill another first place finish. But that's the kind of generosity that defines Bill. He's the perfect host. He's always been a great teammate, which I know firsthand. And he's always willing to give up the chair for someone else. Bill is an accomplished contester in his own right, just for the example I just gave of his single op career, but he's also been part of some very successful multi-ops, even that K1AR guy when he had his K1EA, his multi-single operations at K1EA over the years. And the tremendous run that Matt KC1XX had with multi entries in the late 90s and early 2000s. Bill was a key operator as part of those operations over the years and was a major technical contributor as Matt grew his station. And in over his 60 years in ham radio, Bill has been a constant presence giving back to the hobby, to the community at large in some way. Whether it was consulting with Cushcraft on the design of the highly successful Skywalker Yagi antenna series, to writing articles for the NCJ and the YCCC newsletter Scuttlebutt, which he served as editor for 3 years, on topics ranging from station design and maintenance to technical reviews, to serving as co-editor with Clark Green, K1JX, for Jim Lawson's book Yagi Antenna Design, or devoting much of his time in retirement to the development of Skookum Logger, a top-notch contest logging program for Macintosh computers, something he also gives away for free. And being a critical volunteer at WRTC here in New England a few years ago, where he assisted in the design of the antenna system and wrote a ton of documentation for the site and beam teams, producing somewhere on the order of nearly 6 dozen unique documents to help keep all the little details straight. Bill is a self-effacing guy, often hidden in the back rooms of projects, but quietly working away, always getting things done, and many times without much fanfare. So as you might have taken note, Bill is quite innovative, and he's always been known for doing cutting-edge things that the multi-op stations has been associated with, like Matt's, where I've gotten to know him, as well as his own stations. For example, when he returned to the East Coast in the late 70s, he built a contest station in southern New Hampshire, and this was where he integrated a process control computer into his station to automate antenna switching. And over time, he acquired a set of SB220 amplifiers and dedicated one to each band. So they had rapid band switching in a contest. Now, this is the kind of automation that we all kind of take for granted today. There are a lot of products on the market that do this. You can do it at a very modest station for pretty low cost these days. But this was a pretty cool thing to be doing at the time. And not too many other folks were doing stuff like that. Bill then opened that station to numerous young guest operators to be able to experience those pretty cool things he was doing, including some CTU panelists you've seen today, like John K1AR and Doug K1DG. Many of these young contesters experienced winning the US as single operators or on multi-op teams from Bill's station, in some cases for the very first time. So that's what makes Bill that special kind of person worthy of this honor. Not only is he an accomplished contester in his own right, but he has been an innovator, a contributor, and a tremendous role model and mentor to many, including me. So it is my honor to introduce to you my friend Bill Myers, K1GQ, tonight's final inductee into the CQ Contest Hall of Fame. Bill, from the bottom of my heart, congratulations, and I hand the virtual mic over to you.
Thank you, Bob. Hello, everyone. Frankly, I'm confused and bemused by this award. I never thought to seek it, nor do I really understand what special things I did to deserve it. Whatever effect I've had on others and whatever contributions I've made have been unpremeditated. I've just been doing what felt to be fun and useful. I have a webpage. There's a biography, an autobiography on that webpage. And I'm going to read it all. Quote, K1GQ is my amateur radio call sign. The hobby has connected me with many remarkable people that I would otherwise would never have met. They have enriched my life. They know who they are and who I am. End quote. You may assume safely that I don't like talking about myself. Thanks to all those nameless, remarkable people, including many present here today. Thanks also to the Yankee Clipper Contest Club. And thanks to the Hermitude Busters, in spite of their accomplishment. If you're still here, you are probably hoping to win the radio. K1GQ, over and out.
Thank you, Bill, and welcome to the CQ Contest Hall of Fame. You, Jeff, and Gene are now certified members, and assuming that the Postal Service is still operating next month, you will receive a plaque in the mail. We hope that it has a honored place on your wall. I was asked to make some remarks for the duration of 2 or 3 hours so that people would drop off and increase the advantages of others of winning the new ICOM transceiver. But I've decided that my voice won't take it. So in closing, I want to congratulate the new honorees. And I also want to remind everyone listening that this is a worldwide contest Hall of Fame. Everyone worldwide should think about who they might nominate, and nominations go to CQ Magazine every January 1st. The December or January copies of the magazine have the full information, or you can always email someone like me and I'll send it to you. It's usually also on CQ Contest and some other reflectors. Every year there are more nominees that can be elected, and I can tell you from having reviewed these that almost every year there are 2 or 3 others that certainly deserve being there. Nominations are not carried over, so it's important to know that if someone you nominated doesn't make it 1 year, do send it in another year, add a little bit more or whatever to it. But sometimes it's just a case of there's 7 or 8 really good nominees, and the contest directors vote and decisions have to be made. We try to keep it to 2. This is the 2nd year in a row that we've had 3. So please start thinking about that. Good evening.
Thank you, Dave. Really appreciate your contribution to do the Hall of Fame and to do it virtually this year, and also for the way you do your column in CQ Magazine covering our radio sport hobby. It's very enlightening, and I know that's a lot of work for you, and also all your work with the ARRL. And on behalf of everybody that has come in contact with you, I thank you. So we've reached the end, and so it's time to see who is going to have a new ICOM IC7610. And I can tell you that that radio is currently out of stock, so it's going to take a few weeks. And the winner, I would ask that the winner email with me so that you can, so we can line things up. You have to be on Zoom and you've got to be here now. And
Hey, Tim.
Yes, Ray.
Just one thing to add. It's actually shipping today to you to send to the customer, to the winner.
Great. That is super. So we'll have the radio here in short order. And thank you, Ray, for your contribution and everything you do for Contest University.
It's an honor to be associated with this wonderful group of people, and to have the opportunity to share with everybody how wonderful of a hobby we have, and to see how people that we always see at the top of the list are willing to share their secrets with everybody. So thank you, everybody who made this happen.
And I hope tomorrow, or I'm sorry, on Saturday, to hear lots of these participants and our professors on the air for the Hamvention QSO party. That's hvqp.org. Thanks again to Terry, Kate MNJ, who does a lot of the heavy lifting here. Ray, to you, to all the professors that presented today, and all the professors that present at contest universities around the world. Also to the moderators today, you did a great job. Marty and Bill were the last two here, but we also had K5TR and N5KO and KM3T and W2NAF and K1AR and N3RA. So thanks to all of you. And thanks to the attendees that sat through this, and those of you that will watch the recordings later. I hope you get something out of this. I hope it enriches your ham radio fun. And I do hope you share it. Share it in your clubs, share it with your friends, and please pass on all of the good things that were presented here today. So the way this is going to work, Corey, W3CDG, hopefully you've got your camera on, and I'll get to see you here as well. I'm going to change the way I'm looking. And Corey, is your audio on?
It is now.
Okay. Great. So Corey has figured out a way to take all these call signs, and he's going to actually pick. Corey is over in Atwater, Ohio. I'm here in Western Pennsylvania. And so you need, Corey, the way you want this done is they need to raise their hand. Is that correct?
So what basically we've done is we've already taken all the registrations. We've put all the data together, took out dupes, ran it against QRZ, got your state information, and we've randomly selected somebody out of that list. So if you're ready, Tim, we'll go for it.
All right, let's go.
All right, now, John, I've been to enough contest universities and I know how this drawing goes. So we're gonna start with a kilo. And so all you whiskeys and Novembers are probably shaking your heads now. But now do we have a letter or a number? So the next one is Charlie. So it's Kilo Charlie. So, all right, we got a couple more people, and hopefully we have a Kilo Charlie 0. And the winner will be Kilo Charlie 0 Oscar, KC0O. And name is Marlon. Marlon, are you here today? Raise your hand in chat. I see a bunch of people raising their hands.
Yeah, I wouldn't drop offline yet, because if Marlon's not here, we're gonna keep drawing.
I see a Marlon Brown with his hand raised.
Okay,
so, he is here.
All right,
congratulations, Marlon.
All right, well, Marlon, congratulations to you. We'll have a new radio here shortly. Thanks again to ICOM and 73 from K3LR and Contest University. We'll see you next year.
Hi, everybody. Thanks, Ray.
See you next year.
Next year in Xenia.
73, everyone. Thank you guys for coming. It was a good day.
Thank you, Corey.
Thanks to Tim and Corey for all your hard work on this. It was really fantastic.
Thank you, everybody. Great work.
Thanks, Tim. 73.
Thank you, Corey.
No problem. And I'll get Marlon's email to you here in a little bit. And Marlon, if you want, you can just email us at, you know, what you want to do, K3LR, Tim?
Yeah.
So Marlon, just email Tim at k3lr@k3lr.com. And I'll get him your email so you guys will be good. Thank you guys.
Congrats and thank you.
Hey, anybody up for a Zoom call now?
You
At
busted.
AR, just can't get enough.
Corey, you busted the call sign. It's K1AR is where the radio goes. John, I get my kickback, right?
Yeah, yeah, absolutely. Checks in the mail.
We have been streaming live to YouTube for 9 hours, 55 minutes, and 30 seconds.
Wow.
It feels like it too.
Hey, Corey, thanks for saving my butt when my screen sharing blew up.
Very
That's
smooth.
all right. It wasn't me. I think somebody else got that one.
It was Bill. Yeah.
Bill.
No worries. Anytime.
KN8 uses I got it wrong. The radio actually goes to L1AR. So
Yeah, L1AR.
Yeah.
I don't know what the top out was. I'll do the reports, but we had most of the day we had about 2,200 on, and we were pulling about 300 to 350 on YouTube the whole day. So all in all, probably about 2,500 people, guys.
And how many people signed up out of curiosity?
Total, I had 3631.
That's
Wow.
pretty good.
About
That's a pretty
1,000
good conversion.
It's amazing that many people sign up, but then they don't show up.
I
Oh, they
think that's
showed
a-
up.
They were
They
in
were
and
just-
out.
They were in and out. Yeah,
Not
because
only that, some of them were probably dupes trying to get the radio.
I was gonna say, actually, I think that's a pretty good from other events like this I've done. That's a pretty good. That's a 65% conversion rate or whatever. That's pretty good.
And there was about 400 on YouTube, so someone might have migrated over there.
Maybe you could have Tree or Ken go through and figure out how many unique call signs are in the list.
Well, Corey's got that technology. He's a he'll get
He's a whiz.
We've already got it running.
We need a logging program or something that does dupes.
I'll write a new script.
I was gonna. Somebody,
got a
we need a protocol name. Where is somebody sitting? Trey, where are you right now?
He's kicking back as usual with the mic muted.
You talking to me?
Yes.
We still have
So you guys
1,000.
all did a great job, great content. And like I said earlier, I'm just honored to be involved with all of you. So thank you very much for your contributions to this.
We're glad to have you here, Ray.
I feel the same way. It's so great to see all these familiar, happy faces after kind of all the stay at home and not getting out in the world. You know, it's like it's a real lift.
Hey, I don't have to worry about catching my usual Dayton cold.
Yeah.
Well, you know, the great thing for me today was that I didn't watch any CNN, no CNBC, didn't read the paper. This was just a full day of this. And talk about tuning out is great.
I hope it
Well,
wasn't
I tell
a
you what, I bet if you read the paper tomorrow, it'll say exactly the same thing
Same
as
thing
yesterday.
George, where is that photo taken?
That is from one of W5KFT's towers. That's from 150 feet at W5KFT, looking out on Lake Buchanan, Texas.
I was trying to figure out what water that was.
question. Have any of you folks been at a Zoom meeting that had 2,000 people watching simultaneously?
Yeah,
Yes,
I was on
today.
something with like 37,000 for work. So, yeah,
37,000?
it's a lot of people.
Well, whoever paid the bill for the Zoom license, thank you.
Thank you.
I guess
Yas.
it was Yasmi and ICOM. Thank you.
Yeah. We were scared when we saw the signups rolling over 3,000 that we were going to have to buy the 5,000 license. but Corey always has a plan. Corey doesn't get in too many IT jams. He doesn't get any jams at all. So,
except for the fact that right at 4 o'clock when Rob's presentation started, my cable modem said, "I'm going to reboot now."
I got that text from you. I was like, oof.
Where'd everything go?
Is it
I
was
figured
your
that the
license?
3,000 attendee limit would be just like how it is going to the grocery store these days. If you show up and the place is full, you have to wait in line behind 7 other people, you know, and then you get a chance to come in when people leave.
Well, we had the, the whole YouTube thing was a great overflow valve, right?
Mm-hmm.
Definitely. Was the license for one
fantastic.
day
I
only
even-
or a month?
I even invited a few guys to join and watch the YouTube thing, guys who just checked in during the day who were hams, but not really contesters or whatever. And so you picked up a few that way.
I had a guy that emailed and he says, I'm not a computer guy. I can't make this thing work. So I sent him the YouTube link. He says, well, I don't have any speakers.
Well, you can maybe you can hook him up with the guy who wanted to contest with the Beofang.
Right. That if there was a prize for the quote, the chat of the day, Marty captured that. Can I contest with a Beofang?
I just got a note from K1EP here. He's got a Zoom meeting tonight at 7 and another one at 8. What a lucky duck.
He was struggling this morning. He said that we should really rethink this Zoom thing. Yeah, he sent me an email. So he couldn't make it work. So I hope his other meetings work.
Yeah.
He jumped on me when my sharing thing didn't work. I got a text from him immediately. He said I should have learned how to share in kindergarten.
Just a quick question. Is your license for one day or a month or what?
No, it's for a month.
Yeah.
Okay.
Yeah. So we bought 3,000. It was 3,000 active seats during the meeting. You can have as many as you want, register, but 3,000 seats during the meeting.
Shall we do it again tomorrow?
Yeah, this is good for a month.
Yeah, we do it for the rest of the month.
Daily CTU.
And now for your daily dose of K1AR.
By the way, I think there are still 770 people looking at us just gassing.
Well, we still have an audience of 841 right now.
If you like what you see, come to the Super Suite in Dayton.
Yeah, that's right.
Bob, maybe you can give us a little manualism thing here.
That's an exclusive. There's an extra fee for that.
Hey, Corey. How do I put my call sign after my name?
Oh God. I think that was the #1 chat comment.
Yeah.
The chat was pretty orderly. I was impressed.
Yeah.
It all worked out well.
Actually, that was
a few things come on, but it was.
Yeah,
okay.
I think in total we kicked out 2 people out of 2,000, which is pretty good.
Not bad at all.
Nope.
I think the 700 people hanging on here think they get free pizza.
Yeah, that's what I was thinking. Where's the cash bar and the free pizza?
I'm missing my my yearly slice of Alfredo white pizza.
No.
Well, Tim, you got that second 7610 for the last one standing, right?
What?
Tim, do you think this was a little bit too successful, and people are going to demand the same thing next year instead of a live one?
Well, that's kind of a little worry of mine because we need a whole Zoom crew.
I was gonna say, I think you're gonna have to live stream all the sessions next year.
Well, yeah, I mean the Zoom engine it works so slick and easy, but to try and do more than one classroom be a real challenge.
Even filming with the live classroom is tough because the audio isn't as good, and usually the video isn't as good as what we can do here.
Yeah.
It's certainly I can speak from experience in saying it's a hassle to do from the hotel.
It is.
It's worth doing, but it's a pain.
It is, but somehow we got to marry these two together. I mean, the in-person thing is so good. Obviously, we want to do that, but now, I mean, there are people all over the world that got to attend a CTU that will never ever come in person. Just it won't happen.
And with the push of the button, it's all archived. All of the content will be available. Fairly good quality, fairly quickly.
Which means we can't. Which means we can't give our talks again because people have already seen them now. Everybody's going to demand new material for next year.
Well, I'm
Well, we've recorded them in the past, and they're on the YouTube, on ICOM America YouTube channel. So,
yeah,
if you run the same one a couple years, they've already seen those.
It's true. Although this one's going to have the easiest viewing capability. You know, the quality is audio and everything is much better this time, I think, probably.
So Corey, let's talk for a second about how you're going to publish the recordings. Is it just going to be one, or are you going to break it up?
Well, I don't know how long it's going to take. I know our test session that was an hour long took Zoom about 7 days to process the cloud recording. I did not record locally. When you're doing it here, I can either record to the cloud or record locally. So I recorded this to the cloud, which was good because at 4 o'clock.
Corey, you can take the recording off of YouTube and splice and dice that, because you'll have that instantly.
Yeah,
that's what I would do.
I also took a local recording as well, the whole thing, and I stopped and started it between sessions.
Okay, so you'll have it split up then. That's good.
Yep, I'll just send you a link as soon as my computer finishes transcoding it or whatever it's got to do.
Okay, so we've got a couple options, Tim. We'll kind of figure out where you want to post it, how you want to post it. If we have the link split up into the different pieces, we can put that right on the YouTube channel and go from there.
Yep.
Do we have videos on the CTU website too, Tim?
Yeah, well, we'll have the links
I
on
can
the
click on 'em.
website to those YouTubes.
Okay.
So yeah, we'll do that.
Awesome.
Hey, let me help out here. For the 600 people that are still watching, I'm begging you. There's no pizza and there's not another radio. Okay, really.
You know what this reminds me of? You remember the movie Ferris Bueller's
Day Off?
Go home. End of the movie where he says, "The movie's over. Go home."
At least go to the bathroom.
Just kicking back on the beer here, you know.
Although now with the Marvel series, everybody waits for the teaser at the very end. What's going to happen in the next movie?
Yeah. Well, yeah, you don't want to miss anything.
And no pizza tonight, but I know this great shawarma place.
So, Ed, do you have any hope of going south for a worldwide RIDI? Or is that out the window?
Sorry, what was the question, Marty?
Do you have any hope in going to P4 for worldwide RIDI?
Well, I've got plans of late. I got travel plans, but as Jeff said, it's kind of unlikely. The Aruba's, a couple miles from PJ2T, and we're locked down solid there.
We're watching it in ZF too. Okay. So same story.
Ward, what kind of beer was that you were holding up? I think I saw a red stripe earlier.
Yes, this
Cast iron.
It's red
brown
stripe,
ale.
and the reason is because right there, it's got my initials right on the front of the bottle. DG Red Stripe.
I tell you something that's funny to look at the attendees that are still hanging out. Alex,
what are they thinking?
won CWs in there 3 times, so looks like he's got a couple of robots going.
Maybe
Trying
some
to get
people
more entries for the radio.
connected from
The
different
ballot
computers.
box.
Doing SO3R.
Yeah.
Ward, you didn't hear your answer on that beer.
Cast iron brown ale. Really good. Local brewery.
It looks very dark.
I've got a cup of water locally sourced.
If it holds the pencil up, it's a little too dark, but close.
My fancy water bottle made by Zojirushi. I guess that's a JA water bottle.
Zojirushi, the famous maker of rice cookers, which you're an expert on, Bob.
Hey, Bob, how many USB ports does it have?
I'm still looking.
Where's the Y box connect? Is there a win test script for it?
Shout out,
I'm afraid.
Cal K1CAL. Nice to see you here, Cal.
K1QX is breaking tradition. He's not, or he's cooking the ranks. He's not cooking. He's drinking bourbon.
Oh. Now there's an idea.
Timmy. Must be a bottle of Makers around there somewhere.
There's strategic reserves.
So, Doug, do you think Tim has too many rotators behind him?
Where are you sitting? I can't.
10.
Oh, is that
10.
10?
All these
rotators.
rotators.
Rotators for 10. Jeez.
Yeah,
Well, he uses
they're
about
not over to 15 meters. And
Doug,
they all could be fixed on South America.
Yeah.
There's one for each meter, right? So on 160, you got like 160 boxes sitting around the radio.
looks like it, I'll
Really
say.
happy.
I did get one criticism, by the way, from my presentation. I'm surprising it was only one. I'm told that my pronunciation of Rufzeichen was an older German style of pronunciation, and was
Thank you,
inappropriate.
Sandy.
No, yeah, actually it was Sandy. Was it Sandy or was it MGB? I don't know. They were both texting me during my presentation.
That's it.
Sandy said she wanted to see my talk, but her cat didn't.
Oh yeah, Ward, I want to see that cat. Oh, there it is, right on cue.
Look at that.
That's
Huh?
Electra.
It's muted. Go ahead.
It just started raining really bad.
It's a
They
kitty.
freaked out. They won't go back outside.
Okay, I'll get him later then. Thank you.
Hey Terry, it's not muted. Let's get a close up. Let's get a close up of Electra again.
Oh, you want another?
All right.
Demanding there, Bob.
Oh.
Can you believe there is 500 people watching our shtick? Can you believe that?
There we go. There's a kitty.
Beautiful.
Hi, Bob.
Beautiful. Hello, Electra.
There you go.
We're waiting for TV Bob to go next door and show us a picture of Mr. Peppers.
It's Mr. Pickles. Mr. Pickles.
Mr. Pickles.
Yeah.
That's it.
Pickles.
Yeah, he's quarantined. He's not allowed over here.
What are you doing here?
Well, speaking of pickles, it might be time for dinner.
I think so.
This was terrific.
All right.
Thank you for
Corey,
setting it
it's
all
been
up.
a long day for you. Thanks for all you did and continue to do. And let's go ahead and shut this thing off. Pull the big switch.
All right, I'm going to end the YouTube stream. 73s, everyone. Have a great weekend. Sorry we couldn't see you at Dayton, but hey, at least got to see you here.
See you all.
Bye, guys.
Bye.
Bye.
Talk to you tomorrow, Corey.
Best regards,